world of Python, where creativity meets technology. Whether you're a beginner eager to dive into coding or a seasoned programmer looking to expand your skills, this journey has something for everyone. Please note that we've added the sessions covered in this tutorial along with timestamps in the description so you can easily jump to the topic that excites you the most. You'll be mastering the fundamentals of Python, diving deep into advanced concepts, and unlocking the secrets of powerful data structures and algorithms. Picture yourself analyzing data like a pro. But that's not all. We'll also delve into Python for automation, simplifying everyday tasks, and crafting beautiful interactive GUIs for your applications. Join us as we embark on this comprehensive Python adventure. From basics to brilliance, we've got you covered. So let's get started and code your way to mastery. In Python fundamentals, we'll start with the basics. Install in Python, understanding variables, data types, operators, and flow control statements. You'll also learn about Python's core data structures, tuples, lists, dictionaries, and sets. Next, we'll dive into advanced topics like object-oriented programming, inheritance, and exception handling. You'll also learn file handling techniques to manage your data efficiently. Understanding data structures and algorithms is key. We'll cover arrays, stacks, queues, linked lists, and essential searching and sorting algorithms like linear search, binary search, insertion sort, quicksort, and merge sort. In Python for automation, we will focus on making your life easier. You will learn to use Selenium for web automation. We will also cover GUI development using Tkinter, bringing your applications to life. Why wait? Let's quickly start with the first module. In Python fundamentals, this is where it all begins. We will start by introducing you to Python's syntax and core concepts. You will learn about variables, data types, and control structures like oops and conditionals. By the end of this section, you'll be comfortable writing simple Python programs and ready to tackle more complex challenges.
We'll start off this session by installing Python on our systems. And to install Python, we'll need to go to this particular site here, python.org downloads. Let me just go ahead and click on this link. So as you can see, since Python is platform independent, whether you have a Windows system, a Linux system, or even a Mac, you can download Python for any of these operating systems. And since I'm using a Windows system, all I have to do is click on this particular link and Python will be downloaded. Now, after downloading Python, we'll need an IDE. So what exactly is an IDE? IDE stands for Integrated Development Environment. Now, if you just download Python, we'll also need an environment that makes our coding much easier. So if you've worked with other programming languages like C, C++, or Java, then you know that you've used an IDE for those languages as well. So if you've worked with Java, then you probably used an IDE called Eclipse. Similarly, if you've worked with C or C++, then you might have used IDEs like Turbo C++ or Dev C++. In the same way, there are plenty of IDEs available for Python. So one such IDE for Python is PyCharm, and we can download PyCharm from this particular link, jetbrains.com/PyCharm. I'll just click on this over here. Then I'd have to click on this download button, and as you see, we've got the professional version and the community version. And if we want it for just single user development, we can just go ahead and download this community version over here. And likewise, as you can see here, if you're using a Windows system, you can download PyCharm for Windows. If you have a Mac, then you can download PyCharm for Mac. Similarly, if you have Linux, then you can download PyCharm for Linux. Since I have a Windows system, I'll select this and go ahead and download the community version. Next, we have something called Anaconda, which is actually a distribution for both Python and R. So if you want to do any kind of machine learning or data science work, Anaconda is a complete toolkit. It gives you a lot of tools related to Python. It'll provide you with an IDE called Jupyter Notebook, and not just the IDE. Along with the IDE, it also gives you a lot of libraries. Libraries like Matplotlib, Seaborn, Pandas, and NumPy. So you don't have to install these libraries manually. Once you go ahead and install Anaconda, you can install Anaconda from this particular site right here. Here you see the Products tab. Click on the Individual Edition, which is the open source one. Then just scroll down and you'll find the download button here again. Since I have a Windows system, I'll just go ahead and download the 64-bit graphical installer. And since this is a large file, 466 megabytes, and I don't want to use up my data pack, I'll just go ahead and cancel this because I already have Anaconda installed on my system. Now, once we've installed Anaconda, as I mentioned before, Anaconda comes with an IDE called Jupyter Notebook. So what is Jupyter? It's a browser-based interpreter that allows us to work interactively with Python. So all of our Python code will be implemented in this Jupyter Notebook. And if you need to open Jupyter Notebook, I'll just show you how to do it. So if you're at your search bar, go ahead and type in Anaconda. Then you need to select this option here, Anaconda prompt. Now, in the Anaconda prompt, you need to type Jupyter Notebook. And let's just wait for the browser-based interpreter to open up. So what you see here is called the Jupyter Notebook, which is a browser-based Python interpreter. And we'll be writing all of our Python code right here. Now, if you want to open a new Python notebook, click on this tab and select Python 3. Now, once that's done, we've opened our new notebook. In the Python notebook, you'll see a lot of tabs here. So similarly, if you want to create a new notebook, select File, then you'll see the New Notebook option. Again, you can go ahead and select Python 3. As you can see here, this is our new notebook. I'll just close this one here. Then, let's say you want to download the code file you've written, you have this Download As option. And here, normally, whenever we want to download the Jupyter Notebook, we download it as an IPYNB file, which basically stands for Python Notebook or IPython Notebook. You can also download it in other formats. If you just want to save it as a simple Python file, you can just select .py here. You can also go ahead and save this file as an HTML document or maybe a LaTeX document. And if you want to save, you have the Save As option here. Similarly, you can go ahead and rename your notebook. Either you can select this or you can just click here, then you can go ahead and rename it. So I'll just name it My Python Notebook, and then I'll rename this file here. Now let's go ahead and write our first Python program. So to print something out on the console, we have to use the print command. Then I'll add the parentheses here. I'll use double quotes, and inside them I'll type the command, "This is Sparta." Then I'll just go ahead and click Run, and as you can see, we've successfully printed out "This is Sparta." We've written our first Python program in Jupyter Notebook, and now we're on our way to happily go and hack the NASA system. So this is our building block, guys. We can go ahead and do a lot of things with what we've learned here. Now, you have something called a kernel here. So what exactly is a kernel? You can think of the kernel as the executor of this program. So whenever you write a piece of code and want to execute it, you click on kernel, and that's what actually runs your entire code. Then let's say you want to add a new cell above this. So what you see here is called a cell. And if you want to add a cell above this, you click on Insert. Then you have the Insert Cell Above option. Similarly, let's say I want to insert a cell below this, I click on Insert. I select Insert Cell Below, and that's how I can add another cell. So this was a basic intro to Jupyter Notebook. Let's start by understanding what exactly variables are in Python. Now, when you work with any programming language, your first task is to work with data, right? So whatever programming language you're using, you're basically working with data. But the question here is, how do you actually store the data you're working with? So let's say you're working at a company and you want to store the names of all the employees. So we'll start by taking 3 employee names. So let's say we have John, Sam, and Matt with us, and we need to store these names somewhere. So where can we store them? This is where a variable comes in. So you can think of a variable as your temporary storage space. Now, what we'll do is take this string value. So what you see inside double quotes is called a string, and we'll take this string value, and we will store this in a variable called student. We can call it student, employee, or whatever we want. And this variable will have a specific address associated with it. And since this variable is a temporary storage space, the values stored inside it can be changed over and over again. So at first, we're storing the value John inside this variable, whether it's called employee or student. Then after some time, we can go ahead and replace the value John with Sam. In the same way, after a while, we change the value from Sam to Matt. And this is how variables work in Python. So now let's go to Jupyter Notebook and I'll show you a proper example of this. Here, what I'll do is create a variable called var1. I use the equal sign and go ahead and store the value John inside it. Let me click on Run. Now let me print var1 and let's see what the result is. So we've successfully stored the value John inside var1 and we're able to print it out. And since var1 is a variable, it's a temporary storage space. That's why we can change the value stored inside it. So now, instead of John, I want to store the value Sam in it. I'll click on Run again. I'll use print, and then I'll print out the value of R1. And as you can see, at first we had John in it. We were able to change it to Sam. Now, again, after a while, I'll go ahead and change this value to Matt. Now, let me print var1 here. Print var1, and as you can see, at first we had John, then we changed it to Sam, and finally we've changed it to Matt. So that was a basic introduction of variables. Now, another thing to keep in mind is that every variable has a data type associated with it. So when you're working with data, that data can be in any format. So when you're working with numbers like 10, 500, minus 1000, minus 323, these are called integers. And when you work with decimal numbers, so decimal numbers like 3.14, 15.97, minus 1.92, all of these are floating point numbers. Then we have something called Boolean values. So Boolean values basically mean you only have 0 and 1. Or you can label them as true and false. So you only have two values here, and those two values are true and false. Or you can also label them as 0 and 1. Then we have strings. So strings are things you put in single quotes, double quotes, or triple quotes. So these are the four main data types here in Python. So let's go ahead and look at an example of each of these. Now I'm going to start off by creating an integer variable. So I'll name this integer variable num1 and I'll store the value 10 in it. And just to check what the data type of this is, I use the type method, and inside the type method, I'll pass in num1. As you can see, this tells us that the data type of this particular variable is integer. Then I'll go ahead and pass in a floating point number, or a decimal number. So I'll call this, let's say, decimate. And in decimate, maybe I'll store the value 3.14. Now, let me go ahead and check the type of decimate. So inside this, I'll pass in decimate. And when I click on run, you can see that this is a floating type. Then we have the next data type, which is Boolean. So here I'll have maybe another variable called log1, and inside log1, I'll store the value true. Let me hit run again, and then let me check the type of log1. So inside type, I'll pass in the variable log1, and as you can see, this tells us that it's of type bool. Bool basically means this is a Boolean or logical type, and then we've got the character or string. So this time I'll have my variable as car1, and inside this I'll store the name. Let's say I'll store the name Arjun here. Then let me check the type of car1, and when I hit run, you see that this tells us that this is a string type variable. We also have another variable here, or another data type here, which is of complex type. So complex is basically a data type where you have a real part and an imaginary part. So let's say if I write something like 3 plus 5j. Here, 3 would be your real part, and 5j would be your imaginary part. You probably learned about complex numbers in your primary or secondary school. So normally in math, this j is represented as I. So you'd have something like 3 plus 5i, where 3 would be your real part and 5 would be your imaginary part. So in Python, this I is represented with j instead of I. So now I'll go ahead and store this in a variable called comp1. Now let me go ahead and check the type of this. So type of comp1, and I see that this is of complex type. So we've successfully understood what variables are, and we've also looked at the different data types a variable can have. Now we'll move on to the next concept in Python, which is operators. And as the name suggests, operators help us perform simple operations on this data. And we've got arithmetic operators, relational operators, and logical operators. So we'll start with the first set of operators, which are the arithmetic operators. Let me go ahead and open this Jupyter notebook here. And what I'll do is clear out everything that's currently in the console. So there's the scissors icon you see here. If you click on the scissors symbol, you'll be able to cut out all of these cells. Now let me add a comment. So what is a comment? A comment is something that is not executed by the Python interpreter. And you can add a comment using this hash symbol. So after this hash symbol, I'm going ahead and writing arithmetic operators. I'll click on Run, and as you can see, this is not executed here. So whenever you add a hash symbol here, the Python interpreter automatically recognizes whatever comes after the hash symbol as a comment. Now, if I remove this hash symbol and then click on Run, you'll see that we get this arrow, which tells us that this is invalid syntax, because if we don't add the hash symbol here, then the Python interpreter would consider this. These two are actually treated as two separate variables. And since we haven't declared any variable called arithmetic or operator, that's why we're getting this error. So I'll just go ahead and add this hash here. Now, after this, since we have to perform arithmetic operations, and arithmetic operators basically include plus, we have plus, then minus, then multiplication, and then division. Now, I'll create two variables here. I'll have the first variable, num1, and I'll store the value 10 in it. Then I'll have the second variable, num2, and I'll go ahead and store the value 20 in it. Now, after creating these two variables, let me perform the basic arithmetic operations. So I'll start by adding num1 and num2. So I'll type num1 plus num2, and when I perform num1 plus num2, I get a result of 30. So basically, if you want to add two numbers, you have to use the plus symbol between those two operands, and since 10 is stored in num1 and 20 is stored in num2, we get a result of 30. Then, similarly, I'll go ahead and perform the subtraction operation. So here I'll have num1 minus num2, and when I type num1 minus num2, I get a result of minus 10, because 10 minus 20 is minus 10. Moving on, I'll also perform multiplication. And to perform multiplication, I'd have to type num1 times num2. And when I have num1 times num2 here, which is basically 10 times 20, I get a result of 200. Then we're only left with division. So to perform division, I'll have num1, then I'll use the / symbol, which stands for division. Then I'll have the second operand here, which is num2, and I'll click on Run. And as you can see, when we divide 10 by 20, we get a result of 0.5. So these were some basic arithmetic operations. Now we'll go ahead and work with relational operators. I'll also just add another comment here, and I'll label it as relational operators. So what are relational operators? These help us determine the relationship between two operands, so we can see if the value of one operand is less than the other, or maybe if one operand's value is greater than the other. So we'll have the less than symbol, greater than symbol, equal to symbol, and not equal to symbol. Now again, we'll use the same variables, num1 and num2. Let me just print out num1 and num2 here for you, and as you can see, we have 10 stored in num1 and 20 stored in num2. Now, I want to check if the value in num1 is less than the value in num2. So I'll type num1, use the less than symbol, then type num2 here and click on Run. And as you can see, I get the result as true, which means that num1 is less than 20, which makes sense because 10 is obviously less than 20. Now, I want to check if the value in num1 is greater than the value in num2. And when I hit Run, I get a false value because 10 is not greater than 20. Now, moving forward, I want to check if the value in num1 is equal to the value in num2. So what you see here is the double equals operator. You need to understand the difference between the double equals operator and the single equals operator. This is the single equals operator, and with the help of the single equals operator, we assign a value to a variable. But when we use the double equals operator, it helps us determine whether these two values, the operand on the left-hand side and the operand on the right-hand side, are equal to each other or not. And when I click Run, I get a false value, because 10 is obviously not equal to 20. Moving on, I have the not equal to operator, so I'll use num1. The not equal to operator is represented like this. I'll have an exclamation mark, then the equal symbol. Then I'll have num2 here, and I get a true result because 10 is obviously not equal to 20. So these were some of the relational operators. Moving on, we'll work with logical operators. So I'll add a comment here, which will be logical operators, and we have two logical operators, and or. Let's start with and. So and is a logical operator that will only give us a true result when both operands are true. But or is a logical operator that will give us a true result when either of the operands is true. So let's understand this in detail. This time, I'll create two Boolean variables here. I'll have log1, and in log1, I'll store the value true. Then I'll have log2, and in log2, I'll store the value false. So now I have log1 and log2 here. Now I'll perform the AND operator on both of these. So let me go ahead and type log1 and log2, and when I hit run, I get a false value because log1 is true and log2 is false. True and false will give us a false result. Now let me see what will happen when I have log2. Log what? Again, I get a false result because false and true is also false. Now let me check log2 and log2. Log2 and log2 will also give me false because false and false is also false. And finally, I'll check log1 and log1. Log1 and log1 will give me a true result because the AND operator gives a true result only when both of the operands are true. Now we'll head on to the OR operator. So this time I'll have log1 or log2. Now true or false will give me a true result because OR will give me a true result when either of the operands is true. Then I'll have log2 or log1. And this again gives me a true result because false or true is again true. Then I'll have log1 or log2, and this again, well, let me actually change this to log1 or log1, and this will give me a true result because true or true is also true. And finally, we'll have log2 or log2, and this is the only case where we'll have a false result, which is false or false. So only in the case where both of your operands are false, that's when you'll get a false result when you're working with the OR operator. So that was everything about the different types of operators in Python. Now we'll understand what exactly Python tokens are. So a Python token is the smallest meaningful component in a program. So when you combine all of these Python tokens together, that's when you get your final Python code. So the basic Python tokens are keywords, identifiers, literals, and operators. So we've already worked with operators, which are one of the tokens in Python. Now we'll go ahead and understand what keywords, identifiers, and literals are. So we'll start with Python keywords. Python keywords, as the name suggests, are special reserved words. So when I say special reserved words, it means you can't use these special reserved words for any other purpose. That means you can't use them as the name of a variable, the name of a function, or even the name of a class in Python. And here's some of these reserved keywords: if, def, del, true, false, while, not, or return. So these are some of the Python keywords. Now, let me just show you how to use these. So let's say I type def. As you can see here, when I type def, it automatically turns green. So the Python interpreter recognizes the word def as a keyword. Now, let's say I try to assign something to def, like def equals 10. I get an error because this is a keyword. I can't use this as a variable. Similarly, if I use if is also a keyword, which is why it turns green. Then we have something called identifiers. So identifiers are basically the names used for variables, functions, or objects. So up until now, we've created some variables called var1, num1, or log1. So all of those are identifiers. So the names you give to variables, functions, or objects are known as identifiers. For example, if you have a person and their name is Arjun, Sam, or Matt, so here, the names of these people are the identifiers. Similarly, just like you need a name to identify a person, you also need an identifier to understand, call, or invoke a variable, function, or object. And this is the simple analogy between real life and these Python identifiers. And there are some basic rules when you're working with these identifiers. So the first rule is that you can have an identifier with special characters. You can use an underscore, but except for the underscore, you can't have any other special characters in the name of the identifier. And also, identifiers are case sensitive. So let's say you create a variable called var1 with a lowercase v, and then you create another variable called var1 with an uppercase v, then both of them will be considered as different variables. And then there's another rule here which states that the first letter can't be a digit. So these are some basic rules that a Python coder usually keeps in mind. So let's go ahead and learn about these rules in Python. I've told you that special characters cannot be used in the name. So let's say I have a variable called jperson, and I have this here. And if I try to store the value 10 in it, let me click on run. So you see that we have a syntax error here. Similarly, what I'll do is I have a variable called n1, and inside n1, I'll store the value 10. Then I'll have another variable called capital N1, and inside this, I'll store the value 20. Now let me print both of these. N1 with a lowercase n and N1 with an uppercase N. And as you can see, both of these values are different because both of those variables are different. So this is about Python identifiers. Then we have something called literals. And literals are just constants in Python. So a constant is a value that does not change. So whatever values you are storing inside a variable, that is called a literal. So here, when you are storing 10 into N1, 10 would be a literal. Similarly, when you are storing the value 20 into N1, 20 would be your literal. Then over here, when you are storing values such as 10 into num1 and 20 into num2, again, those are your literals. Now we'll move on to an interesting topic in Python, where we'll learn about strings in Python. So what are strings? Strings are basically sequences of characters that are enclosed within single quotes, double quotes, or triple quotes. We already know this, and we've already seen an example of Python strings. So let me just give you an example of all three, where I'm creating a string with single quotes, double quotes, and triple quotes. Let me go ahead and remove all of this here, because I like to keep things clean. Let me just clear all this stuff out from here. Now, what I'll do is create a new string variable called str1, and I'll assign it a value using single quotes. And inside this, I'll just type hello world. And I'll print out string 1 here. I've successfully created the string str1 with hello world. Next, I'll have str2. And for str2, I'll create it using double quotes. Here, I'll just type this is Sparta. And I'll print out str2 here. Moving on, I'll create another variable called string3. And this time, I'll make a multi-line string. If you want to create a multi-line string, you can use triple quotes. So I'll use triple quotes here, and inside them I'll just type, I am going to France tomorrow. Let me run this and print out string 3 right now. As you can see, I've successfully created a string that says, I am going to France tomorrow. What you see as a \n indicates a new line. So after I am, we have \n, which means going to appears on a new line. Similarly, there's another \n before France tomorrow, which means that part is also on a new line. So this gives us a basic idea about strings in Python. Now that we know this, let's actually see how we can extract individual characters from a string. Here, we've created a string called myString. So the name of the variable is myString, and this is the value stored inside it. The string is, my name is John. Now, if we want to extract individual characters, we need to understand the concept of indexing. Here, these characters are located at specific indices, and the index values start from 0. So, for example, M is at index 0, Y is at index 1, and the space is at index 2. In the same way, each of these characters has a specific index assigned to it, and the index values start from 0. And if you want to extract a specific character, or the first character from a string, you need to specify the name of the string. You also need to use parentheses. Inside the parentheses, you put the index value of the character you want to extract. Since I want to extract the first character, I need to use index 0. And that's how we can extract it. Similarly, if I want to extract the last character, the index for the last character will be -1. You could manually count the last value here if you wanted, but that's basically time consuming. Instead of counting the index, if you just want to directly extract the last character, you can simply use -1, and that'll automatically give you the last character in string. So let's go ahead and perform these operations in Jupyter Notebook. Let me add a new cell here, insert cell below, and I'll go ahead and create a string called my_string right here. Let's say I'll have a string called my name is. John, if you don't mind, let me please print out my string here for a moment. Now after this, I want to extract the first character. So if I want to extract the first character, I'll just type my_string. I'll put it in parentheses. I'll write one here, but actually I need to put 0 because the first character is at index 0. So this is important. You have to remember that in Python, indexing starts from 0. So this is how I extracted the first character. Now, similarly, if I want to extract the last character, which is N, then I'll put -1 here, and as you can see, I'm able to extract the last character. Now, in the same way, let's say I want to extract this A. So that's at index 0, 1, 2, 3, and 4. It's at index number 4. So let me just put 4 here, and as you can see, I've successfully extracted this particular element from the entire string. Now we'll go ahead and work with some string functions. So the first string function is len, which will give us the length or the number of characters present in the string. So all we have to do is use len, and inside that we pass in the name of the string. So when we pass in my string, this tells us that the length of the string is 15. And similarly, let's say I want to convert all the characters in the string to lowercase, we have the lower method for that. So all I have to do is type my_string.lower, and this will convert all the characters to lowercase. And a method that's similar to lower is the upper method. So I'll type my_string.upper, and with this, I'll be able to convert all the characters to uppercase, as you can see in the result here. So I have my string ready, and now I want to check its length. Inside len, I'll pass my string, and this will tell us that the length of the string is 15. Now, similarly, as you can see here, we've got two uppercase characters. M is uppercase and J is uppercase. I'd like to convert them to lowercase. So for that, first I need to provide the string name, which is just my_string. I'll use the dot operator, then I'll use the lower method, and when I click on run, you'll see that all the characters have been converted to lowercase. Now, similarly, if I want to convert all the characters to uppercase, I'll go ahead and type my string, use the dot operator, and then write upper here. I'll click on run, and as you can see, I've converted all the characters to uppercase. Now we'll go ahead and look at some more functions. So we've got the replace method here, and we've got the count method. So if I want to replace a particular character or a particular string with another string, then we can use the replace method. So again, first we'd have to give the name of the string, which is my_string. I'll use the dot operator, then I'll use the replace method, and it takes in two parameters. The first parameter is basically the character that I want to replace. So as you see here, initially we had Y here. I want to replace that Y with A. So initially the sentence was, my name is John, but I have changed that to, my name is John. So quite an interesting method, isn't it? Then we have the count method. So here we have created a new string where we have stored the value hello, hello world. And if I want to check the count of the number of times a word occurs or the number of times a particular substring occurs, then we can just pass the substring into this method. So if I want to know the number of times the substring hello occurs in this entire string, if I pass in hello, this tells me that the substring hello occurs 2 times in the entire string here. So let's work with this replace method and the count method. So we already have this my_string variable ready, and let's say instead of my name is John, I want to change the name here. So instead of my name is John, I want to change it to my name is Sam. So I'll have my_, then I'll use the replace method here, and we already know this takes in 2 parameters. The first parameter is the substring I want to replace. So I want to replace John, and I want to replace it with, let me actually keep it like this, and I want to replace it with Sam. And when I click on run, you'll see that I have successfully changed the substring from John to Sam. Then we have the count method. Let me create this new string variable here. I'll have new_string, and inside this I'll store hello, hello world. Now that we have this, what I'll do is go ahead and use the count method. So I'll have new string and use the count method, and inside this I'll pass in hello. And when I pass in hello, this tells me that the substring hello occurs 2 times. Now we have 2 more string functions here. So now we have the find function. So the find function helps us find the index or the starting index of a particular substring. As you can see here, if I want to know the starting index value of this substring spot up, I'll just pass this entire substring into the find method, and this gives us the value 8. So let's just understand this. So now if I count, the indexes will be 0, 1, 2, 3, 4, 5, 6, 7, and 8. So as you can see, this S is placed at index number 8, and that's what the find method gives us. So let's say similarly, if I had passed S into this find method, then it would have given us the result of 0, 1, 2, 3, 4, and 5. Then we have another method called split. The split method helps us divide this string into a list of substrings based on a single split criterion. So here we've got this entire string called I like apples, mangoes, and bananas, and I want to divide this whole string into multiple substrings based on the comma. So here, whenever this method encounters a comma, it will separate or split it into a substring. So I like apples becomes one substring, mangoes becomes the second substring, and bananas becomes the third substring. Let's go ahead and implement an example of these two. Let me write string 1 here. And what I'll do is I'll just assign a new value here. Let's just say I'll type I love pizza, and I want to know the starting index of the substring pizza. So I'll use string1.find, and inside this I'll just pass in pizza, and we get the result 7. So let's just verify this. 0, 1, 2, 3, 4, 5, 6, and 7. Now we'll go ahead and work with the split method. So for that purpose, we'd have to create a new string value, and I'll name it as fruit. And here I'll just type in I like apples, guavas, and bananas, for example. And I'll also write, maybe, just to be sure, strawberries. Then I'll use the split method, fruit.split. Inside this, I'll give in a separator, which will be comma. And I've got a list of substrings. I like apples becomes one substring. Guavas becomes the next. Bananas is the next substring. And then we have strawberries as the final substring. Now we'll go ahead and work with the next data structure in Python, which is a list. So when it came to a tuple, that was an ordered collection of elements enclosed within round braces, but a list is an ordered collection of elements which is enclosed within square braces. And that is not the only difference. So tuples were immutable. That means when you created the elements inside a tuple, you couldn't change them later on. But when you create a list, you can actually change the values that are present in it. And this is how we create a list. So L1 is the name of the list I'm creating, and I'll use square brackets and store these different elements inside it. Let me delete all of these here and start fresh for the list. I'll add a new comment here, which will be list, and inside this, I'll name the object as L1. I'll use square brackets here. I'll put 1, and true. Let me print out L1, and this is our new list. Now let me go ahead and check the type of this using type. I'll pass in L1, and as you guys can see, this tells us that this is a list. Now, just like we extracted individual elements from a tuple, we can also extract individual elements from a list, and the process is the same. So here we've got all these elements, and the indexing starts from 0. So that's very important. Keep that in mind, guys. So the indexing of a list, or whatever data structure you're working with in Python, starts from 0. And if I want to extract the second element here, the index of the second element will be 1, because this is index number 0. This is index number 1. And when I pass in L1 bracket 1 close bracket, I'll be able to extract this particular element from the entire list. Similarly, if I want to extract a series of elements, so I've got all of these, and if I want to start from index number 2, so this will be index number 2. So we've got 0, 1, and 2, and this will go on up to index number 4. So as I've already told you, when it comes to Python, the outer limit is exclusive. So when we specify up to 5, we'll only be able to extract up to index number 4. That's why here we'll be extracting 2, B, and 3. Let me create L2 here and add some elements to it. I'll have 1, A, then I'll have 2, then I'll have B. After that, I'll have 3, and moving forward, I'll also have C here. I've successfully created L2. Let me print this out. And now, if I want to extract, let's say, B from this, let's see what the index would be. It'll be 0, 1, 2, and 3. So I'd have to use L2 inside the brackets. I'd have to put in 3, and I'm able to extract this particular element from it. Similarly, if I want to extract the last element, I'll use L2. I put in -1 here, and I'm able to extract the last element. And if I want to extract a series of elements, then in that case, all I have to do is use L2. And as we saw in the example, if I want to extract 2, B, and 3, the indexes for these are 0, 1, and 2. I'll put in 2 here, and if I want to extract up to 3, that would be 2, 3, and 4. So that's why I'd also have to include index number 5. And that's how we're able to extract 2, B, and 3 from this entire list. Now, let's see how we can modify a list. So we have the same list here. And initially, at index number 0, we have the element 1. But if I want to change it to some other element, all I have to do is provide the index number and assign a new value to that particular index. So as you can see, I'm assigning the value 100 to this particular index, and I'm able to change the value from 1 to 100. Now, we can also append a new element at the end, or pop the last element. To add a new element at the end, we'll use the append method. So we'd have to provide the name of the list, use the dot operator, and then use the append method. We'll just enter the value we want to append. So when I type in Sparta here, it gets appended to the end of the list. Similarly, we can go ahead and pop the last element. So if we have to pop the last element, popping basically means removing the last element. So we would have to use L1.pop, and it automatically removes the last element. So as you guys can see, we had added Sparta, but after using the pop method, this Sparta value was removed from this list. Now we have the same list over here, which is L1. Actually, let me use L2 here, not L1. Let me print out L2 for you guys here, and I want to change, let's say, this particular value right here. So let's say instead of A, I want Z. So I'll use L2, and the index for that is 1, and instead of A, I want to store Z in it. Let me print out L2 again. So initially we had but after changing it, we have Z there now. Now let's see how to append an element at the end of this list. So we'll use L2, and I'll use the dot operator. Then I'll use the append method, and inside this, I'll just add the word Python. Let me print L2 for you guys, and now I've added Python at the end. If I want to pop this out, I have to write L2.pop, and when I click Run, we see that it's been popped out. Let me print L2 again for your reference. We see that the last element has been removed. Now, there are some more modifications we can perform on the list. So let's say we want to reverse the elements present in a list. As you can see in L1, we have all these elements here. And if I want to reverse the order of these elements, all I have to do is use the reverse method. So I'll type in L1.reverse. And when I print this out, we see that the elements are printed in reverse order. Then, if we want to insert an element at a specific index value, so when we use the append method, we were able to add an element at the end of a list. But instead of adding an element at the end of a list, if we want to insert an element at a particular index, then this is how we can do it. I'll use L1.insert, then I'll specify the index position where I want to insert. So initially at index number 1, we have the value A, but now at index number 1, I want to insert Sparta. So this method takes 2 parameters. The first parameter is the index where I want to insert, and the second parameter is the value I want to insert. As you can see, I've inserted Sparta at index number 1 now. Here, as you can see, the rest of the elements have all been shifted 1 index to the right. So A, which was originally at index number 1, is now at index number 2. 2, which was originally at index number 2, has now been shifted to index number 3. So each element shifts 1 index to the right. Then we can also go ahead and sort a list. So we have all of these elements here. Now, if you want to sort these elements in alphabetical order, then we can just use the sort method, and this sort method arranges all of these alphabetically. So we have apple, followed by banana, then guava, and finally mango. So let's use the reverse method, insert method, and sort method in Jupyter Notebook. So we have the same L2 here. Now, if I want to reverse this, I'll just type L2.reverse, and when I click Run, it's executed. Now let me print L2. So as you can see, initially we had this particular sequence here, which was 1, Z, 2, B, 3, and C. And after using the reverse method, the elements have been reversed. Now we'll go ahead and add an element at a particular index. So if I want to add something at maybe index number 3, so now we've got 0, 1, 2, 3, so we've got 2, which is present at index number 3. But now let's say I'll have L2.insert, and at index number 3, I'd want to insert Great Learning, and let me hit Run and print out L2. As you guys can see, at index number 3, I have inserted Great Learning, and the elements that come after that have shifted to the right by 1 index value. Now, finally, we'll see how to sort a list. So I'll have L3, and inside this, I'll have some elements. So I'll have apple, after that I'll have mango, then let me actually change the sequence over here. So let me start off with mango first, since it's such a sweet and juicy fruit that I really enjoy. Then I'll have apple, which is always crisp and refreshing. After that, I'll add guava, known for its unique tropical flavor, and maybe lychee after that, with its delicate sweetness, if I still feel like having more. Now, this is the sequence that's present in this list, and if I want to sort it, I just have to use the sort method. So when I type L3.sort, this has to be a list and not a tuple, so it has to be square brackets. You guys have to keep that in mind. Let me change this here. Let me cut all of this out and paste it here. And as you can see, this method has been executed. And when I hit run, we've changed the order. So now we've got apple, followed by guava, then lychee. And mango is at the end. Now, we can also perform the same concatenation and repetition operations on lists as well. So here we have L1, which contains the elements 1, 2, and 3. Then we have L2, which contains the elements A, B, and C. And if I want to concatenate L2 to the end of L1, all I have to do is use the plus operator. And when I use L1 plus L2, this is what I get. I'll have 1, 2, 3, A, B, and C. And if I want to repeat the elements that are present in a list, I just need to multiply the name of the list by a specific scalar number. So as you can see, I'm multiplying L1 by 3, and I've repeated these elements 3 times. So here, I'm just going to concatenate a list, and I'll go ahead and create 2 lists here inside L1. I'll have 1, 2, and 3. Inside L2, I'll have A, B, and I'll also have C. Now I'll perform L1 plus L2, and we've appended L2 at the end of L1. So you need to understand that L1 plus L2 and L2 plus L1 will give you different results. Now when I actually type in L2 plus L1, you'll see that we've appended L1 at the end of L2. So this sequence also changes when you change the order with the plus operator here. Now let's go ahead and repeat the elements. So I'll repeat the list, and let's say if I want to repeat the elements that are present in L2, I'll just multiply L2 by, let's say, 5, because I want the elements to be repeated 5 times. So I have A, B, and C being repeated 5 times. Now we'll move on to the main component, which is about the different data structures in Python. So we have tuple, list, dictionary, and set. Let's start with the first data structure, which is a tuple. So up until now, when we've worked with single variables, you were only able to store one value or a single value inside a variable. But with the help of these different data structures like tuple, list, set, and dictionary, we'll be able to store multiple elements inside a data structure. And it's not that we can only store multiple elements of a single data type. We can also store elements of different classes or different types in this data structure. So let's start with tuple. What exactly is a tuple? It's an ordered collection of elements enclosed within parentheses, and tuples are immutable. What do I mean when I say tuples are immutable? So what this basically means is, if you create a tuple, you can't go back and change any of the values in it later on. A tuple can't be modified once you create it, and here's an example of a tuple right here. So we have parentheses, and inside the parentheses, I've stored the elements 1, A, and true. As you can see, I have elements of different types, so we can store elements of different types in a tuple. So let me create my first tuple in Jupyter Notebook. I'll type in. Let me actually do this in a fresh space. I'll add the comment tuple. Over here, I'll type in tup1. I'll use parentheses here. So the first element is 1, then I'll have Sparta, then I'll have true here, and then let me just print out tup1. So I've created this tuple. Now, let me check its type. I'll use type, and inside this, I'll pass in tup1, and this tells us that this is a tuple. Now, if I want to extract individual elements from a tuple, how can I do that? Well, the process is pretty much the same as with strings. So if we want to extract the first element from a tuple, as you can see here, I've created a tuple that contains all of these elements. 1, A, true, 2, B, false. And if I want to extract the first element, since the first element's at index number 0, I'd have to use the name of the tuple, and inside the parentheses, I'd have to provide the index value, which will be 0. And I've extracted this particular element from the entire tuple. Similarly, if I want to extract the last element, so if I want to get the last element, I just need to use -1. So in tup1, I'll use -1. And with this, I'm able to extract the last element. Now, if I want to extract a continuous sequence of elements, so here, if I want to extract true and 2, which are a continuous sequence of elements, I'd have to do something like this. So inside the parentheses, I'll put 1:4. This is the starting index value. This is the ending index value. Now, when it comes to Python, you have to remember that the ending value is exclusive, while the starting value is inclusive. So when you give 1 as the starting index value, right, we have 1, and we've extracted that element. But when you give 4, it only goes up to index number 3. That's why we've only extracted A, true, and 2. 2 is at index number 3, so we've extracted A, true, and 2. But at index number 4, we have the value B, but that's not extracted because index number 4 is exclusive. So let's go ahead and create a new tuple and extract some elements from those tuples. So what I'll do right now is create a new tuple called tup2, and let me just put some random values inside it. I'll put 1, A, true, then 2, B, and I'll add false to it. So I've created tup2. Now, if I want to extract the first element, which is obviously at index number 0, I'll just type tup2, and inside the brackets, I'll give the index value, which is 0, and as you can see, I was able to extract this particular element from the entire tuple. Now, similarly, if I want to extract the last element, I'd have to type tup2, put it in parentheses, and to extract the last element, I'd have to use -1. And if I want to extract a series of elements, let's say I want to extract true, 2, and B, so here, true is at index 2. So I'll have tup2, the starting index value is 2, and then it's 2, 3, 4, 5. Since this goes up to 5, and 5 is also included, I would have to put 6. So 0, 1, 2, 3, 4, 5. This will go up to 6. Let me hit run, and as you guys can see, I've included true, 2, B, and false. If I, let's say, want it only up to B, then that would be 2, 3, 4. And since this has to be included, I'll just put 5 here. And I've extracted only true, 2, and B. Now we'll actually try to modify a tuple. So I initially told you guys that a tuple is immutable. Now, when I say a tuple is immutable, I basically mean that whatever you store inside it can't be changed. So here I am actually trying to change the value that I had stored in a tuple. So as you guys can see, in up1, whatever element was present at index number 2, I'm trying to change it, but we get an error here, and the error is tuple object does not support item assignment. So let me just print up 2 here. I'll hit run. And let's say I want to change this particular value. So I have this is present at index 0, 1, 2, and 3, index number 3. So in tup2 at index number 3, I want to change that from 2 to 20. Let's see what we get. We get the same error. Tuple object does not support item assignment because a tuple is an immutable object. And that's why you can't go ahead and change whatever's stored inside a tuple. So we've seen that a tuple can't be modified. Now let's go ahead and perform some basic operations on the tuple. So here we have the same tuple where we have all these elements, 1, A, true, 2, B, and false. Now, if you want to find out the length of a tuple, in other words, if you want to know how many elements are in a tuple, you can just use the len method. So this will give us the number of elements present in this tuple. And as you can see here, we've got 6 elements, and that's the result right here. Next, we can also concatenate 2 tuples. That is, we can attach the elements of one tuple to the end of another tuple. So here we have tup1, which has the elements 1, 2, and 3, and then we have tup2, which has the elements 4, 5, and 6. Now, when we want to concatenate, all we have to do is use the plus sign, or the plus operator, and when we use tup1 plus tup2, we get the result 1, 2, 3, 4, 5, 6. So let's go ahead and perform these operations in Jupyter Notebook. So I'll just create the tuple again here. I have tup1, and let me add some elements. So I'll have 1, A, true, then I'll have 2, B, and then I'll also have also here. So I have created this tuple. Now if I want to check its length, all I have to do is use the len method, and inside this, I will pass in the object. As you can see, we get the result, which tells us that there are 6 elements present in this tuple. Now I'll create 2 more tuples. I have tup2 here, and inside this, I have the elements 1, 2, and 3. Moving on, I'll create another tuple named tup3, and inside this, I'll store the elements 4, 5, and 6. Now I need to perform tup2 plus tup3. Let me fix the spelling here, and as you can see, we've concatenated these elements to the end of tup2. So this was a very simple operation. Now, if we want to repeat the elements present in a tuple, that's also something we can do. So here in this tuple, we only have two elements, which are Sparta and 300. Now, if we want to repeat these elements a certain number of times, we need to multiply the tuple by a scalar number. So here, when I multiply tup1 by 3, I get Sparta 300, Sparta 300, and Sparta 300, which basically means I'm just repeating these elements 3 times. Now, we can also perform repeating and concatenating at the same time. So here we have tup1 and tup2. So first, what I'm doing is repeating the elements that are present in tup1. So here, when I use tup1 times 3, the elements are repeated 3 times. So I have Sparta 300 repeating 3 times. Then I'm attaching or concatenating tup2 to the end of this. So let me add a comment here. I'll just write repeating. These are elements in a tuple, for example, numbers or strings. Now I have this tup1 over here. Let me just print out tup1, and if I want to repeat these elements 3 times, all I have to do is type in tup1 times 3. And let's see. So as you guys can see, 1a through 2b shows up. We have it once, then the same thing is repeated a second time, and then a third time. Now, similarly, if I want the whole thing to be repeated 5 times, I would just multiply it by 5. So as you guys can see, I've repeated all of the elements 5 times. Now, we'll do repetition and concatenation at the same time. I'll add a new comment here. Repetition and concatenation. I'll have 2 tuples here. I'll have tup1 where I'll put, let's say, A and B. Then I'll have C, and I'll go ahead and create a new tuple, which will be tup2. And inside this, I'll have X, Y, and then I'll also have Z. Now, this is an interesting operation. I'll do tup1 times 3 plus tup2, and let's see the result. So as you guys can see, I've repeated the elements in tup1 3 times. So I have ABC, ABC, and ABC. Then I'm adding this to the end, and I get X, Y, and Z. So this was another simple operation. Now we also have some simple tuple functions. So if you have a tuple and you want to find out the minimum and maximum values in it, all you have to do is use the min method and the max method. So here I have these elements, and if I want to find out the minimum value present here, all I have to do is use the min method and pass the tup1 object into it. As you can see, this method tells us that the minimum value in this tuple is 1. Similarly, moving forward, we use the max method, and when we pass in tup1, it tells us that the maximum value in this tuple is 5. So I'll have tup1, and let me add some numerical values to it. I'll add some random numbers in a random order here. So I have 8, 2, 5, 1, 0, 7. Now, if I want to, I have to remove the C here. Now, if I want to find out the minimum value present in it, all I have to do is use the min method. And inside this, I'll be passing in tup1. And as you guys can see, this method tells us that the minimum value present in this tuple is 0. Similarly, if you want to find the maximum value, I'll use the max method. And again, I'll pass in tup1, and we get the result of 8. This brings us to the end of this tutorial on tuples in Python. So a dictionary is an unordered collection of key value pairs enclosed within curly braces. And a dictionary, again, is mutable. So what exactly are key value pairs? Let's look at an example of that. So here, we're creating a dictionary where we have 2 key value pairs. So the first key is apple, the second key is orange, the first value is 10, and the second value is 20. So you can also think of it this way. Let's say we have the name of the fruit and the cost of the fruit, or maybe the quantity of the fruit. So we have apple, and let's say there are 10 apples. Then we have orange, and let's say there are 20 oranges. And you'll be separating the key from the value with this colon here. Now let me just delete all of this, and let's start fresh with our dictionary. So instead of a list, I'll just type in dictionary here. And let's say I'll create this dictionary like this. Let's say my first fruit is mango, and I have 10 mangoes with me. Then I'll have apple, and let's say I have 20 apples. Then I have lychee, and I have 30 lychees.
And finally, I would have strawberry, and I would have 40 strawberries with me. Let me print out the result here. So this is our first dictionary that we've just created. And just to make sure we've actually created a dictionary, let me check its type. So type of fruit would tell us that this is of dict type, which basically means it's a dictionary. Now, once we've created a dictionary, we can actually go ahead and extract the individual keys and values that are present here. So this is our dictionary. And if you want to extract only the keys, so what you see on the left side of the colon, those are our keys. And if you want to extract only the keys, all you have to do is use the name of the dictionary, follow it with the keys method, and you'll get all the keys present in this dictionary. Similarly, if you want to extract all the values, you would use the values method. So when I type in fruit.values, I'm able to extract all the values that are present here. So I have fruit, which is a dictionary that's already there, and if I want to extract all the keys, I'll just go ahead and use the keys method, and as you can see, I'm able to extract all the keys that are present. Similarly, if I want to extract the values, I'll type in fruit.values and I've extracted all the values that are present. Now, since a dictionary is mutable, we can modify it. That means we can add a new element or change an existing one. So here we only had 4 elements, but if I want to add a 5th element, so here we don't have mango at first, but if I want to add mango, all I have to do is use the name of the dictionary. Then inside parentheses, I'll add the new key. So what you see inside the parentheses, I'm adding the new key and assigning a value to it. As you can see, I've attached this new key value pair at the end of the dictionary. Similarly, if I want to change an existing element, so initially the value of apple was 10, but if I want to change that value, then inside the parentheses, I'll just provide the key and assign a new value to it. So initially we had 10, now we've modified it to 100. Now let's see how to add a new element. So I have fruit over here, let me just print it out. We have 4 elements. Now let me add a new element to this. So I'll have fruit, I'll use the square brackets, and let's say the new fruit I'm adding is guava, and let's say I have 50 guavas with me. Let me print out fruit right now, and let's check the results. As you can see, we've attached this new key value pair at the end of the dictionary. And finally, let's actually see how we can modify an existing element. So let's say I want to modify this particular key value pair. I have lychee, and the value of lychee is 30. So I'll have fruit, and inside this, I'll provide the key, which is lychee, and I want to change 30 to 300. I'll just assign 300 to this, and let me print it out. As you can see, the value was initially 30, and I've successfully changed it to 300. Now, we'll go ahead and work with some dictionary functions. So let's say we have 2 dictionaries here, fruit 1 and fruit 2. In fruit 1, we have apple and orange. In fruit 2, we have banana and guava. If I want to append the elements of fruit 2 to fruit 1, or in other words, if you want to concatenate the values from fruit 2 into fruit 1, all you have to do is use the update method. So I have fruit 1, and I'll use the update method and pass fruit 2 into it. So as you can see, we've appended banana and guava to the end of fruit 1. Similarly, we can go ahead and pop an element from a dictionary. So if we want to pop any key value pair, so inside the pop method, we need to provide the key we want to pop. For example, we had orange, but I don't really like oranges, so I went ahead and popped out orange. As you can see, orange is no longer present in this particular list. Now, let's create 2 more dictionaries. I have fruit 1, and I'll put 2 fruits in it. I'll start with mango, and I have 10 mangoes. Then I'll add apple, and maybe I have 20 apples. Then I'll have fruit 2, and in fruit 2, let's say I'll start with guava, and I have 30 guavas. Then, moving on, I'll add lychee, and I'll have 40 lychees. So, I've created these 2 dictionaries. Looks like we've made a mistake here. Let's actually check what that mistake is. So instead of the equal sign, I need to use a colon here. That's important. So I've created fruit 1 and fruit 2. Let me print out fruit 1 and fruit 2 for you. And once we've printed these 2, let me go ahead and actually append the values from fruit 2 to fruit 1. So for this, I need to use fruit 1. Then I'll use the dot operator here. And after that, I'll use the update method. And inside the update method, I'll be passing in fruit 2. Let me print it out. Let me close this first. Now, let me go ahead and print out fruit 1. Now, as you can see, I've appended the values from fruit 2 to fruit 1. Now, we already have fruit 1, but let's say I want to pop something out of it. So let's say I want to pop out the value for lychee from this. I'll use fruit1. Then I'll use the pop method. So fruit1.pop. So we have an error because we'd actually have to give a key inside this. So because I'd want to pop out lychee, I'll give in lychee over here, and we have successfully popped out lychee from this. Now we'll head on to the last data structure in Python, which is set. So set is an unordered and unindexed collection of elements enclosed within square braces. So when we say unordered, it means that whatever sequence you insert the elements into a set, that particular order doesn't stay the same. And also, when we say it's not indexed, you can't extract elements from a set using a specific index value because there's no proper ordering. Also, you have to keep in mind that in a set, duplicates are not allowed, so you can't have the same element twice. But if you actually give the same element twice, what happens is the set only takes it once. We're creating a particular set here, and if you want to add a new element to it, so initially we're creating this set where we have all these elements: 1, A, true, 2, B, and false. If I want to add a new element at the end or somewhere in this set, I'll just use s1.add, and that's how we can insert a new element into it. Now, let's say instead of adding just one element, if I want to add multiple elements at the same time, instead of the add method, we'll use the update method. With the update method, I'm passing in this list of values, which are 10, 20, and 30. As you guys can see, I've inserted 10, 20, and 30 into this set. But again, you have to keep in mind that the order is not maintained in a set, so these are inserted randomly. If you want to remove a particular element, you can just use the remove method and pass in the element you want to remove. Again, since there's no indexing, you can't remove elements by index value. You have to explicitly give the value you want to remove. So let's create our first set. I'll have S1, I'll just add some elements here. I'll have A, B, C, D, and F. Let me print out S1 for your reference, and this is what we have. Now, let's say I add some duplicates into this, and let's see what happens. So I'll have A repeating 3 times, then I'll have B also repeating twice, and then I'll have C repeating twice. Now, if I print this out, as you guys can see, we only have A, B, C, D, and F. Even though A is repeated 3 times, we'll only have one unique value of A. Similarly, even though B and C are repeated twice, we'll only have one unique value of B. Now, if I want to go ahead and add a new element to this, I'll use the add method. So s1.add, and inside this, I'll just add Sparta. So when I use s1.add open parenthesis, quote Sparta, close parenthesis, and then print s1, we've inserted Sparta here. Similarly, if you want to pop something out or remove something, we'll have to use the remove method. So I'll have s1.remove here, and inside this, let's say I want to remove the element E, I'll just pass in E here. And let me print out s1 again. So we've successfully removed the element E from this entire set. Now we'll work with some set functions. So here we have 2 sets, S1 and S2. In S1, we have the elements 1, 2, and 3. In S2, we have the elements A, B, and C. Now, if we want to combine all of the elements present in S1 and S2, then we can use the union operator. So S1.union S2 will give us a union of S1 and S2. And as you guys can see in the result, we have 1, 2, 3, A, and C. Similarly, we have 2 sets here. And if you want only the common elements that are present in both sets. So here we have 1 to 6, and here we have 5 to 9. If you want the common elements, I would use the intersection method. So when I use S1.intersection, you'll see that we have 5 and 6 in common between S1 and S2, and that's the result we get. Here I have S1, and in this I'll have 1, 2, and 3. I'll have S2, in which I'll store 4, 5, and 6. Now let me use the union operator, so I'll have S1.union, and inside this I'll be passing in S2. As you can see, I've appended 4, 5, 6 at the end of S1. Now, similarly, if I want to find out the common elements, let me make some modifications in S1. So in S1, let's say I have 1, 2, 3, 4, and 5. And in S2, let's say I have the elements 4, 5, 6, 7, and 8. Now, if I want to find out the common elements that are present in S1 and S2, I'll use S1.intersection, and inside this, I'll be passing in S2. And it looks like we have an error here. So this has to be intersection and not intersect. Let me click on ride. So as you guys can see, by using the intersection operator, we get the common elements, which are 4 and 5. Now we'll learn about flow control statements in Python, and within flow control statements, we'll cover decision-making statements and looping statements. We'll start with decision-making statements, and as you can tell from the name itself, decision-making statements help us make a decision based on a condition. And we have a great example right here in front of us. So let's say you want to play football, but it's actually raining outside. So the condition here is, if it's raining outside, then you can't play. You'd have to stay inside. On the other hand, if it's not raining, if it's not raining, then you can go out and play football. So this is a great example of an if-else statement. Now let's look at another example. Let's say you have your main exam coming up and you go ahead and take a mock exam. And in that mock exam, if you score more than 70 marks, then your parents tell you they'll buy you an ice cream. But on the other hand, if you score less than 70 marks, then you'll have to take another mock test. So this is again an example of an if-else statement. So now that we've understood how if-else statements work, let's go to Jupyter Notebook and implement them. So here we have two variables, A and B. We've stored the value 10 in A and 20 in B, and we're trying to check if the value of B is greater than the value of B. That is, we're checking if 20 is greater than 10, and if that evaluates to true, we'll just go ahead and print out B is greater than A. And this is the syntax, as you can see. You use the keyword if, followed by the condition, and in the condition, we're checking if B is greater than A. So is 20 greater than 10? That evaluates to true, and since that's the case, when I hit run, I'll get this result. B is greater than A. Now let me change the condition here. So instead of checking if B is greater than A, I want to check if the value in A is greater than the value in B. So I'm basically checking if 10 is greater than 20, and obviously this evaluates to false. Since that's the case, whatever is inside the body of this if statement will be skipped, and when I hit run, you'll see that I won't get any result here because it evaluated to false. So whenever an if statement evaluates to false, you need something else. That's why we have this else keyword here. So here we're checking if A is greater than B. And since this has been evaluated to false, I'll add an else keyword here and print out whatever should happen. Since this is false, I would have to print out B is greater than A. And when I run this, you'll see that I get B is greater than A, which is actually correct. So that's about the if-else condition. Then we have another variation of if-else, which is if-elif-else. So with this, we can compare multiple variables at once, or we can have multiple conditions together. This time, I want to find the greatest value among three values. So I have three variables here, A, B, and C. I'm assigning the value 10 to A, 20 to B, and 30 to C. Once I've done that, using if, I start by checking if the value of A is greater than B, and also if the value of A is greater than C. So as you can see here, I'm giving two conditions, and those two conditions are joined using the AND operator. If A is greater than B, and A is greater than C, and if that's the case, I'll go ahead and print out that A is the greatest.
And if either of these evaluates to false, then with the AND operator, you know that if either one is false or both are false, this part will be skipped. So here, if A is greater than B, we're checking if 10 is greater than 20, which is obviously false. And here we're checking if A is greater than C. So is 10 greater than 30? That's also false. So false and false will be evaluated as false. And that's why we'll be skipping this particular line. Then we'll move on to LF. And this time, we're checking if B is greater than A and B is greater than C. So B is greater than A, 20 is greater than 10. This evaluates to true. After that, we're checking if 20 is greater than 30. This evaluates to false. So true and false is, again, false. And that's why we'll skip this as well. And finally, we'll reach the last else statement and just go ahead and print that C is the greatest. So that's about if, elif, and else. Next, we can also use the if statement with a tuple. So here, we've created a tuple with three elements, A, B, and C. And once we've created this tuple, I'm trying to check if the element A is present in this tuple. So here, if A is in tup1, then I go ahead and print out
A is present in tup1. And as you can see, since this evaluates to true, in other words, since this element is present in the tuple, I'm able to print out A is present in tup1. Now, on the other hand, if I want to check if an element Z is present in this tuple, so here I have if Z in tup1, print Z is present in tup1, and as you can see, I do not get any output because this element is not present. So here, what I'll do is add an else statement to the code, and then print out the message Z is not present in tup1. This time, I'll get a result because the condition evaluates to false, and as a result, it will print whatever is inside the else block. And this time, we're going ahead and using the if statement with a list. So again, we're creating a list L1 here, and we have these three elements, A, B, and C. This time, what we're doing is checking if the value at the 0th index of this list is equal to A. And if that value is A, I want to change that value to 100. So I check if L1 at 0 is equal to A, and if so, I'm assigning a new value here, which is 100. After I run this, you'll see that initially the value is A, and I've changed that value to 100. Now, let's say I execute this again, and if I want to change this value from A to Z, I'll just put Z here. And you'll see that initially the value is A, and this time I've changed the value to Z. And finally, we'll be applying the if statement with a dictionary. So here we've created a dictionary D1 where we have three key value pairs, K1, K2, and K3. The value at K1 is 10, the value at K2 is 20, and the value at K3 is 30. And with the help of the if statement, I'm adding 100 more to the first key here. So the condition is if D1 of K1 is equal to 10. I'm checking if the value for the key K1 is equal to 10, then I'll add 100 more to it by using this condition. So D1 of K1 equals D1 of K1 plus 100. So I have an error here. I need to initialize D1, and as you can see, the initial values were 10, 20, and 30. After using the if condition, I added 100 more to the first value of the first key. So those were decision-making statements. Now we'll move on to looping statements, which are used to repeat a task a certain number of times. And again, we have a really great example here. Let's say you have a bucket and you want to fill it up using a mug of water. Now imagine that both the mug and the bucket are empty at this point. First, you'll fill the mug and pour that water into the bucket. Then you'll check if the bucket is full or not. After that, you'll take another mug full of water and pour it into the bucket again. Again, you'll check if the bucket is full or not. Then, once again, you'll take a mug full of water and pour it into the bucket. And again, you'll check if the bucket is full or not. This process continues until the bucket is completely filled with water. And it'll only stop when the bucket is full. So what you're doing here is looping, or repeating the same task over and over until a condition is met. We have another example here. Let's say you're listening to your favorite song and you put it on repeat. So here, the condition is that the same song will keep playing until you either close the app or maybe turn off your phone. So that's the condition here. The song stays on loop until you close the app, stop the song, or maybe turn off your phone. Then we have a very interesting example. So at the end of every month, your salary amount gets credited to your account. So what's happening here is if the date is the 30th or 31st, and it's the last day of the month, your salary will be credited to your bank account. This also happens in a loop. So these are some examples of looping statements. And in Python, we have two types of looping statements, for and while. We'll be working with both of them. So let's go ahead and start with the for loop. Here, we've created a list called fruits that contains these three fruits, apple, mango, and banana. Now, using this for loop, I want to print out each individual element that's present here. So I'll write, for I in fruits, print I. So here, what happens is, initially, the value of I will be apple. Then the value of I will be mango. Then the value of it will be banana. And this will end once it reaches the last element in the list. And that's how we're printing out each element that's present in this list. So this is a very simple example of how we can use a for loop. Then we can also have a nested for loop, where we have one for loop inside another. And here we have two lists again. We have one list made up of different colors and another list made up of different items. So the colors are blue, green, and yellow, and the items are book, ball, and chair. And what I'm doing is I haven't outer for loop that helps me pick a color. So here it's for I in color. Then inside the outer for loop, I have an inner for loop that goes for j an item, which helps me choose an item, and I print out ij. Let's understand how this for loop works here. So initially, the value of I is blue, and we enter the for loop, and the value of j here will be book. So when I print out ij, it will be blue book. Then the value of j is incremented, it becomes ball, and I print out blue ball. Again, the value of j is incremented, it becomes chair, then I print out blue chair. Then I go back to the outer loop, and blue is incremented, so the color becomes green. Then I have green book, green ball, green chair. Again, after this, the value of green becomes yellow. And I print out yellow book, yellow ball, and yellow chair. This is how you can work with a nested for loop. After the for loop, we have the while loop. So the while loop, again, helps us repeat a particular task. And this task is repeated based on a condition. Here, I'm trying to print out the first 10 numbers using a while loop. Here, I have initialized a variable called I and assigned the value 1 to this variable. After that, I'm checking if the value of I is less than or equal to 10. And if the value of I is less than or equal to 10, I enter this while loop and print out I. Then I increment the value of I. So let's understand what's happening in this while loop. Initially, the value of I is equal to 1. So the condition is 1 less than or equal to 10? And since that's true, I go inside the for loop, print out 1, then the value of I is incremented and becomes 2. Then I go back and check if 2 is less than or equal to 10. This is true again. I go back, print out 2, then increment the value of I, and it becomes 3. Then I check if 3 is less than or equal to 10. This is true again. I go back into the while loop, print out 3, then the value of I is incremented and becomes 4. Then again, I check if 4 is less than or equal to 10. This is true. I come back into the while loop. I print out 4. Then I increment the value of fetch. It becomes 5. Then we continue in the same way until the value of I is equal to 10. When the value of I is 10, I check if 10 is less than or equal to 10. And this condition is true. I print out 10 here. After that, I have I plus 1. The value of I becomes 11. And this time, when I check if 11 is less than or equal to 10, this condition fails. And that's when I exit this while loop. And this is the result I get here. Similarly, if I want the first 15 numbers instead of the first 10, I just go ahead and change this value here. And you'll see that I've printed out the first 15 numbers. Now, using the while loop, I can also go ahead and print the 2 times table. Here, I have it. I'm assigning the value 1 to I. Then I have a new variable called n, and I'm assigning the value 2 to this new variable. In the while loop, again, the condition is while I is less than or equal to 10. And while this condition is true, I will print out n times I equals n times I. Then I increment the value of I. So let's again understand what's happening inside the while loop. Initially, the value of I is 1, so the condition will be while 1 is less than or equal to 10, which is true. I come back here and print out n times I, which will be 2 times 1 equals 2. So I print this out, then I increment the value of I, and it becomes 2. Is 2 less than or equal to 10? Yes, that's true, so I go inside. This time I print out 2 times 2 equals 4. Then the value of I is incremented and becomes 3. So is 3 less than or equal to 10? That's also true. So this time I'll have 2 times 3, which equals 6, and I print that out. This process continues until the value of I is equal to 10. When I is 10 less than or equal to 10? That's true, so here it will be 2 times 10 equals 20, and we'll print that out. After that, when we increment the value of I, it becomes 11. So is 11 less than or equal to 10? That's false, and that's when we exit this while loop. So these were some examples using the while loop. Now we'll also see how to apply this while loop to a list. Here we have this list L1 with all these numbers, 1, 2, 3, 4, and 5. I want to add 100 to each individual element of this list. So I start off by initializing this variable I. I give it the value of 0, and this while loop will continue until it reaches the length of the list, or in other words, the number of elements in the list. So what is the length? It'll be 1, 2, 3, 4, and 5. Initially, the value of I is 0. So we're checking if 0 is less than 5, which is true. We enter the while loop. Here, it'll be L1 at index 0 equals L1 at index 0 plus 100. So it'll be 1 plus 100. We'll print out 1 plus 100 here. Then we increment the value of I. It becomes 1, so it's 1 less than 5. That's true. So here we'll have L1 at index 1 equals L1 at index 1 plus 100. So it'll be 2 plus 100, which will become 102. And that's how we'll continue. And print out or add 100 to each element of this list.
Now that we've built a strong foundation, let's take your skills to the next level. It's time for advanced Python concepts. Get ready to dive into object-oriented programming, inheritance, and exception handling, along with efficient file handling techniques.
Now we'll move on to one of the most important concepts in Python, which is object-oriented programming. Now, when you look around, you'll notice that you're surrounded by objects. The laptop in front of you is an object. The phone in your hand is also an object. The bottle next to you is, again, an object. Now, if you want to represent all these real-world objects in programming, you need an object-oriented programming language. So there are many object-oriented programming languages, and Python is also an object-oriented programming language because it lets us represent all these real-world entities in the programming world. Now, to understand the concept of object-oriented programming, we need to understand its two main components: classes, and of course, objects. So let's start with this term called class. So what exactly is a class? Simply put, you can think of a class as your template or blueprint for real-world entities. And we have a very simple example right here. Let's take the example of a phone. Now, when we talk about a phone again has two things associated with it. It'll have some properties, and it'll have certain behaviors associated with it. Now, when I say properties, the phone will have a color associated with it. The phone will have a cost associated with it, and the phone will also have a certain battery life associated with it. And along with these properties, when I say a phone will have certain behaviors associated with it, now what do I mean by behaviors? I simply mean that with a phone, you can make calls, you can watch certain videos on it, and some phones even let you play games. So this class, this phone class, has properties and behaviors associated with it. And what exactly is a class in Python? You can think of a class as a user-defined data type. Just like we have predefined data types like integer, float, boolean, and string, we can define our own data types using classes. So just like these predefined data types, we can create a user-defined data type, and that user-defined data type is called a class. So here, what we're doing is creating this class, a user-defined data type called mobile, and this user-defined data type will have attributes and methods inside it. These attributes are simply the properties of the class, and these methods are simply the behaviors of the class. Now that this is clear, let's move on to the next component of object-oriented programming, which is the object. So we already know what a class is. Now, an object is simply a specific instance of a class. So when we talk about having a mobile class, the specific instances of this mobile class are Apple, Motorola, and Samsung. So Apple, Motorola, and Samsung would be objects of this class, phone or mobile. And if you want examples of what exactly an object is, so just like we have these predefined data types, like integers, so A is an integer variable, and I'm storing the value 10 in it. Similarly, B is an integer variable, and I'm storing the value 20 in it. In the same way, if we have a mobile data type, then for this mobile data type, we have the objects Apple, Motorola, and Samsung. So that was a brief introduction to object-oriented programming. Now, let's see how we can actually create a class in Python. So to create a class in Python, we need to start by using the keyword class. Then, moving forward, we'll give the class a name. And by convention, you should remember that the name of the class should start with a capital letter, the first letter. It has to be capitalized, which is why we've used a capital P here. So the name of this class is phone, and inside it, we're defining two methods. So with the help of these methods, we can define the behavior of this class. So I have this first method called makeCall, and inside this method, I'm just printing out making phone call. And as you can see, this method takes a parameter called self. For now, just understand that with the help of this self parameter, you'll be able to access the attributes that are present in this class. Just keep this in mind for now, and as we go further into object-oriented programming, it will become much clearer to you all. So just like we created this method, we'll also create another method called playGame, which again takes one parameter, self, and all I'm doing inside is printing out playing game. Now that I've created my blueprint or my class here, I need to create a specific instance of it. Or in other words, I need to create an object of this phone class. So I'll just write phone here and store it in this object called P1. And now that I have an object of this class, I can go ahead and call the methods that are present in this class using this object. So when I type in p1.make_call, with this, I'll be able to call this method and it will print out making phone call. Similarly, when I call p1.playGame, I'm invoking this method and it prints out playing game. So this is how we can create a class and an object in Python. So let's go to Jupyter Notebook and try this example out. So my task would be to create a class. So I'll have a class. I'll name the class phone. I'll put a colon here. And after this, I need to create a method. To create a method, we already know that we'll use the def keyword, and I'll name this method makeCall. And we know that this takes only one parameter, which is self. And inside this, I'll simply have a print statement that says making a phone call. Once I have this method, I'll go ahead and create another method here. I'll call this method playGame. So def playGame, and I'll have self here again as the parameter. I'll add a print statement here as well, and I'll write playing a game. So I've created my phone class here. And now that I've created this phone class, I need to create an object of it. So here, I'll have p1 equals phone. So I need to put parentheses here. And this is how I'm creating an object of this phone class. And now that I have the object ready, I can use the dot operator to call both of these methods. So I'll start by calling the makeCall method. So I'll write makeCall. And when I hit run, you'll see that it successfully prints out making a phone call. Similarly, now when I use p1.playGame, you'll see that it prints out playing a game. So we've created our first class, and we've also created an object for this class. And now, in the methods that were present in the previous class, there were no additional parameters. We only had one parameter called self, and with the help of that self parameter, we were just able to access the attributes that are present. And actually, we didn't have any attributes in the previous class. So we're going to change that. So in our phone class, or rather in the methods present in our phone class, we're going to add some additional attributes. So here, we're adding a new method called setColor. And this setColor method here takes in two parameters. The first parameter is self, because that's required. Then we'll have this new attribute called color. And with this color parameter, what I'm doing is creating an attribute called color and assigning this color to the color attribute in my phone class. Similarly, I have another method called setCost. This also has two parameters. Self, because, again, it's required, and then we have this additional parameter called cost. I'll also have an attribute called cost in the phone class. And what I'm doing is assigning this value of cost to my cost attribute in the phone class. So now that I've assigned the values of color and cost to my attributes, what I need to do is display the value of color and display the value of cost. So now that I've set these, I need two methods to show the color and show the cost. That's why I'll create a new method called showColor, and this only has the self parameter here because I'm not assigning anything. I'm just returning the value. To return the value, I'll just use the return keyword and write return self.color. Similarly, if I need to return the cost, I'll have a new method called showCost. This also takes only one parameter, which is self, and I'll go ahead and return it here. As you can see, I'll have return self.cost, and these are the additional methods I have. Then I have the same methods, which are makeCall and playGame, and inside makeCall, all we're doing is printing out making a phone call, and inside playGame, all we're doing is printing out playing a game. So let's go ahead and modify our phone class, which we created earlier. I'll delete these records from here. Let me cut this whole thing, or actually, I can just write it right here. So these are the methods that were present earlier. I'll need to add 4 more methods to this. So to create a method, we need to use the def keyword, and I'll need to set a color attribute. So I'll use this method called setColor. The first parameter itself is required. Then I'll have this additional parameter called color, and I'm assigning the value of this color to the attribute color by using the self attribute or self parameter, which I've passed in. Now, in the same way, I'll have another method here. So just like I set the color, I also need to set the cost. So def, I'll have a new method called setCost. This will take in 2 parameters. The first parameter will be self, and the second parameter will be cost. And here, I'll write self. Cost equals cost, and this is how I'm assigning the value of cost. After this, to print out the value of color and cost, I would need a method called showColor, and the parameter will only be self. And what this does is it will just return the color, so it will be self color. Then I would need another method called showCost, and this again would take in only one parameter, which is self, and with this I'm returning the cost. So here I will have self.cost. So these are the 4 additional methods that I have added inside this. So it seems that we have an error here. Let me see what exactly this is. So this is line number 7, and this is set.cost. So here, I actually need to put a comma instead of a period there. And now we see that we've successfully created this. Now, after creating this class, I need to create an object. So I will have P1 equals phone. And now that I've created this object, with the help of this object, I can access these methods and assign values to the color and cost. So I'll just call P1 dot set color, and I'll set the color of this phone to blue. Similarly, I'll also set its cost, so I'll have P1 dot set cost, and I'll set the cost to, let's say, $999. Now that I've set the values for color and cost, I can print out these 2 values. So let me delete this, and I'll have P1.showColor. Now when I hit run, you'll see that the color is blue. Similarly, when I use P1.showCost, you'll see that the cost is $999. So this is how we can add extra attributes and assign values to those attributes, which belong to a class, with the help of these additional parameters. Now, there's a special example or a special concept in object-oriented programming known as a constructor. So if you've worked with other languages like C++ or Java, and if you've learned about the concept of inheritance, you would know about a constructor. Normally, in C++ or Java, a constructor is a special method that has the same name as the class. And this helps us initialize the values of the attributes right when the object is created. So that's what a constructor is in Python. It's just that in Python, the constructor's method name is not the same as the class name. In Python, the constructor is called the init method. So here, as you can see, this is our constructor. We have our init method right here, and I have def, so in init we have 2 underscores as a prefix, and also 2 underscores after init here. So our constructor's ready, and as I mentioned, with the help of a constructor, we'll be able to assign values to the attributes during object creation itself. So obviously, we'll have some parameters inside this, and with the help of these parameters, we'll be able to assign values to the attributes. So in this employee class, let's say I have 4 attributes called name, age, salary, and gender. So I have these 4 additional parameters here, and I'm assigning the value of name to this attribute. Similarly, I'm assigning the values of age, salary, and gender. Now that the constructor's ready and have assigned the values, I need to display those values. And to display the values, I have this new method called employee details. I'll create this method like this. So I'll have def employee details, and I'll pass in self here because I'm not assigning anything. And this is the default, we definitely have to include that self parameter here. And inside this method, I'm just printing out the employee's name, age, salary, and gender. And once we create this class, we'll go ahead and create an object from it. So here, when we're creating an object, as you can see, we have E1 equals employee. And during the instantiation of the object itself, as you can see, I'm passing in the values for all the attributes. So here, I'm assigning the name as Sam. Similarly, I'm setting the age to 32, then the salary to 85,000, and the gender to male. This is how I'm assigning all the values during the instantiation of the object. And once I have created the object, and since I have also provided all the values for the attributes, I can directly call the employee details method. And when I call the employee details method, you'll see that I'm able to print out all the details. The name of the employee is Sam, the age of the employee is 32, the salary of the employee is 85,000, and the gender of the employee is male. So let's go to Jupyter Notebook and implement this concept of a constructor. So I'll just add this comment here, constructor. And I'll create this new class. So I'll have a class called employee, and inside it, I'll go ahead and create the init method, def. I'll have 2 underscores, then I'll write init. Then again, I'll add 2 more underscores here. So I'll start by adding the self attribute inside this. Then I'll start by adding the name attribute. Then I'll include that as well, age of the employee. After this, I'll add the salary. Then finally, we have the gender of the employee. All I have to do is assign these parameters to the attributes that are present. So I'll have self.name equals name, self.age equals age, self-salary equals salary, and self-gender equals gender. So I've created this constructor here. After this, I need to create a new method called show_employee details. Let me just write down the name of this method. So I'll have show_employee details, and this will have only one parameter, which will be self. Inside this method, I'm going to print out all the values of the different attributes that are present. So I'll start off by printing the name. So I'll have name of the employee is, I'll have self.name. Then I will have age of the employee is. Here I'll have self.age. Then I will have salary of the employee is. Here I will have self.salary. Salary. And finally, I will have gender of the employee is, and here I will have self.gender. So let me hit run, and I have successfully created this class where I have a constructor inside it. Now I can go ahead and create an object of this. So I'll have E1 over here, and what I will do is I'll use the name of this class, which is employee. The first value inside should be the name of the person. So let's say this employee's name is Sam, then Sam is 28 years old, and let's say Sam earns around $75,000. Let's set it to $75,000, and Sam is male. So I've created this object here. Now that I have assigned all of the values, I can go ahead and invoke the showEmployeeDetails method. Here I will use e1.showEmployeeDetails, and when I invoke this, you'll see that I get this result. Name of the employee? Sam. Age of the employee is 28. Salary of the employee is $75,000, and gender of the employee is male. Now we'll understand the concept of inheritance. So, simply put, inheritance is when you derive some properties from something else. And a real-world example of inheritance would be that you inherit some of your features from your parents. And your parents inherit some of their features from your grandparents. Or in other words, let's say you kind of look like your parents, and your parents might look like your grandparents in some way. So you're inheriting some physical features from your parents. Now, if we have to relate this concept of inheritance to Python, it basically means that we will have a child class and a parent class. And the child class would inherit some or all of the features from the parent class. And we have an example of inheritance right here. So what we're doing is starting off by creating the parent class. So the parent class is called vehicle. So we will have a class called vehicle. And inside this, I have 2 methods. The first method is the default constructor. And in this constructor, I have 2 additional parameters, which are mileage and cost. And I am assigning the value of mileage, then I am also assigning the value of cost. Once this is done, I will go ahead and create another method called showUnderDetails, and inside showDetails, I am printing out I am a vehicle. Then I will go ahead and print out the mileage of the vehicle, and also I will print out the cost of the vehicle. So now that the parent class is ready, I would have to create an object of the parent class. So here I have v1 equals vehicle, and I pass in 500 and 500. So this 500 would represent the mileage of this vehicle. So this basically might mean 500 miles per gallon. Then we have the cost, which is 500 again. So this would mean that the cost of this vehicle is $500. So now that we have created this object, we can directly call the show_details method with this object. So I have v1.showDetails, and as you can see in the result, I'm a vehicle, the mileage of the vehicle is 500, and the cost of the vehicle is 500. Let's go to Jupyter Notebook and implement this. Let me delete all of these previous examples from here. Let me keep it fresh, and I'll create this new vehicle or new class called vehicle here. We'll start off by creating the constructor. I would need the init method here, and the first parameter is obviously self. After that, I would need the mileage of the vehicle, and I would also need the cost of the vehicle. Then I'll go ahead and set these 2 values. So I'll have self.mileage equals mileage. After this, I'll have self.cost equals cost. Now that I've created this constructor, I need to show the details. So I will have show vehicle over here. This method would just have one single parameter, which is self, and inside this method, I'll go ahead and print out some basic things about the object. So first of all, I'll print out the message, I am a vehicle. Then I'll go ahead and print out mileage of the vehicle is, and here I'll have self.mileage, which refers to the mileage attribute of the object. After that, I'll go ahead and print out the cost. So I'll have cost of the vehicle is, and here I'll have self-cost, which is the cost attribute of the vehicle object. And this is essentially how I've created this class, step by step. After creating this class, I would have to create an object of it. So I'll have v1 equals vehicle, and inside this, I would have to pass in the mileage value first. So let's say, for example, this vehicle gives me around 120 miles per gallon, and the cost of this vehicle is around $800. So I've set these values here for the object. Then I can just go ahead and invoke the showVehicle method. So here I'll have v1.showVehicle. And when I run this, we have an error here. Let's try to understand exactly what this error is. So we have self. Now let's take a closer look at what might be causing this error and see how we can fix it in our code. Mileage, we have self. Cost inside this vehicle object has no attribute mileage, so I'm setting mileg. Let me keep it over here. Now when I run this, so as you see, I have successfully printed out I'm a vehicle, mileage of the vehicle is 120, and cost of the vehicle is 800. So we have created our parent class. Now it's time to go ahead and create our child class. So to create the child class, we'll once again go ahead and give this class a name, which is car. So we'll have a class called car, and to inherit something, we put it inside the parentheses. So as you can see, this class didn't have any parentheses here, but for the child class, we'll add parentheses. And inside those, we'll pass in the name of the parent class, which is vehicle. And this child class will have a method of its own, which is showCar. This takes only one parameter, which is self. And I'm going ahead and print out. I am a car with this method. Now once I create this child class, I will create an object of it, which is C1. Now here, as you can see, even though I don't have a constructor inside this child class, I'm still passing in some values. This is because, since this car class is inheriting from the vehicle class, it'll automatically have these two methods inside it. So this car class will have the init method, and also the showDetails method. So this car class will have three methods in total: the constructor from the parent class, the show_details method from the parent class, and also this showCar method, which is specific to this car class. Now, since it also has the constructor, we need to pass in the values for mileage and cost. As you can see, I'm passing in the value for mileage, which is 200, and the value for cost, which is 1,200. Then I'll go ahead and invoke the showDetails method using this object of the child class. So as you can see, this object is from the child class, but this method belongs to the parent class. But since the child class inherits from the parent class, that's why we're able to call this method. And when you look at the result, we have I'm a vehicle, mileage of vehicle is 200, and cost of vehicle is 1,200. And since we also have the showCar method, which is part of the car class, we can call it directly. So when I use c1.showCar, I get the result, I am a car.
So we already have our parent class here. Now let me go ahead and create the child class as well. So I'll create a class called car, and I'll use parentheses, and inside them I'll pass in this vehicle class. Then I need to go ahead and create a method that's specific to the car class. So I'll define a method and I'll name it show_car. This method only takes one parameter, which is self. And inside this, I'll use the print function and just print out something. I am a car. And when I hit run, you'll see that we've successfully created this class. So after creating this class, I need to create an object of it. So I'll write c1 equals car. Since this inherits, it will also have a constructor. So I'd have to pass in a value for mileage. Let's say this car gives me a mileage of about 300 miles per gallon, and the cost of this car is around, let's say, $10,000. So I'll pass these two values here. Now that I've entered the values, let me call the show_details method. This is actually the showVehicle method, which is in the parent class. So c1.showVehicle, and as you can see, I get the result. I'm a vehicle, mileage of the vehicle is 300, and cost of the vehicle is $10,000. And since we also have this particular method here, I can go ahead and call it. I'll use c1.showCar. This should be a lowercase c. Now when I hit run, you'll see that I'm able to print out I am a car. Now we'll see how to override the init method in the child class. So in the previous example, we created a child class where we only had one method here. But what we'll do now is also add an init method to this child class. And this init method will take 4 parameters. The first 2 parameters will just be the 2 parameters for the parent class. And since the vehicle class has mileage and cost parameters, I'll have them over here. I'll also include the self parameter, and I'll add 2 new parameters specifically for the car class. So I'll have tires and HP. Now, to pass the values to the superclass or parent class, I need to use the super method, so I will. Write super.init, which basically means I'm calling the init method of the superclass, or in other words, I'm invoking the init method of the parent class, and inside this, I'm passing in mileage and cost. So these are just the values of the parent class that I'm passing in, and after passing in the values for the parent class, I'll go ahead and assign the values for the child class as well. So here, as you can see, self.tires equals tires. I'm assigning the value of tires here to the attribute of the car class. Similarly, I am assigning the value of HP here to the attribute of the car class. And once I assign these values, I need to display them. So here I will have a function called show_car_details, and I will print out I'm a car, number of tires are self.. Tires and value of horsepower is this. After I create the template for this child class, I can go ahead and create an object of it. So here, as you can see, I have c1 equals car, and I've given 4 values here. The first value will be for the mileage of the vehicle class. The second will be the cost of the vehicle class. So here, as you see, I'm using vehicle, and when I call c1.showDetails, even though showDetails is part of the parent class, I'm able to call it because the car class is inheriting from the vehicle class. And here I have mileage of vehicle is 20, and cost of vehicle is $12,000. And I also have 4 and 300. And as you can see, when I call c1.showCarDetails, I get the result, I'm a car, number of tires are 4, and value of horsepower is 300. So I'll go ahead and create the parent class again and the child class again here. So I'll have a class called vehicle, and this will have an init method. So I'll write def here. I'll write init, and this will definitely have the self parameter here, and it has 2 values, which are mileage and cost. Now I need to assign these values, so it will be self.. The value of mileage is set to be equal to the value of mileage here, so in this case, I'll have self.cost set to be equal to the value of cost, and this is the way in which I am assigning the values for both mileage and cost in this context. Once I have completed this assignment, I need to proceed and print out the values that have been assigned, so I'll create a new method specifically for that purpose. I'll define a method called show_car_details right here, and this particular method will only take a single parameter, which is self, and I'll begin by printing out the phrase IMA to indicate the start of the car details. Vehicle, and after this step is completed, we need to print out the following message. The mileage of the vehicle is, the mileage of the vehicle, which in this particular case will be represented by self.mileage, is what we're referring to here. Then, in addition to that, I also need to print out the cost, which is another important value to display. The cost of the vehicle is, here, it will be self.cost. And this is how we've created the template for the vehicle class. Now, I need to create the template for the child class as well. So here, it will be the car class, and since this inherits from the vehicle class, I need to pass vehicle as the parameter inside this. After that, I have to override the init method. And since I need to override it, I have to create an init method for the car class itself. I'll start by giving the self parameter, then it will have mileage and cost for the parent class, and then it will have tires and HP, which are exclusive to the car class itself. After this, I will invoke the super method. So with this, I'll be able to call the init method of the superclass. So I'll have super.init, and inside this, I'll just pass in mileage and cost. Once I do this, I need to assign the values for tires and HP. So it will be self.tires equals tires, and self.hp equals HP. Now that I've created or overwritten this init method, I need an explicit method for the car class itself. Let me add a space here, and this time it will be, naturally, def show. Let's talk about car details, and as you can see, I'll have self here as a parameter. After this point, this particular method will actually only take self and nothing else as its argument, which means it will not require any additional parameters. Then, I need to go ahead and print out the statement, I am a car, to indicate the identity of the object. After that, I need to print out another message, which is the number of tires are, and here it will be self, referring to the instance of the car class. This helps to demonstrate how the method accesses the attributes of the object itself, using self to refer to the current instance. Tires, and after that, I need to print out the horsepower as well. So here, it'll be the horsepower is, and the value will be equal to self.hp. And now that I have created the parent class and the child class as well, I need to create an object of it. Here, it'll be C1 equals car. And I need to give the value for mileage and cost. Let's say the mileage is about 30, so it would get around 30 miles per gallon, and the cost, let's say, is $5,000. After that, let's say this car has 4 tires, and the horsepower would be 499. Now that we've created the object and assigned the values, I can go ahead and call the methods of both the parent class and the child class. I'll use c1.showCarDetails here, and you'll see that it prints out I'm a car, the number of tires is 4, and the horsepower is 499. So these are the details from the child class, or the car class. Now I'll print out the details from the parent class, so here I'll use c1.show. Vehicle details, and when I print this information out for you, it looks like I've overridden this, so I'll keep the name as show vehicle details here. So the method in the parent class will be show vehicle details, and the method in the child class will be show car details. And once I've done this, you'll see that I get this result. I'm a vehicle, the mileage of the vehicle is 30, and the cost of the vehicle is 5,000. Moving forward, we'll look at the different types of inheritance. So far, we've worked with single inheritance. Now we'll see what multiple inheritance and multi-level inheritance are. We'll start with multiple inheritance, where a child class inherits from more than one parent class. So, for example, if you have a mother and a father, obviously you have both, and you inherit some features from your mother and some from your father. This process is what we call multiple inheritance. So as you can see, if there's a child class, this child class will be inheriting some features from parent 1 and some features from parent 2, and this is what is known as multiple inheritance. Let's take a look at this here. So we're starting by creating the first parent class, called parent 1. I have 2 methods here. In the first method, I'm assigning a value to string 1. So to assign string 1, I have self in str1, and with this, I'm assigning the value to the str1 attribute in this parent1 class. Then, once I assign the value to string 1, I'll go ahead and display this value or return it using show_string1. So in parent class 1, I'm assigning the value for string 1. Then I have parent class 2, and with the help of parent class 2, I'm assigning the value of str2 first, then I'll go ahead and return the value of str2. Then I'll have a child class, and I'll name this child class the derived class. This one here takes in 2 parameters, or in other words, it's inheriting from parent 1 and parent 2, and again, it has 2 methods here. The first method is assign string 3, and I'm assigning the value for string 3 here. Then I'll go ahead and display it. As you can see, I'm returning or printing out self.str3. So parent class 1, parent class 2, and child class. And after that, what I'm doing is creating an object of the derived class, or the child class. And here I have d1.assign string 1. So even though assign string 1 and assign string 2 belong to the parent class, I'm able to call them because the child class is inheriting from both parent classes. So here, I'm assigning the value of 1 to string 1. I'm assigning the value of 2 to string 2, and I'm assigning the value of 3 to string 3. Once I've given the values, I go ahead and display the values here. So d1.showString1 gives me 1, d1.showString2 gives me 2, and d1.showString3 gives me 3. Now, at this point, this might be a bit confusing, so let's go to our Jupyter notebook here, and let's carefully create our 2 parent classes, as well as 1 child class, step by step. For this, I need to use the Python keyword class and then give the name of the first parent class, which is called parent1. After this, I'll create a method using the def keyword, and I'll name this method assign_str1. This method will have two parameters. The first parameter will be self, and the next will be str1. Here, I'll simply write self.str1 equals str1. Once I assign the value, I'll need to print out or display this value, so for that, I'll need to define another method here, which will be showstr1. This method will be responsible for displaying the value that we have just assigned, making it visible to us when we run the code. What I'll do inside this is, it will only have the self attribute, and I need to return the value of string 1. So this will be return self.str1. And you can see that I've created the first class, the first parent class. Similarly, I'll go ahead and create the second parent class. This time, it will be class parent2, and here I'll have def assign str2 with self and str2 as parameters. I need to assign the value, so this will be self.str2 equals str2. Then I'll go ahead and create the next method, which will be showstr2, with self as the parameter, and I need to return str2. So I've also created the second parent class. Now that both of my parent classes are ready, I can go ahead and create the child class. So here, I'll just name this child class child, because that's more intuitive. Inside this, I'll be passing in both of the parent classes. I'll have parent1 as well as parent2. Now that I've passed in both parents, I'll create one method exclusive to the child class itself, and inside the child class, I'll be assigning string 3. Assign str3 here. This will have the self parameter, and I'll have str3 as well. This is how I'll assign the value. Self.str3 equals str3. And once I assign the value, I would have to go ahead and print it out. So here it will be showString3. It'll be self here, and I'll go ahead and return it. So again, here I need to keep in mind that this is self.string2, and here again, it will be equal to self.string3. And as you can see, I have created all three classes, two parent classes, and one child class, which is inheriting from these two parent classes. Now I can go ahead and create an object of this. So here I'll have car1 equals child. Once I've created this object, I can go ahead and invoke the methods. So I'll start off by invoking the method of the first parent class, car1.assign_str1. Inside this, I'll pass in the value 1 here. Then I'll go ahead and invoke the method of the second parent class. This will be assign_str2. Inside this, I'll pass in the value 2. Then I'll go ahead and invoke the method of the child class itself, assign_str3, and inside this, I'll pass in the value 3. Once I invoke all of these, then I can go ahead and print them out. So I'll have show_str1, and you would see that I have printed out 1. Then I will have c1.show_str2. Then we have an error over here, so let's check this properly. Self.str. We are assigning the value over here, and we are returning this over here. c1.showstr2, name str2 is not defined. So what I'll do is I'll run all of these again because I had added those self parameters, and this time we need to get the result. And this time, as you see, when I have c1.showstr2, I get 2 over here now. Similarly, I'll go ahead and invoke the third string, so I will have c1.show_str3. And this time, when I hit run, you would see that I get the result 3. So this is how we can implement multiple inheritance. Moving on, we have something called multi-level inheritance, and you can think of multi-level inheritance as a grandfather-father-child relationship. Just like a grandchild inherits features from their parents, and those parents inherit features from their grandparents. So here you have multiple levels, and this is what's known as multi-level inheritance. So here we have 3 classes. We start off by creating the parent class first, and in the parent class, we assign the name of the person and then display the person's name. Then in the child class, we assign the age of the person and display the age. As you can see, this child class is inheriting from the parent class. Then we have the grandchild class, where we assign the gender and display the gender. Here you can see that the grandchild class is inheriting from the child class. So here there are 3 levels. The child class is inheriting from the parent class, and the grandchild class is inheriting from the child class. Now let's go to the Jupyter Notebook and implement this. But I have to start off by creating the parent class. I'll have a class, I'll call it parent here, and inside this, I'll create a new method called assignName. This will have self, and then we'll have name here. Inside this, I'll just write self.name equals name. This is how I'm assigning the name. Then I'd have to show the name, and for that purpose, I'll have showName. This will only have self here, and I need to return self.name. And I've created the parent class. Now after this, I would have to create the child class. So here I will have a child class. I'll create a new method here, and I'll name this method assignAge. I will have self. I will have age here, and I need to assign this age. So here it will be self.age equals age. Then I would have to display the age. I'll have to create a new method. This will be called show_age. I'm writing self here, and I would have to return this. So this will be return self.age. And this child class is inheriting from the parent class. That's why I'll pass the parent class as a parameter to the child class. Then finally, I will create the grandchild class. Here I will have a class for the grandchild. The grandchild class, which is a subclass, will inherit all the properties and behaviors from the child class. This grandchild class will also have 2 distinct methods of its own. The very first method that will be defined is called assign_gender, and this is the way in which I am passing in the 2 required parameters. I will have self as the first parameter and gender as the second parameter. Here, within this method, I would set the attribute by writing self.gender equals gender, which assigns the value of gender to the instance. Then, after that, I will proceed to create a brand new method here, show gender, and here I will only have self. I would have to return this. It'll be like return self.gender. And now that I've created these 3 classes here, I have my parent class, the child class, and the grandchild class. I can go ahead and create an object of the grandchild class. I'll call it GC, and I'll instantiate it like this. And once I create this grandchild class object, I can assign the name, age, and gender. So I will have gc.assign. Let me write it down again. So here it is, gc.assign_name. And the name that I am setting, or in other words, the name that I am giving to this person is Bob. Then after that, I would have to give him an age as well. So here it will be gc.assign_age, and let's say, for example, that Bob is 54 years old. I'll also assign the gender to Bob, just to make sure all the information is complete. This will be gc.assign_gender, and the gender is male. I've assigned these 3 things. Now I need to go ahead and display them. So here it will be gc.showname, and I'm setting the name. Actually, I don't have to provide anything here, I just need to call it. And as you can see, I get this person's name as Bob. Now let me also call the age here, gc.showAge. You'll see that this person's age is 54. Then I'll have gc.showGender, and here, as you can see, the gender of this person is male.
So let me take you to the next slide, which is an introduction to file handling. Okay, so what do we mean by file handling? Whenever I talk about the topic of file handling, we see that working with text files is basically known as file handling. You all know about text files, right? The files that have the extension .txt, those particular files are called text files. So let's say you wrote some text into a file and saved that text file. Now, how do you work with that specific text file using Python programming? Like, let's say you want to write something into that file, or you want to read what's written in that particular file. Or any particular operation you want to perform on that file, how can you do that using Python programming? That's exactly what file handling is, right? I hope it's clear to you now what file handling means. As I mentioned in the definition, working with text files is called file handling. Even in Python programming, we have another name for file handling, which is I/O functions, that is, input-output functions. So whenever you hear file handling or I/O functions, they actually mean the same thing, working with text files. Don't get confused by these terms, okay? Next, as I also mentioned, what are the areas, what are the things that come under file handling, and what are the operations you can perform. So in file handling, we already have many built-in functions that help us perform tasks like opening a file, reading the text, and whatever is written in it, writing some things into the file, appending the text, basically altering out the text, deleting out some text, and all these operations you could completely perform with the help of Python, right? So as I mentioned that there are many different functions that are particularly involved up here. Now, after that, basically I have one more thing here, and that is basically that what's the IDE I'm going to use and what's the Python version that I'm going to use up here for doing out the practical for the file handling. See, one very important thing to let you know that basically what are the online IDEs you're having that do not support out the file handling technique. And the reason is that with the help of the py file, that .py is basically your Python file into which you write out your coding stuff. So any of the online IDE, if that particular IDE is supporting the .py and the .txt file at the same time, then absolutely you could use out that IDE for writing out your code. Start online IDE. Otherwise, I would recommend you to download out the offline IDE. Now, there are many different IDEs which you can go ahead with, like you can use out the PyCharmer, you could use out the VS Code, you could use the Jupyter Notebooks, whatever you feel like. You could use, let me tell you my particular specifications that I'm going to use. So I'm going to use about the PyCharmer IDE, and the Python version which I am using is 3.9.1, right? If you have the same configurations, well and good. And even if you have some newer version of Python, then also it's absolutely fine. Do not take out the Python versions below than 3.7. Okay, some functions work there, some functions do not work. So I would recommend you to upgrade your Python version above 3.7. Hope you are very much clear with this particular that what's are dealing with the text and what are the functions or operations which you could perform, and basically what's the IDE that I'm going to use up here for doing out the stuff, right? So now basically I'll be taking you to the next slide, and there we are going to discuss about the open, read, and the write modes which we have in the file handling. So let me take you to that brief discussion of these three particular topics. Let's open, read, and write modes. Okay, as the names are just for the open mode, so into this particular mode, what you could do, you could open out any text file with the help of this particular function that's open. So this particular open mode is used whenever you just want to open out a text file. For reading or for writing, for altering, or for doing anything, you use out the open function at the very first point. Now, one more thing which comes up here is that let me take you a very live example of this, but do not assume it as a text file. Let's say I'm having out a book. Okay, I want to read out a book. So how can I read out the book? I'll be taking out that particular book. I would for opening that, then reading out the stuff, whatever I just want, right? Same particular case applies here onto the text file as well. You will be saving out your text file onto the same folder where your Python file has been saved out. After that, the very first step that comes is the opening of file. Writing, reading, altering, all these things are the secondary part that you need to do. Before, like if you're not opening the file, without opening your file, how you could perform out any of the operations, right? So that's the reason whenever we do the file handling, whenever we just deal out with the text files, so the very first method was the very first step that we use is opening our text file. So that particular thing is performed by the open mode which we have here in the Python programming language. Hope I just made this thing very crystal clear that what is this open mode and why we just use that here in the file handling, right? Now, next I'll be taking you to the read mode. After you have opened up your file, let's say you just want to read some text from that file. Let me use the book example again. When I open my book, there can be two scenarios for opening it. First, I might want to read something from that book, or maybe I want to write something in it, right? There are really only those two possibilities. So whenever you're in the first situation where you want to read something from your book, similarly, whenever you just want to read something from your text file, in that particular case, what do? We use the read mode, right? This is the mode you use whenever you just want to read the text that's already stored in your text file. So we use this read mode, right? I hope I've made this clear as well when it comes to the read mode. Next, your second scenario could be that instead of reading, you want to write something into that book. So same case goes for the file handling as well, that instead of reading out your file, you want to write something. You want to add some more text onto your file. So in that case, the write mode actually comes in place. So whenever you are willing to write out anything to add some more extra stuff onto your text file, so in that case, we use out this write mode. So this is used whenever you want to write the text in your .txt file, right? So hope I made this write mode as well very much clear to you, that what it is used for, what's the case when we use this out, and why we just use out this write mode as well, right? So hope these particular 3 modes are very much clear, that what are these, how we perform out the functions, how we go ahead with the operations. Now I'll be taking you to my IDE, that's my Pajama IDE, and then I'll be letting you know that basically how we could perform out the practical, how we can read, write, and open up the files using the Python programming language. So this is the PyCharm ID that we actually are having, right? I'll be giving you a quick overview regarding this particular ID, then I'll be going ahead with the practical. So here basically, let's just make out one of the folders, that's the folder which I'm having. So what I would just do for making out a Python file into which I'll be writing out my code, so for doing out this particular thing, I'll be clicking on this file, okay? And now here, I'll be doing out the right click. So as soon as the 2 or the right click, this particular box would appear. Now, I would just want the very first option, that's new, okay? From this new option, I'll be going on to the number 4th option, that's Python file. I'll be clicking on that particular. Here you need to save out your file with any particular name. Let's say I'm going to give out the name as file, and that's the, let's say, file handling. Okay, click enter. So yeah, this is how your notebook actually appears out here. Whenever you have made out any py file, that's your .py file, that's a completely Python file. Okay, hope I'm very much clear. Next, so here we are dealing out with the text files. So it's necessary to make out one text file. See, now the 2 cases apply up here. Either you make out a text file, or basically you already have one of the text files and put on that particular path here. So what I'm going to do is that I'm going to make out one new text file here, okay? So for that, again, the same procedure, go onto your project, do out the right click, go on the new option, and now in this case, go on to the very first option, that's file. So whenever you just see out this file option, take this as it's our txt file. And let's see, my text file's name is text only, and hit enter. Right click on this and click on OK. So my text file has been made, and that is having the extension that's .txt file, okay? Hope you are able to see this particular file. Right now, what I'll be doing here is that I would be putting, okay, let me do one thing. Yeah, I'll be putting on the things and writing out my folder program. So I'll be making out a variable, that's FE. Before that, okay, not here, into the text file. Before that, I'll be putting on the text into this file. So I would just put on the text that, let's say, this is the topic. This is the topic of file handling. Now, one more thing to notice out here, that this is a text file into which you are writing. So you do need not to put out any comment, any hash sign, or any double inverted quotations or single noted quotations. Nothing like that is at all needed, right? Hope I'm very much clear. Let me take you to the file where we have the Python file, and let's start writing up the code. Let's say I just make out one of the variables. That's FL. Now, this is known as a file pointer, okay? Make this as a file pointer. So FL is equal to open. Now, open is basically my function, the very first function that we are going to see. Let me put on a hash here, and let me write out here the first mode, that's the open mode, okay? So here, we use out the open inbuilt inside this, we'll be putting out the double inverted commas, okay? Now, into that double inverted commas, you're gonna write out our text file name. So my text file name is text.txt, okay? Let me just throw out one thing, because I just need to rename this out. So, okay, 1 second. That is, okay, rename file. Let's do that. Not right here, so input. Okay, let's do the cancel. File. Okay, let's go ahead with this particular thing only. Let's see what is going to happen out. So open text.txt, okay, that's my file name. Come to the new line, and this is how you open out your particular text file. Simply, you need to write out a variable. That's this I just wrote a variable because we call that as a file pointer. That's the reason I mentioned out of F. Other than that, it's not compulsory. You could put on any variables of your choice. We put on the assignment operator, and after that, we use out the open function for opening out this particular file. file, right? So as soon as the open file has been done, the next thing comes is that in which mode you want to open it out. You want to open in the read mode or you want to open in the write mode. So whenever you are willing to open the read mode, in that case, we write out here R. And whenever you are willing to open it in the write mode, so in that case, we write out W, okay? So that is x.txt. Okay, putting the comma here again and using double quotation marks. Now here you specify the mode in which you want to open the file. Let's say I want to use read mode, so I just write R here. It will automatically understand that you want to proceed in read mode, which means you want to read your file. You are opening your file for reading. Let's move to a new line here. And I'll create a variable. And what we'll do is that particular variable will read the text for me. So let's say my variable is content. Content is equal to, and my f is the variable in which I have opened my file in read mode. And now here comes my read function. Content is equal to f.read. Go to a new line, and here I'll simply write print. And inside the brackets, I'll put the variable, which is content. Because content is the only variable into which my file is being read. It's being read and it's being stored. See, okay, before that, let me quickly run the program. Then I'll let you know what I was just trying to explain here. Okay, actually, there's no such file. I was just hoping that it would work. Let me create a new file. Click on New. Go to the file, write the name here. Let's say that's it. Hit Enter. Yes. Now I want the .txt file and click on OK. Okay, right here. So let me close the file from here now. Click on this particular one right here, something like, okay, that's it. And let me quickly do one more thing. Let me make one more right here. So that's file demo.txt, hit enter. So yeah, now this is the complete correct file that has been created. Please, yeah, one more thing to notice here. Do not forget the extension you want to add. Fine, so as soon as you add .txt, now this is your correct file that has been created. So I would just once again add some text. This is a file handling topic. Let's say this is my text. Okay, topic. Now let's come back here. Now I'll just change the name of my file, that's demo.txt, and I'll comment out the first line because now that's not needed at all. Let's leave our file here for a while. So, okay, it's indexing. Basically, it's setting up whatever you've written out here. So it's setting up all of that, all those particular things. So this is one of the things that comes up here, like this by jump ID. Okay, I'll just click on the run button above. So now let me just take you up. So right now you have your output. This is a file handling topic. This was the text that we wrote in the demo.txt file, right? This was the same text that we wrote. And with the help of the read function, we are able to display this particular text here in this specific context in the console of my PyCharm IDE. I am able to get this text output, so this is how we perform the read mode. This is how you read text using file handling techniques, right? I hope you're very clear about the first full read function. Now, what I'll do is take you to the next mode, which is the write mode. What I'll do is comment out all the 3 lines above because now I want my file to be opened in W mode, which is the write mode. So let's say f equals, here goes the open function. Okay, 1 second. Let me come to this part. My file name is, right, putting your comma here, and I want to open that in W mode. Now, after opening it in write mode, I'll use the write function to specify the text you want to write into your text file. So let's say I just want to write about the topics. Write the text that I'm learning file handling. Let me scroll down for a second. Okay, so that's the text I want to write. Yeah, that's done now. One very important thing to mention here, which I didn't mention above, I'm mentioning it now, is that whenever you open a file, it's important to close that file as well, okay? It's a good practice, I would say. See, when I relate this to the example I used earlier about the book, in that case, what were we doing? We had a book, so we opened it. Whether you want to read or write in it, that depends. So whenever you've opened it, after doing whatever operations you want, you will close that book as well, right? The same applies here to text files. Whenever you open any text file, you should close it too, right? That's why I've used f.close here. Now I'll run my file. Here, I won't get any output in the console of my Python IDE. The reason is that I'm directly getting the text written to my demo.txt. And here it is. I am learning file handling, right? I'm learning file handling. This is the text we've written. That was the correct sentence, so I'm seeing that sentence written here in my demo.txt file, right? So I hope you're now very clear about this function as well, how the write function works. So I hope you're now crystal clear about the open function, how it works, about the read function, and even about the write function. Right, so now we have some more topics, some more modes to learn about. So I'll take you to the presentation right away, and then let's discuss the rest of the topics. Now, let's talk about how we can add text to that text file, and also how we can count the number of characters we've added to that particular text file. So let me take you to the next slide here, where we have adding text and counting characters. So first, let's talk about adding that text. So whenever I want to add any text to that txt file, we have a function called append. That's append. This is the specific append function we use to add data or text to your text files, right? So basically, whenever you want to add these lines or add particular lines, we use the append function. The mode we write here is in double quotes with a lowercase a. For reading and writing, we use R and W, but for the append function, we use a lowercase a, right? So whenever you see a lowercase a written, you should quickly understand that this is the place where something is being added or written to the text file. Now, let's say you have a particular case where whatever text you're adding, and you just want to transfer or add that particular text onto a new line. To add text on a new line, we use the operator \n. So \n is another operator that's used to move your text to a new line and then add whatever text is needed, right? So the append function basically helps us add text to your .txt file. As I mentioned, it is used for adding your text to .txt files. Next, the mode used is A for appending, which means adding or writing some text to the file. So whenever I use A, it means I'm using append mode. It means adding or writing some text to the file. Then, to add text to the file on a new line, we use \n before writing the sentence to be added. So this is another case that comes up. I've already mentioned that. But one thing I left out is that whenever you want whatever you've written to appear on a new line, like a new sentence appears on a new line. You want to append things onto a new line. So in that case, use that \n at the beginning of the sentence, not at the end, okay? Use it at the start of the sentence, and then it will specifically move you to a new line and display your sentence on a fresh new line, right? So I hope I'm very clear about the append function, what it's used for, how we use it, what the specifications are, and what mode we use here. Now, we have the next topic, which is counting the characters. Now, let's see how you can count the characters. This is done with the help of the len function, L-E-N, okay? So len is the function that's basically used for counting the characters, meaning the total number of characters you have in your file. That particular operation, that particular thing, can be done with the help of the len function. So what do you do basically? First of all, you open your file and read it using some function that we already have, open and read functions. After reading the file and whatever is written in the file, you just apply the len function, okay? You simply apply the len function, and that particular len function is applied to a variable. You assign it to a variable, the variable in which you have opened your file in read mode. With the help of that particular variable, you use the len function, and as soon as everything is done here, you simply get the total count of the characters in your text file, right? So I hope I'm very clear regarding the len function as well. So let me go over it once again, just to make sure everything is absolutely clear and there is no confusion at all. When you want to count the number of characters in a file, you first open the file using the open function, then you read the contents of the file using the read function. After you have the contents stored in a variable, you use the len function on that variable. The len function will return the total number of characters present in the file, including spaces, punctuation marks, and any special characters that might be there. This is a very useful function when you need to know the exact length of the text in your file for processing or analysis purposes. Remember, the len function is simple to use and very effective for this task. So to summarize, open the file, read the contents, store them in a variable, and then apply the len function to that variable to get the total character count. I hope this explanation helps you understand how to count characters in a file using Python. If you have any questions or need further clarification, feel free to ask. That it's completely used for calculating or finding out the total number of characters you've used in your text file, right? First of all, you open your file, then you perform whatever operation you want to use, and after that, you simply use your len function. So I hope I'm very clear regarding the append and the len functions, what these two particular functions are, what they're basically used for, and how to use them. So I hope you're very clear on these things. Now I'll be taking you to the PyCharm IDE, and there we'll see a practical example for the append and the len functions. Now let's see how we can actually implement the append mode and the len function. So append mode is basically used for adding some characters to your file, and the len function is used for calculating how many characters you have there, right? Okay, what I'm going to do is first add some text to my demo file because it was erased since I commented everything out. So let's say I'm going to write here, I'm learning, and here goes, let's say, file handling. Okay, fine. This is some of the text I already have here. Now I'm going to use append mode to add some more text to this particular place. The short form we use is A. The very first step I'm going to do is open my relevant file, the one I want to append text to. So for me, that's demo.txt. I'll put a comma, then double quotes for the mode, and the mode is A, so I'll put that. Moving to the new line, okay, now here I could just take a variable, let's say that as takes one of my variables here, I'm going to use the fwrite function to write or add anything to my notebook or to my file. Inside this, I'm going to write that, okay, above what we've already written, what's already there, I'm learning file handling. Let's write, this is append mode, like this, right? Let's move to a new line, print out the add text here, and finally, I'm going to close my file. So f.close with the brackets like this. What I'll do is add a \n here as well, so that whatever comes next appears on a new line. And now it's time to run the program. So, okay, this is basically happening because I've written add text here, so it's basically counting the number of simple characters I've added. So yeah, that's actually okay. Let's go to demo.txt and see what has come up. Here, this is append mode has been added. Basically, what I'm getting is a new line added here. This is append mode, which I added using the A function. Using this A mode, I've added that particular thing, right? So I hope I'm being clear about how this function actually works, right? So I'm going to do one thing. I'm simply going to remove these relevant things from here, so this will be great. And if I run this again, it will basically run here. Now, the downside is I didn't get any option or answer, but here, again, the sentence has been added. So the number of times you run this statement, the number of times you run this program, it will basically add that many statements to your relevant text file, right? Now, this is how the append function actually works. Now I'll be showing you about the length function. So here goes the length function. Let's come down here. I would, again, open my file, but this time my file would be opened in, one second. This time my file will be opened in read mode because I want to just add up or count some of the relevant things, right? I don't want to write or repeat anything like that, so I simply want to count the total number of characters. That's pretty clear. My file will be opening in read mode. Okay, so here I'm going to write out, let's say my variable, this data, is equal to f.read, and in the brackets, I'm going to write out the variable that we have as f. Okay, not this. I'm simply going to write f.read like this. Next, I have total count as one of my new variables. And into that, I'm going to put, first of all, the function we have, len, and the variable into which I've read my data from the file. So that variable is just data. Okay, I'll just read in data_mean. Let that be. And here as well, it's data_read. So inside the len function, you need to write that variable. The specific variable where you've used that read function, which I wrote up here, okay? And finally, you're going to print out the variable where you've counted, so that's total_count. I'm just going to write it like this. And lastly, you close your file, right? So what I'm going to do is run this program here. My total characters, the total number of characters I have in this file is 87, right? I have a total of 87 characters in this demo.txt file. right? And why did I get one more statement like this? Because I didn't comment out this particular line. That's why one more line appeared here. So yeah, I hope it's clear again how to use the append function to add some text, and basically how to use the len function to calculate and give you a count of the total number of characters present in your file. All right, I hope I'm being very clear about these things. So let's move on to the next topic and check out the next function. Now we'll look at another function here in file handling, and that's the readline function. Now I'll explain what the readline function actually is and how it's useful here. All right, now let's see. We've already talked about how to read text, how to write text, and how to add some things to that particular text. We've seen how we can append, and all these things are absolutely clear. Now, there could be a situation where, let's say, whatever text file you have, you want to read that text line by line. For example, on the first line, whatever text is written, you read that first. Then, on the second line, whatever text is there, you read the second line. On the third line, whatever text is written, you read that as well. So this could be a specific case where whatever text is there, you need to read all of it line by line. Right? So to perform this particular function, we have a readline function in file handling. Readline, as the name suggests, helps you read the text, or the lines, whatever is present, line by line. Right, I hope I'm making myself clear. Now, next, what do we have? So how do we use this particular function? So to use this function, first you need to open the file in whatever mode you want, read mode or write mode, whichever you prefer. You can open the file. After that, you need to use the readline function. So to read the lines accordingly, we use the readline function as mentioned. It will basically show you the lines, like it will display the text line by line. Now, let's say in your take the first line, it's written as learning file handling. In the second line, it says read, write, and open mode. In the third, it says append mode. So whenever you use the readline function, first of all, it's going to display the very first text, which is learning file handling. Next, it will just give you the next output. Again, if you use the readline function, it will give you the second line, which is read, write, and open modes. After that, if you use readline again, it will display the third line. So this is how the readline function actually works. This is how these functions play a role and help us read the text line by line. So after writing these things, and after, let's say, I told you to read this file line by line, once we've seen the read function, right? That's also a function used to read the text you have. But the difference is that with that function, you read your text all at once. Like if you use the read function, it will display all the text written in your file at one go. But in the case where you want to read your text line by line, one single line at a time, that's when you use the readline function, right? So I hope I'm very clear about these two things, the readline function and basically how to read the text line by line. Now, what I'll do is take you to the PyCharm IDE, and there we'll see a practical example of this readline function. Okay. So here we are in the PyCharm IDE, and now I'll be using the readline function, okay? But before that, I'll write one or two more sentences to my file. So f.write, let's say I'm learning file handling, okay? Topics, I'll just write that the topics are open, read, and write mode, okay? Then, okay, that's not open, it's open like this, right? And let me go to a new line. I'll just write f.write once again, and let's say I'll write here that next is the append function, right? Let's say these are the 3 lines that are written. I'll just run this particular file up here, but before that, what I'll do is comment out this particular part, right? So comment that out, and now let's go down and run our program. So here we go. Okay, so nothing will be displayed here, as I told you, because we've written to the file. And this is my file now. Here I haven't used the \n, and that's why it's coming out like that. Let me quickly use the \n at the start. Oh, okay, not like this, and \n at the start. And now let me quickly run that again here. So let me go to demo.txt, and yes, now it's coming up right. So I'm learning file handling, topics are open, read, and write mode, and next comes the append function. And one more thing, if you want to remove all these spaces, don't put any space between the /n and the sentences. Now it appears absolutely correct. Great. Now, what I'll be doing up here is that I want to read out the text line by line, okay? So what do we need to do? First of all, I would simply write the variable name, the one I use to open my file, regardless of the mode. For example, here I've opened it in write mode, but it doesn't matter which mode you're using. What matters is the variable you've chosen, right? So you've opened your file and the variable is f. Then you use the readline function like this, f.readline. And this whole thing goes inside the print statement like this. All right, now I'll just run this program here for a moment. Okay, 1 second. It's not readable. Where did my text file go? 1 second, guys. Where is that particular folder for Great Learning? Let me just quickly open it up. So here it is. Not here, not here. It's right here. So demo.txt, right? These are the files. Now let's quickly run our program here for a bit. Okay, not readable. Let's check out what we're doing here, what the issue is, and why it's not displaying as expected. Okay, so it goes print f.readline, and after that, the bracket is closed. Before that, let me comment out these 3 lines and open the file in read mode first. Now it's time to run the program again. So here we go. Now here I got my very first output. I am learning file handling. So this output appeared because, oh, one more thing. Basically, you can open the file in read mode or write mode, but you can't use functions like this together. So at that point, I needed to comment out these lines first, because at the same time, I can't write and use the readline function together. You can't use both functions at once, right? That's why I had to comment out those 3 lines. So it read the very first line of my text file, which is, I am learning file handling. Yes, that was the first thing. Now, let me come down here. What if I use another print statement right here, f.readline, and put the brackets like this? Now, if I run my program again, see what output I get here. The output I'm getting is topics are open, read, and write mode. So let me just do it like this right here. When I used the readline function the first time, I got the first line displayed. Next, when I used the readline function a second time, this line was displayed, right? So I hope you all got the idea about this. Now, let's see what happens if I use this print readline function once again. So f.readline with the brackets. Now what will happen? This particular line will be displayed for the 3rd time. That means my 3rd line will be displayed here, which is about the append function. So just to verify, these are the only 3 lines. I'm learning file handling topics, which are open, read, and write mode. And the next and last one here is the append function. Great. So I hope I'm very clear about these 3 readline functions, how we read out the text line by line. Now, what if I use my readline function once again? Since I only had 3 lines in my text file, what happens if I use the readline function again? Basically, it won't display any other text because there are no more lines in my text file. In my demo.txt, I only had those 3 specific lines. It won't show you an error, nor will it display any text. It will simply leave that part blank. I'll remove this particular thing now. And finally, my file is getting closed, because we all know that whenever we open a file, we basically need to close that file as well, right? So I hope you also understood this particular concept about the readline function, what the readline function is, how we use it, and basically how we can read the text that's present in a single line. And that's done completely line by line, right? I hope that's all very clear to you. Now we'll move on to the next topics. Now let's talk about the try and except functions. So this is the point where we start dealing with exception handling, right? So from here, I'll explain to you how to handle exceptions. So the interesting topic that comes under this is try and except. So let me take you to the next slide now. And here we have the try and except statement. Now, whatever block of code you write inside the try block will be executed as long as your code is completely error-free. And if there's any error in your code, then basically the except part gets executed. See, think of it this way. Let's say, for example, that you are writing some code, perhaps for a project or an assignment. So you decide to put the main logic, which is the core functionality or the essential part of your program, inside the try block. Right after that, you add an exception as well. So if there is any error, mistake, or unexpected issue in the code you have written, it will display that particular exception to you as an error message. Right after that, It's an exception, which is a special kind of event that will occur if something goes wrong. In that case, you need to put a print statement, or any other action you want to perform, inside the except block. So, if your code does not have any errors, the try block will run smoothly and display the relevant output, whatever is required or expected. But if your code has some issues, problems, or errors, then the control of your program will go into the except block, and whatever you have written there will execute. Whatever exception occurs will be shown, or if you have written any print statement inside except, that will be shown as well. Whatever you have written inside the except part will be displayed as output to you in the form of an exception message. Great! I hope I am very clear about try and except statements and how they work in programming. After that, one more thing is that with a single try, you can use any number of except statements, which means you can handle multiple different types of exceptions or errors in your code, making your program more robust and reliable. Let me explain this a bit more. Let's say you have written a try and except statement, the way you write one try block and one except block. Now, let's say you want to add more than one except block. Yes, you are absolutely allowed to do that. So yes, basically you are completely allowed to do that, and there are no restrictions preventing you from doing so in your code. Now, let's talk in detail about how this works as output in your program. With a single try block, it's perfectly okay to have just one except statement, but it's absolutely mandatory to have at least one try except pair in your code for proper error handling. Other than that, with a single try block, you can use any number of except statements as you wish, however many you want, depending on the different types of errors you want to handle. Those are the except statements that are associated with a single try, right? So I hope I'm making it clear how to use try and except statements in your programming. Whenever there is no error in your program, the try block gets executed as expected, and your code runs smoothly. But if there is an error in your program, the except statement gets executed instead, allowing you to handle the error gracefully. Basically, after the except statement runs, whatever print statement you have used inside the except block will get executed, and you will see the output accordingly. If you haven't used any print statement, then you'll get an exception as the result, and nothing will be printed to the screen. Another thing I mentioned earlier is that a single try block can have more than one except statement, which means you can handle multiple types of exceptions separately. So it's not necessary to always have just one pair of try and except. You can have multiple except statements for different error types. With a single try, you can use 10 excepts, 20 excepts, 30 excepts, however many except functions or statements you want to use with one try block, you are always allowed to do that, and there is no upper limit. I hope I've made it very clear to you how to use try and except functions and how to use them effectively in your code for error handling. Now, let's look at the syntax in detail and see how you can write this in your program. So how do you use it? What's the syntax for try and except? First of all, you write your try keyword, right? You write that, add a colon, and go to a new line. As soon as you go to the new line, you'll automatically get some tab spaces. Those spaces are there to confirm that, yes, you are inside the try block, right? After that, you write your relevant logic, you write your statements. This means you just write out your complete code, whatever you want to write in that particular place. Right after that, you come out of the try statement and then write your except. Now, you could simply print something like write except and inside that a print statement, or you could write except exception as E. Now, these two cases come up here. What are they used for? So this except exception as E is basically used whenever you want to see whatever relevant error or exception is occurring as output. In that case, we use except exception as E. And in cases where you just want a print statement to be output after an exception occurs, you simply use the except keyword, and after that, you just write your relevant print statement, right? So, as we've learned about the try and except theory, now let's move on to the practical part. Let's see how it's actually used, how to implement it. So what I'm going to do here is, first of all, I'm going to take two inputs. Let's say A is equal to, I'll just write input here. Inside that, I'm going to write a statement. Let's say, enter the number. Okay, move to a new line. Let's take the second one. I'll just write here as input for number 2. Let's say this is number 2, and let's say this is number 1. So here again comes the colon, like this, right? Now, let's say I'm writing a program to add two numbers. So now comes my try function. Inside my try function, what do I have here? So I'll start here with the things that, let's say, I have to do. Declare a variable, let's say c equals. Now above, I had just used the input functions only. What I want to do is write a program for adding two numbers, but nowhere have I declared that I want the input to be an integer format, right? That's the part that's not declared. So now I've declared, or I would declare, a new variable, let's say c here. After that, basically what I'm going to do is, as I mentioned, we'll be writing a program for the addition of two numbers. Let's say I'll be taking the two numbers from the user here, right now. When I talk about taking input from the user in number format, in that case, at no point have I mentioned that I want the input to be in integer format. And if I haven't specified that, then it will automatically take the input as a string. When I use the plus sign, it won't give me the addition. It will just concatenate both numbers, which is what actually happens. What I could do here is simply use the relevant typecasting. I could write it like this and simply write it out like this. Moving to the new line, I would use one of the print statements, and inside that, I'll print C. Okay, after this, I'll use except exception as E, right? This is the first sentence I just told you that we could use this particular statement, except exception as E, and here I would simply print out E. What I'm gonna get as a result, you all know as well, is that I'll get some kind of exception here. The reason is that I haven't specified any data type here at the start, and I have mentioned it here. So it would say that we cannot add an integer and a string. Either it should be integer plus integer or string plus string. Right, let me run the program and show you how these things appear. You can enter the first number. Let's say that's 2. And here goes 6. So what did I get here? Unsupported operand type for plus, int and str. So basically, it means that the operand types, the operators you've used here, like the variables you've taken, are not supported. One is an integer and the other is a string, right? Now, this is the kind of exception that occurs when you've made an error in your program. That's the first way to encounter an exception. Okay, now the second way is that you could simply write except here, and inside this, you could add a print statement like error in your try block. You could print out a simple sentence like this as well. When I run this, let's say I enter my numbers. Let's say 3, then 5. So what do I get? Error in your try block. But it's not as specific as the previous one, which was except exception as E, right? It's not that specific. So in that case, we always try to prefer writing except exception as E. You should always prefer to use that, right? So I hope you got the idea of how exceptions occur. Now I would typecast this as well, and now let's write our program in the correct way. And I would be running this at this particular place. So what I got as the first output was enter the number 1. Let's say that's 4, 6, and now I got my resulting output, which is 10. The reason is that I didn't have any errors. So my try block executed, and if my try block executed, my exit block will too. Will not get executed because I didn't have any errors in my program that I wrote out, right? I hope I'm very clear with these particular try and except statements for you. How we use try and except, what the syntax is that we use, and what's the correct way to actually generate an exception. So the correct way is except exception as E, right? I hope that's clear. Now let's move forward to some other topics about the try and except function. So let's add in exception handling. Now let's understand about try with the else clause. I just told you about try and except a few minutes ago. Now let's see how, with try and except, you can use the else clause, when exactly it gets executed, and all those things. Let's move forward. Okay, so the first thing is that you can use the else clause with try and except statements. Yes, that's allowed. What is the set of instructions? What are the things you need to follow here? So whenever, let's say, you use the else clause with the try statement, it's when you want to execute a set of strict instructions. Whenever, let's say, the case is that you do not have any exception in your program. After the execution of the try block, you want one more statement to be printed as output for you. In that case, we simply use this else clause. Let me give you an idea. Let's say you wrote a program for the multiplication of two numbers. You add your except statements, and after that, you use the else clause. Inside the else clause, whatever print statement you use, in that particular case, if you do not have any exception in your program, if you do not have any error in your program, then after the execution of the try block, that particular else statement will be executed. I hope I'm very clear about this particular point, right? But that will only and only be executed when you do not have any error in your program, when your exception doesn't actually occur. Only in that case will the else clause work. The syntax is that you simply write your try statement first, then your except statement, and after that, put the else keyword. After adding that, put a colon and go to a new line. Some spaces will be automatically detected, and after that, you can add your relevant print statement, your relevant block of code, whatever you want to be executed if your exception hasn't occurred. So in that particular case, you can use anything relevant to you right there. There's no restriction that you can only use a print statement or only write some logical operations, nothing like that. You can write anything in that particular section. Right, so I hope I'm very clear about the use of try with the else clause, how you can use it, and in what cases it's particularly used. Now, let's see practically how we can use the try and except statements with the else clause. So I'll start by writing code to take two inputs from the user. So A equals int input. I'll write here, let's say, enter the number. Okay, enter the first number. It moves to a new line, and I'll take another input. And that's where our input comes in. Enter the number. Okay, so here I go with a lowercase n. Now, I'm going to write a program to find out whether a number is even or odd. Okay, so I don't need the second statement, right? I'll just write the program for that. Determining whether a number is even or odd, I don't need to check a second number, right? It only works with one. So let's go ahead and write that out. I'll start with my trial statement, and inside my condition, I'll check if the number modulo 2 is equal to 0. Basically, if the number divided by 2 leaves a remainder of 0. In that case, I'll print out, using f strings, the number itself first, which is A, an even number, right? And if this is not the case, in that case, print out the else part, that print if its strings A is an odd number, right? These can be two statements, two cases, which could appear that if the number is even, it means that the remainder is 0. In that case, write out that this particular number is even. Otherwise, print out it's odd. After that, here goes the except. I would write out exception as E. Put on the colon, come to the new line, print out the small e, that is my exception. Now after this, try and except here, you use out the else clause. So like this it goes. Inside this you could write out anything. I would simply put on a printer statement that that else clause got executed. Like this, I could print on one of the statements and the else clause got executed, right? So, okay, now what I would just do is that I would run out this particular program. So it's asking me to enter the number 1. Let's say that's 4. See what it got me? It gave me that 4 is an even number and else clause got executed. Now, why did my else clause got executed? Because my try block got executed completely, in a complete manner, because there was no error or exception in my program. That's the reason this else part got executed. Now, what I would do, let's say I just make out any error into my program. Let's say if I just put on one single this, okay? Now if I run out my program, okay, so it is syntax error 1 second is equal to, and here let's say I just make on b, because b is one of the variables which we haven't defined. So let's say I made out b, run that out to you, asking me to enter the number 1. Let's say my number is 3. See what it is giving me? Name B is not defined. This is my exception that is occurring, right? And my else clause even did not got executed. The reason I have already told you that whenever your try block will get executed, whenever the portion, whenever the logic which you have written inside the try block, that would get executed. After that only your else part will get executed. If you're getting any error or exception, then your else clause will not at all get executed, right? right? So I would again make out the relevant changes. So it's A and again it's A. And now if I just again run out my program, so now in that case, I would not be getting any error, any exception like that. Let's say it's right. So 45 is an odd number. And here I got the statement executed, that else clause got executed, right? Hope I'm very much clear with the statement for land. Click how does the strike and except and else clause work together. Hope I'm very much clear with this, that which part will basically execute, right? We'll see up the next topics now. Now let's discuss about the finally keyword. So now I'll be seeing up that what is this finally keyword in the exception handling. Let's go ahead. So yeah, here we have, okay, I told you about the try and except functions in a very much detail. Even we had done out the practical answer, right? That was completely over. Then I introduced you to the else part is right, that the how to use out the else clause with the trial statement. So that particular condition was applied at that particular case whenever you just wanted to like let's say you are writing out any particular logic or particular code inside the try block, and whenever you do not have any particular error into your program, it means that your except part doesn't works out, it doesn't executes at all. In that case, the else part was getting executed. Now what happens with the finally keyword here? See, finally is a keyword that would execute either you are having exception in your program or you're not having exception in your program. It doesn't. All that matters for the finally keyword is that it has to execute, whether you have an exception or not, right? You can use the finally keyword directly with the try and except blocks, or even if you just want to add it to the else clause. So in that case as well, you can just add it to your else clause and then your finally keyword after that. It doesn't matter if you're using it with the else clause or just with try and except, whatever you wish. But one thing is certain here, and that's compulsory. Whatever code you write inside the try and except blocks, no matter if try runs or except runs, the finally keyword will definitely execute, right? Now, let's quickly pay a little attention to the write-up I've written here. So finally, the keyword that surely executes after the execution of the try and except block of statements. So it means that finally is one of the keywords that is definitely going to execute after the try and except blocks have run, as I told you before. Great. Now, when I move on to talking about the syntax, about how to use it, the syntax is super easy and actually the same as we followed in the previous topics. Simply, first of all, you put your try statement, put your relevant code or logic, whatever you want to include, inside the try block. After that, add your except statement. I would always recommend you write your except statement as except exception as E. It makes the exception more relevant for you. It generates a specific exception. So if you have any exception in your program, it comes to you as a clearly defined one, so you can easily understand, okay, this was the exception that occurred, so now I won't make this particular mistake in my program again. That's what actually happens. Then, after that, we have the else part, which is optional. If you want to add it, you can. Otherwise, it's not at all compulsory to include, right? And after using whatever relevant else condition you want, or not, the next statement is about the finally keyword. So at this particular place, you use your finally keyword. Inside the finally block, you put your relevant code, or maybe just a print statement, or some logic, whatever you wish. You can put that inside the finally block. After that, you execute your program. So whatever runs, either try or except, it doesn't matter, but you will always get the final output, either from try or except, and the finally keyword will definitely execute at the end. That means whatever you have written in finally will surely be executed and shown to you after the try or except block runs. Great. So I hope I'm very clear now regarding the finally keyword, what it is, how we execute it, what's the syntax, what it's used for, what conditions apply, and what don't, right? So I hope this theoretical part is very clear. Now let me take you to the PyCharm IDE, and let's implement the practical part for the same. So now let's execute some practical examples for the try and except part, right? I'll be using the finally keyword here with try and except, so let's get started. Okay, let me just scroll down to this particular place. What I'm going to do is I'm going to write a program first of all to find out which is the greater number among them, okay? Let's say, for example, we have a simple program that we want to write. So what I'll be doing here is taking an integer as input from the user, and here goes the input step, and here is my prompt, which is enter the number, right? My first number, which is the value for the first variable, goes here. Next, moving to the new line, what I'll do is use a second variable, and for that as well, I'll take input from the user, just like before. So here it goes. Enter the number, giving this space like this, right? So now both variable 1 and variable 2 have successfully taken input from the user, and we have stored those values. Then comes my try function, which is used to handle exceptions or errors that might occur during the execution of the program. So try, my condition goes, if A is greater than B, right? In that case, I could print a statement to the user. Using F strings, which allow us to format strings easily in Python, I could write print F, A is greater than B. Coming back, adding my else condition, else, what we could print is, okay, let me go above at this particular place in the code and add the F string for the else case as well, so that both conditions are handled properly. In the brackets, it goes like this. Okay, the F will be outside, not inside, like this, right? So yeah, out right here, B is greater. Let me come down to a spot right here. B is, one second. So B is greater than, and here goes, here as A. Okay, so B is greater than A. Those conditions are satisfied. Coming out and using my except function. So exception as E. Putting on the colon and printing out here as, right, this much code you absolutely understood because we've already dealt with these types of code before. Now, coming down to a spot here, I'll be using my S class as well. Let's say that's also getting executed. Okay, first of all, let's just add the finally block, and after that, I'll add the class. So here goes my print statement, and I'll just write that. Finally, keyword, what keyword use? Let's say this is my print statement. Okay, fine. So I don't think we have any relevant exceptions in our program because we haven't created any. So my output will be, first, I'll get whether any of the conditions from here are met, and at the end, this particular statement will be printed. Let me show you how. So let's run it. So as you remember, to run it quickly on a blank space, we just right-click. Click on the run option, and here we go. So the number I would enter, let's say, is 21. Okay, the one above isn't commented out either. One second, I'm so sorry. Let me terminate this from here. Okay, yeah, remember a previous program we wrote as well? So let me just do that quickly here too. Let's comment that out. All right, now it's the right time to run the program. So click on run, enter the number 1. So let's say that's 21 here. That's 34. So what it showed me is that 34 is greater than 21 because my second condition was satisfied. It means the value for B is greater than A, right? And lastly, this statement appeared here, that the finally keyword was used, right? Because this final statement got executed. Now what I'm going to do is make some changes to the program later. Let's see here. Okay, yeah, let's run this now. Okay, so I'll enter num1. Let's say that's 34. And num2, let's say that's 1, okay? I got the relevant exception that says name C is not defined. Other than that, my finally keyword got executed again at this particular point. So it showed me the use of the finally keyword. So as I mentioned to you when we were discussing the theory, the finally keyword always gets executed, no matter what we're using. Whether the try block is running or the except block is running, the finally keyword will definitely run at that particular point, right? I hope I'm very clear about this. Let me close this out here, and now I'll do it again the same way, and let me also show you how to use the else part. Simply after the except, you can add the else condition. And 1 second, go back, hit enter, and write your relevant print statement. So print or whatever logic you want to put, anything works here. So I'll just write here print else part got executed. So here goes the execution, right? So here I've also added the else part along with finally. Now let's run that. So let's see, my number 1 is 67, and I'm told it's 30, and here goes that. 667 is written on 32. After the try, we've used the else part, so that's why the else part got executed first. Then we had the finally keyword, and then basically my finally statement was present there, so this particular statement got executed. That's the finally keyword used, right? I hope I'm very clear with a complete detailed explanation for the program, how to add the finally keyword, how to add the else conditions, and everything should be very clear, right? Fine. So let's look at the other things as well. So now, basically, I'll be discussing the summary of this particular module that we've covered. So let me just take you to that particular presentation as well. Now, let's take a quick summary of whatever we've learned in this exception and file handling module. So let me take you right back to the very beginning, where we started, and we'll go through everything from there. So we began with an introduction to what file handling is. So file handling basically deals with text files. It means that this is entirely about working with text files, meaning you're opening, reading, writing, or appending to them. All these operations are performed on a text file, and this whole process is called file handling. Another name for file handling is Python file input-output function, file I/O functions, or file input-output functions, whatever you want to call them. You can use that term. So specifically, we have different functions here like read, write, append, alter, and many others. Okay, let's move forward. Here, we described the open, read, and write modes. So open was one of the modes that basically helps us open our file, just like we would open a book to read it. So the first step we do is open the relevant book. Similarly, whatever file you're going to work with, the first thing you do is open that file. That particular action is done with the open mode. Then we have the read mode. Read is the mode that allows you to read whatever is written in your program, in your file, in a text file, and write is one of the modes that basically allows you to write anything onto your text files. So these were the three modes that we saw. We also saw practical examples of how to implement them. Then we had adding text and counting characters. So to add some text to your text file, we have the append function. Append is a function that basically helps you add text to your file. We saw how to write that as well. Next, we had a function that was used for counting the characters. That tells you the total number of characters you have in your text file. So that function was the len function, right? Now let's move on. Then we talked about the readline function. So this was one of the functions that basically allows you to print out your relevant written text line by line, whatever text you have written in your text file. So it allows you to print out all the text line by line as output, right? Then we moved on to exception handling. We talked about the try and except functions. So we discussed the try and except statements. Whatever code is written inside the try block will only get executed if there is no error or exception that occurs. If you have any exception, then basically the try block won't get executed and you'll get your relevant exception output. We saw two methods for writing exceptions. The first one is except. Just write except, and inside the print statement, write your relevant message. And the second one was that you could use except exception as E and then print E. So it will automatically give you a relevant and meaningful exception, right? So we talked about try and except. We also saw that with a single try, you can use any number of except blocks, right? Then we moved on to try and the else clause. So I explained to you how to use try with the else clause. So the part or block of code that is specifically written inside the else clause, which is a part of exception handling and programming, only gets executed if and only if there are absolutely no exceptions that occur anywhere in your program during the execution of the try block. If there is any exception, even a single one, then your else clause will not be executed at all, right? This is exactly what we observed and discussed with the try and else clause in our previous examples. And finally, we talked about the finally keyword, what the finally keyword is, what its purpose is, and how it works in the context of exception handling. With finally, whether your try block executes successfully or your except block executes due to an exception, it doesn't matter. What truly matters is that your finally block will definitely, without any doubt, get executed whether or not there is any exception in your program. Your finally block will always, under all circumstances, get executed, right? So I sincerely hope I have made everything absolutely clear about this module on exception handling and file handling. Right, so I hope you are now very clear about all the topics I have shown and explained, including all the practicals and demonstrations we performed together during this session. If you have any doubts, feel free to revisit the examples and practice them on your own for better understanding. Hope you all are very clear about this.
With these advanced concepts in hand, let's move on to data structures and algorithms. We will explore arrays, stacks, queues, and linked lists, and dive into essential searching and sorting algorithms to boost your problem-solving skills.
Now, let's talk about our first linear data structure, which is the array.
So what is an array? It is a linear data structure, which means elements are stored in a linear fashion, right? Linear fashion. Now, if we talk about arrays, let's take an example. let's say this is how you represent an array in the form of a row, right? And let's suppose it contains the elements 1, 2, 3, and 4, right? Now, every memory location will have some address, right? So let's say these are the 4 elements, 1, 2, 3, and 4, and these are their respective addresses. Let's suppose this one is 100 and this one's 104. This one is 108 and this one is 112. Now, if you talk about memory, obviously these addresses will be in hexadecimal. And when you talk about this particular array will be somewhere in memory with 4, or you could say 4 bytes of memory for each integer. Now, if I consider this integer, and let's suppose an integer takes up 4 bytes. Now, these 4 bytes are available for each integer. Now, this is an integer, right? Now, it takes 4 bytes. Now, the second integer will start from 104, right? Because, again, this will take 4 bytes. Then 108, again, it will take 4 bytes. Then 1112, right? So in memory, it will be somewhere around there. But the thing is, obviously, you might be thinking, okay, sir, let's suppose this is our memory, and now if we have 4 and 4 bytes, that means 8 bytes here and 8 bytes here, but they're available in chunks, right? This is one chunk, and this is the second chunk, and the rest of the memory is occupied. Can we store this array in your memory, in the memory? No, because it needs a contiguous memory location. That means when this is the scenario where you have memory locations available in one big chunk, right? That means if you talk about this array, it requires 4 times 4, that's 16 bytes, and they are available in a contiguous memory fashion, right? Or they're available in such a way that it is one single chunk of 16 bytes, okay? So only then can you store the elements at that location. Now, obviously, for simplicity, I'm taking these addresses as a number, integer numbers, but in reality, those are hexadecimal numbers, okay? So it's easier for me. Okay, so now, one more thing is that the elements are stored in a linear fashion, right? But can we access elements randomly? Yes, with the help of indexes. So if you talk about this array, right? 1, 2, 3, and 4. Obviously, there will be a name associated with this array, right? Now we have index 0, 1, 2, 3. Now, why does indexing start with 0? Or why is there a 0? And indexing always starts with 0? Now that's the question, right? Now, let's try to demystify this fact. Why does indexing start from 0? Why doesn't it start from 1? Now, if you remember, right, I told you that there will be a name associated with this array, which is R. Now, this R is nothing but the name of the array, and the name of the array represents, right, it represents its base address. Right, now the base address of this, as we discussed earlier, is 100, this is 104, this is 108, and this is 112, right? So now this is 100. Now let's talk about how you access. We'll talk about how to declare and initialize our array in the coming slides, but let's suppose we're talking about how to access this. We use the array name, then the subscript, and then the index, okay? The index is 1. Now, I told you the name of this array represents the base address, so the base address is 100. Now, plus 1, now this 1 represents 4 bytes, okay? So the 4 bytes, then what happens internally is it boils down to 100 plus 4, which means 104. Now, 104 is not the first location, it's the second location. Okay. Now, similarly, if you talk about accessing the second or third element in the array, what does it boil down to? Array of 2, which is nothing but 100 plus 2. Now, this 2 is nothing but 8, right? 108. So you'll be accessing the third element in the array. Now, how can you access the first element? So R of 0. Now, it boils down to 100 plus 0 because there are no bytes, right? So it comes down to this. Array indexing starts from 0. And now you know why. And this is how you can access elements randomly. So with the help of these indexes, okay, so now you might be thinking, okay, now we have an array. Can we store different elements, right? Can we store, let's suppose this is the array. Can we store in this like first an integer, then a floating point number, then maybe a character? No. If you talk about any particular array, let's talk about this array, the data type, or the type of data you can store in this array, will be homogeneous. That means you can only store similar elements, okay? So these are some facts, and this is how arrays work. What the addresses are, what the indexes are. Can you store different elements? No, you can only store similar elements in them. Now let's talk about the applications of arrays. Now you might be thinking, why do we need arrays? What's the reason we're using them? Basically, when you talk about arrays, obviously, when you have a scenario where you want to store your elements in a linear fashion and you want to store them in continuous memory locations so that you can use your memory efficiently, right? Not the CPU, but you can use your memory and utilize it to the maximum. So if you want to use your memory efficiently, you can use arrays. But obviously, arrays have some drawbacks, right? That's why we have different data structures. So if you want to store your data in a linear fashion, you can use arrays, okay? Now, arrays are also suitable for scenarios where you require frequent searching. If you want to search for an element in an array, you can directly go and access these indexes one by one. So in a linear fashion, you check, is this the element you're looking for? No. Is 20 the element you're looking for? No. Is 30 the element you're looking for? No. So what is the element that you're looking for? Yes, you can access all those elements one by one and try to search for the element you want, okay? So it's suitable for applications that require frequent searching. Now, let's talk about one dimension. If we talk about a 1D array, it can be thought of as a row, like we saw in the example, right? So that's what a one-dimensional array is. It's represented as a row, and we have addresses like 104, 100, 104, 108, 112, and 116. And the indexing will obviously be 0, 1, 2, 3, 4. And then there will be a name associated with this array, which is ARR. And then you can store the elements in this array. Let's suppose here it's an integer array. You can only store integer elements, and the size of this array is 5. And you've stored the elements 1, 2, 3, 4, 5. So now you can think of it like a row where the elements are stored one after another. Like you see you have 1, then 2, then 3, and so on. All of these numbers are stored in continuous memory locations. Okay, now when you talk about a 1D array, only one index is used, right? When you try to declare and initialize your array, at that time you will use one subscript. Okay, so how do you use that? Let's suppose if I talk about this specific array that I've defined here, right? You would define it as ARR, and then the subscript or index, and the number of elements present here, which is 5. So only one subscript will be there, or one index will be used. Okay, so this is how you declare your array. Now let's talk about the declaration and initialization of this array. So obviously, when you talk about the array, there will be a name associated with the array, and then the data type, are you going to store integer values in that array? Then that one subscript or one index that we use, and definitely the size of the array. So this is how you declare your 1D array. Now, how can you initialize it? There are different ways you can initialize it. Obviously, here you are declaring it. Then you might use a for loop to initialize all the elements, or you can declare and initialize your array at once. So how do you do that? So you would write, and let's suppose this is an integer array, and you don't have to specify the size, you can directly write the elements, right? And those elements, let's say, are 1, 2, 3, 4, and 5. In this case, when you're declaring and initializing your array at once, the size becomes optional. You don't have to explicitly specify the size of the array. But obviously, the size of this array will be 5. Okay, now since you are declaring and initializing it at once, this is optional. But in the case where you are not initializing it, at that time the size becomes very important, and you have to mention the size explicitly. Okay, now let's talk about two-dimensional arrays, also known as 2D arrays. So it can be thought of as a table like this, or you can also call it a matrix, where you have rows and columns, right? Now in this, elements are stored one after another in such a way that you can think of it as a 1D array. Now this is what a 1D array is, right? As we've already seen, right? And inside this 1D array, you have another 1D array. Now this is known as a 2D array. So how does it work? Let's suppose you have numbers here, and you have 4 numbers, 1, 2, 3, 4, then you have 5, 6, 7, 8, then you have 9, 10, 11, and 12. So this is a 2D array, and this would be similar to having 3 rows, right? You will have 3 rows, not 4 rows, but 3 rows, and in those 3 rows, you will have 4 columns, 1, 2, and so on. So the numbers will be like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, done. Now obviously, this will have, let's suppose this is zero-based indexing, so this will have a 0 index here, 1 index here, and so on. Now internally what is happening is, it will be 0, 0, then 0, 1, then 0, 2, 0, 3, then 1, 0, 1, 1, 1, 2, 1, 3, then 2, 0, 2, 1, 2, 2, and 2, 3 for indexing, right? So similar to that, we will have this index as 0, 0, this one as 0, 1, and so on. So if you want to access the element that is present at a specific location, what will you do? You will run 2 for loops, right? One will start from here. Let's suppose one will start from I equals 0 to the length of this outer array, which is less than 3, right? And the other from 0 to the number of rows that are there. Okay, so this one will be the outer loop, and this one will be the inner loop. That means the number of columns that are there. So this is for rows, and this will be for columns, which will start from 0 to less than 4, okay? So this is how you iterate, and it will be similar to this. And now, what about the addressing, right? What about the addresses that will be there? So let's suppose if this is 100, then this will be 104, this will be 108, this will be 112, and this will be 116, because internally it's treated as if they're all in a contiguous memory location. But this time you have a one-dimensional array, and inside that one-dimensional array, you have another one-dimensional array. So to declare it, you'll use 2 subscripts, right? So it'll be something like the name of the array, then 2 subscripts. Now, this will represent the number of rows, and this will represent the number of columns. So in this case, the number of rows will be 3, and the number of columns is 4, right? So this is how you declare a 2D array. The dimension depends on the number of subscripts you're using. This time, we're using 2 subscripts. Now, let's suppose you're using 3 subscripts, right? So similar to this, 3, 3, and 3, okay? So this time, it's a 3D array. And similarly, you can have multi-dimensional arrays, right? You just need to keep on adding subscripts. That's it, okay?
Now, we should learn about array implementation, right? We're solving 3 different problem statements here. The first one is creating a one-dimensional array. It's very simple, and people can understand it very easily. The second one, we're focusing on creating a 2-dimensional array, which usually means a matrix that includes rows and columns. We also call it M and N or M by N. These are all names you can use for a 2-dimensional array. Also, 2-dimensional arrays are used for different purposes. Lastly, we're going to sort, search, insert, and delete elements inside an array that only contains integers. So these are the problem statements we're solving for arrays in Python. Let's quickly hop into the IDE and check out the first problem statement, which is how to create a one-dimensional array and insert elements into it, and also display the output, whatever input is given by the user on the screen. So let's hop into the IDE. Here, I'm using Google Colab to write the first program, right? So we'll rename this. I'm naming it one-dimensional array. Now we'll come to this IDE and type out a one-dimensional array example, where you include the array size, ask the user for different inputs, and then present the same inputs received from the user on the output screen. To save time, I'm just putting up the code now. So this is, I think, the code we'll use for a one-dimensional array. I'll explain what's happening here. The first thing is we're asking how many elements to store inside the array. For example, it might be 5, 6, or 10. So whatever the integer number is, the whole number, we can give it, right? So again, we're assigning a variable for input. Whatever input is given by the user will be assigned to the variable called num, right? Then we're assigning an empty array. Why? Because whatever size has been defined by the user is set here. So if it's 5, it can only take 5 elements. If it's 6, it can only take 6 elements. That's how it works. And right after that, we'll ask to enter the elements into the array. Then we'll be adding them using a for loop. And we'll be using one important piece of code here. That is r.append. Append in this context means assigning the elements one after another at the end of the array. We're not placing the elements entered by the user in the middle, at the front, or anywhere else, right? So append will always make sure that the elements provided by the user are added to the end of the array, one after the other. Next, we'll display whatever elements are in the array. Again, to show the array elements, you have to use a for loop because it needs to print the elements one after another. So let's quickly run this program and see what the output looks like. Right, so it's asking how many elements you want to insert into the array. For now, I'm just entering 3. Then it will ask you for the first number. I'm entering 4. Then the second number, which is 5. Then I'm entering 7, okay? So it'll display 4, 5, 7. Also, you can modify this output by adding commas or spaces between the numbers. If not, it can just display like this, 4, 5, and 7. So that's about one-dimensional arrays in Python. Now let's look at the second problem statement involving arrays in Python, okay? We're going to create a two-dimensional integer array where you can specify the number of rows and columns, and it will fill in the elements inside the array accordingly. So let's quickly switch over to the IDE, which is Google Colab, and check out how a 2D array works in Python. So here, I've named this particular file 2D array, but you can name it whatever you like. And I'm putting the code here. Let me explain the code. We've asked for the number of rows. So how many rows should your matrix have? I'll just call it a matrix, since we usually use rows and columns in a matrix. So the user should provide the number of rows, and we'll store that number in rnum, which stands for row number. Again, we'll ask the user to input the number of columns, right? So whatever number is given, an integer, a whole number, will be stored in cnum, which means column number. You can set up the variables according to the problem statement. So here, to keep things relatable, I've used rnum and cnum. Next, we're going to assign whatever values we have, right? The ones given by the user, whether it's the row number or the column number, we'll assign those along with the elements. To do this, we'll use a for loop because we need to print them one after the other. At the end, we'll print the final array, the final matrix, which is a two-dimensional array. I've just used an abbreviation here so it's easier for you guys to understand, 2D array. That's 2D for dimension _ RR. I haven't written out array completely, just R. So this is how we initialize and declare the variables, and this is how we execute the program. Let's quickly look at the output. So I'm running it, and it's asking for the first input, which is the number of rows. The number of rows I'm giving here is 2. Then I'll hit enter, and it will ask for the number of columns. So then it is 3. Here, I'm entering that, and it gives you 2 rows and 3 columns. Also, if you want, you can arrange it as a matrix, so one after the other. But here, I'm just showing it for you guys so you can see. You can count. You have 3 columns and 2 rows, right? The brackets define the rows here. The first set of brackets is for the first row, and the second set of brackets is for the second row. So this is how a 2D array works in Python. Now we're moving on to the third problem statement, which we're solving for arrays in Python. It says implement search, sort, and delete operations on an array of integers, right? So I'm breaking these 3 operations, search, sort, and delete, into 3 different programs to make it simpler rather than combining everything into one huge program. So first, I'm focusing on deleting elements inside an array of integers in Python. So let's quickly jump into the IDE and look at the program. Google Colab is ready and the page is empty. I'm just pasting this particular code to use our time efficiently. Now, explaining this code, the first line says enter the size of an array, right? We're first getting the array size. For example, it could be 10, 5, or 8, depending on what the user enters. Then we're inserting that many elements into the array. Say, for example, the size is 5, so we're inserting 5 different elements, which we've already seen by now. Next, it's asking which element to delete, right? So we're specifying an integer element to delete, and then it will display the new array for you. The for loops are there to keep the array in sequence. Whether it's for printing or taking input from the user, we're using for loops for both. And append is used to add elements to the end of the array, right? We're not inserting elements in the middle or at the front randomly. The insertion should happen one after another, sequentially. To append or insert elements, we use arr.append. So let's quickly see what the output is. If you enter an element that doesn't exist in this particular array, it will tell you element does not exist in the array. That's how the program works. So let's quickly check out the output now. So it's asking for the array size. I'm entering 3 and hitting enter, then entering all 3 numbers that I want to input. Okay, now it'll ask you which value you want to delete, right? I'm entering the value 5, so the new array is without 5, which means it's 4 and 6. So that's how it works, and right away I'll show you what happens if you enter an element that's outside the array bounds, how it will give you an error. So I'm entering 3 elements again, 5, 7, and 8. Right. So it will ask you which value you want to delete. I'll enter 1. 1 isn't in the array. It's just 5, 7, and 8. Right, so if you do that, it will say element does not exist in the array. So that's how deletion works in Python arrays. Now that we know how to delete an element from an array, next we need to see how to sort elements inside an array in Python. So let's quickly jump into the IDE and check out how to sort elements inside an array. All right, so here we'll start coding, just putting the code here. The array is already defined. The elements are 10, 22, 38, 27, 11, and so on. So we have 5 elements here to be sorted in ascending order, and you can also sort them in descending order as well. I'm showing you how to do it in ascending order. So what's happening here, I've just added a comment for better understanding, displaying the elements of the original array. Original array means whatever is here is displayed first. Next, it's sorting using a for loop. So it will check every element and try to compare it with the next element. If it is greater, it will push that particular element to the back, and whatever is smaller will come to the front. So this kind of swapping will happen, and it'll sort the array in ascending order. So ascending means from the smallest to the largest number. So it will quickly display, after sorting, the elements of the array sorted in ascending order are such and such. So let's quickly see what the output is. This particular code, right? So we have the original array that we gave, which is 10, 22, 38, 27, 11. And then we have the sorted array. In ascending order, it is 10, 11, 22, 27, 38. So this is how it will sort. The main function where the sorting happens is in these particular lines of code, which I'm highlighting in this IDE. Here, it will compare each and every element in the array to the next one. If it is greater, it will push it to the back. If it is less than the compared array element, it will push it to the front. So this operation happens in these lines of code. You can also sort by using the sort function directly as well. So this is a simple example to show how sorting works in Python. Now let's see how you search for an element inside an array. Here, I'll also show how to find the occurrence of an element. So let's quickly search and check for elements in an array in Python IDE. Okay, so this is the code to search for an element and also find its occurrence, right? So here, this is the array set. I'm giving the numbers 1, 2, 3, 1, 2, 5. You can see that 1 and 2 are repeated. Those two integers are repeated. So first, it is displaying the created array. Whatever array has been provided is displayed first. And next, what it's doing is trying to find the occurrences of the element. So with the help of the index, right? So for the element 2, the number 2, it shows where it is present and how many times, right? So first, it'll show where it is present. The second time won't be counted. The first occurrence will be counted. So let's quickly look at the output of this particular code, right? So here, the newly created array is whatever array the user provided is shown in the first line. In the second line, it says the first occurrence of 2 is at position 1. Why? Because it's 0, 1, 2, 3, 4, 5, right? So the first time 2 appears is at index value 1 in the array, right? Again, next, it's searching for 1. Where's the first occurrence of 1 in the array? It's at index point 0, right? So it's showing the output 0. Again, you have 1 here. That's 0, 1, 2, 3. Also, you have a second 2 in the fourth position, but still, wherever it is available first is what's being shown in this particular program, right? So this is how the occurrence is counted and how elements are searched in Python.
Now, let's talk about the advantages of arrays. Obviously, when you have indexes associated with the array, right, we have indexes, so it's easy for us to access any element, right? With the help of this index, if you want to access the third element, you can just go ahead and say r bracket 2 bracket in a 1D array, right? So you can directly access elements using indexing. Similarly, it's easy for us to iterate through it. Right, with the help of a single for loop, we can iterate through all the elements one by one that are present in the array. Similarly, if you want to sort, we can easily go through these elements one by one. And if we're trying to search for an element in the array, let's say we're searching for 3, then one by one we'll check. Okay, is this element 3? Is this element 3? Is this element 3? Is this element V? Is this element V? Right, and if this element is 3, we can easily search. And also for sorting, right? Let's suppose we want to sort this array. What would it be? It would simply be, what if you have 4 here, 3 here, 2 here, 1 here, and let's suppose you have 0 here, okay? So now you want to sort this in ascending order. So what will you do? We'll use 2 loops. One will focus on this first element, And then the second one will compare all the elements, okay? And then at the end of this process, you'll have the largest element at the end of the array. So sorting, iteration, searching, it is easy in an array where you just have to iterate through all the elements one by one. Now, it is a replacement for multiple variables. Now, what do I mean by this? Let's suppose you have an integer, or let's say you want to store the roll numbers of 10 students, right? So what would you have done earlier before you knew about arrays? You would have said roll number 1, or you could say S1, S2, S3, S4, and one by one, you could store the roll numbers in these integer variables, right? But as soon as the number of students increases, now let's suppose we're talking about 10 students here, but what if we talk about 100? Now what happens if we talk about 500? Are you going to write 500 integer variables starting from S1 to S500? No, that's a very inefficient way of doing it, right? So instead, what you can do is create an array. You can create an integer array and name it student, and there you will have the size, which obviously represents the number of students there are, and in this case, it will be 500. Now, if you want to change it, if tomorrow you want to change it to 600, you can go ahead and easily change it to 600, right? So it is a replacement for multiple variables. That's what it means. Now let's clear the screen, and now let's talk about disadvantages. One disadvantage that can be easily noticed is the size. Now, obviously, when you're talking about a 1D array, or any array, the size is fixed. So you cannot exceed the size. The elements cannot go beyond its limit. So let's suppose you have a size of 5. You can only store 5 elements. You cannot go more than that, or beyond that. Now, if you have a size of 100 and you're only trying to store 2 elements, the memory allocation for all 100 will still be there for this array. That means you're wasting memory. You're not using it efficiently. Okay, so this is what it means that the size is fixed and you can't store more elements, and if the capacity is greater than the occupancy, most of the array gets wasted. Okay, so these are 2 things. Apart from this, you need continuous memory allocation. That means if chunks of memory are available here and there, you can't store an array like that. Or let's suppose here you have 16 bytes and here you have 16 bytes. If you have an array that's 16 bytes, that's fine. But if you have an array of size 4, that array can be stored here. But if you have an array of, let's say, size 8, you can't store 4 elements here and 4 elements there. That won't work, okay? That can't happen because it needs continuous memory allocation. So that's another disadvantage. And last but not least, insertion and deletion are difficult. Now, why do we say that? Let's suppose you have an array, and in this array you have 1, 2, 3, 4. Now, suppose you want to insert a value 0 at this location. What do you need to do? You insert the 0, and then every other element has to be shifted. So swapping is required, right? Swapping is required. Plus, there should be memory available so that you can store that element. Otherwise, if there are only 4 elements and now you want to store 0 and the size is also 4, what happens then? You'll store 1 and the rest of the elements will be swapped and you'll end up losing this value. So it's very difficult to insert the value. The same thing happens when you're trying to delete, but at that time you won't be losing data, but yes, swapping is still required, right? So let's suppose you want to delete this location or delete this number. What will you do? You'll overwrite this with 3, you'll overwrite this with 4, and let's say if there's a 6, you'll write this with 6. So at the end, you'll have 1, 3, 4, 6, right? 1, 3, 4, 6, and 1 memory location will be left, and it will contain the same element, which is 6. So next time, you'll just overwrite this. So again, swapping is required. That's why it's very difficult to insert and delete an element in the array.
Now, let's look at the concept of a stack. Now, come into the stack. A stack is a linear data structure that follows the last in, first out order. That means the elements that are inserted last will be removed first. That's the LIFO order, last in, first out. Now, insertion and removal of elements are done at one end. I'll explain it to you now. So let's look at an example of a stack. So here, if I have 23, 45, 67, 89, 11, and let's say I have 50. These are the elements that need to be inserted into the stack. So now what I'll do is, let's say this is my empty stack, and I'll insert these elements into the stack one by one. So first I'll insert 23. After 23, I'll insert 45. Then I'll insert 67. After 67 comes 89, then 11, and finally 15. So this is my stack. Now, as I told you, the element that is inserted last will be removed first. That means last in, first out, or LIFO order. So as you can see here, 15 is the last element that was inserted. So now, if you want to remove an element, 15 will be the first one to be removed. So for insertion, we use push. So push is used to insert an element, and pop is used to remove an element from the stack. So 15 is the last element that was inserted. Now I will use pop to remove this 15. Once 15 has been removed, I have the elements 23, 45, 67, 89, and then 11, right? So if I want to remove another element, then my 11 will be removed. So again, I will write pop here. Always remember that the push operation is used for insertion and the pop operation is used for removal. So for all the elements I was inserting here, 23, 45, 67, 89, 11, 15, I was using the push operation. So if I write push 23, then 23 is inserted. After that, if I write push 45, then 45 is inserted. And after that, if I write push 67, then 67 is inserted. In this way, I can use the push function to insert elements. Now, as I mentioned here, insertion and removal of elements are done at one end. Why is that? If you look, this was my stack. So this is my stack. Whatever element I was inserting into an empty stack, I was inserting it through one end, and I was performing the insertion using the push operation. Now, if I perform the pop operation, I am also doing the pop operation through one end. That's why you can see that it's written here that insertion and removal of elements are done at one end. So this was the basic concept of a stack. Now let's look at an example of a stack. As you can see here, this is my pile of coins. So this can be considered an example of a stack. Why? Because the last coin is removed first here. So this follows the last in, first out principle. So I will remove one coin at a time. So if I am removing them step by step, that means the last coin will be removed first. And in this way, if I keep going, you can see that I can remove one coin after another, one after another. And in this way, this serves as an example of a stack. Similarly, the same example applies to DVDs. If I remove one DVD after another, then this can also be considered an example of a stack. So the DVD that was inserted last will be removed first. The same goes for books. The book that is on the top will be removed first. And after that, if I go one by one from the top, you can see that the last book that was placed will be removed first. And in this way, this can be an example of a stack. So that was a basic example of a stack. Now let's look at some functions associated with stacks. So we have the push function. As I mentioned, if I write here push 23, and let's suppose this is my stack. So this is an empty stack, so it'll insert 23 here. So as you can see here, it's used to insert the element x at the end of the stack. So here, instead of x, if I write 23, then it will insert 23. Similarly, the pop function, as I told you, pop will remove the element from the stack. So it is used to remove the topmost or last element of the stack. So if there's only one element in the stack, 23, and I write pop, then it will remove 23. And also, please remember that it will remove the topmost or last element. In this stack, we have only one element. So this will be the last element. So if I write pop, then 23 will be removed. But what if I write push here, let's say 25, then 25 will be inserted here. And once again, if I write pop, then this will be the last element. So 25 will be removed. So that was the basic idea about the push and pop functions. Now let's talk about size. So the size function will give me the size, or you could say the length of the stack. Next, we have top. So it'll give the reference to the last element present in the stack. So let's say this is my stack, and I have 23, 25, and let's say 27. So this is my last element here. So the top function will give me the reference to this last element. Now let's talk about the empty function. So the empty function returns true for an empty stack. So if this is a stack, and if this stack is empty, then the empty function will return true, right? So that was the basic idea about functions in a stack. And what will be the time complexity for each function? Here, the time complexity for each function will be big O of 1 for push, pop, size, top, and empty. So for every function, the time complexity will be big O of 1. So that was the basic idea about the functions. Now let's look at stack implementation. There are several ways to implement a stack in Python. We can use a list, we can use the collections module where we can use the dequeue class, and we can also implement it through the queue module. So these are some of the ways we can implement a stack in Python. Now let's look at the implementation using a list. When implementing with a list in Python can be used as a stack. So we can use a list as a stack in Python. In Python, we have the append and pop functions. We don't have a push function in Python. So if you want to insert an element, we need some function, right? So we can use the append function, which is used to insert an element. Now coming to the pop function, yes, we do have a pop function in Python, and pop removes the element in LIFO order. That means last in, first out. And as we know, our stack also follows the LIFO order. The elements that are inserted last will be removed first. So these are the two functions we'll be using here with lists. Now let's look at the logic for this. As I told you, a list in Python can be used as a stack, right? So here I'm using a list as a stack. So this is my stack variable, and it's an empty list. And now, as I told you, if you want to insert an element, you can use append. So this was my empty list, which is the stack. And as we know, in Python, a list is denoted by square brackets. Now, I'll write stack.append, and inside this append, if I write x, then x will be inserted into my list. Now, coming to the pop function, if I write stack.pop here, and if I use print and put it inside, then whatever element I have, it will remove it. So let's suppose this is my stack, and if I have the element x in it, then if I write stack.pop, it will remove this x element. Because I have only one element here, the last element will be removed from the stack. So this is the basic idea of how a stack can be implemented using a list. Now let's look at a practical example. So now for the practical implementation, I'll be using Jupyter Notebook. So I'll click on New here, and then I'll select Python 3. And if I'm writing here, I'll name it stack. And let me add a comment here first. I'll write a hashtag here and then write implementation. Using lift. So as I told you, that a stack can be implemented using a list. So I'll create a variable called stack, and this will be a list, an empty list. After that, I'll write stack.append here. And inside this, if I write welcome here, and after that, once again, I write stack.append, and now I'll write 2 here. Once again, I'll write stack.append. I'll write great learning. So you can see that this is my append. Now, if I print my stack, so I'll click on the run button, you can see that this is my list. Earlier, my list was empty, but now, through the append function, I've inserted welcome to great learning. So now this is my list. Now what I'll do here is, from this stack, I want to remove an element. So for that, I'll be using the pop function. So I'll write stack.pop here, and I'll put this stack.pop inside a print function. So I'll write print, and now let me execute this. So when I execute it, you can see that I'm getting great learning. So that means the element that was inserted last is removed first, right? And as I told you, pop will always follow the LIFO order. Last in, first out. So if I print my stack, you can see that I'm getting welcome to, because great learning has been removed using the pop function. If I write it here once again, let me copy and paste this. Control-C, Control-D. So once again, I'm performing stack.pop here, and if I print the stack, you can see that I'll only get welcome. So you can see that I'm getting welcome. And here, if I do stack.pop, then 2 has been removed, right? So clearly, we can see that we can implement a stack using a list with the append and pop functions. So this was the basic idea about implementing a stack using a list. So another way to implement a stack is by using deck. So we'll look at how to implement it using collections. Here, stacks in Python are created using the collections module, which provides the deck class. So now let's understand this is the collections module. In Python, I would write from collections. From the collections module, I'll import the deck class, right? I would write from collections, and then here I would write import deck. Deck here stands for double-ended queue. Append and pop operations are faster compared to lists. Why is that? Because the time complexity for DQ is O of 1, whereas the time complexity for lists is ON. Also, with lists, if you keep inserting more elements, the list will grow and eventually run out of a block of memory. So Python has to allocate more memory. That's why when you insert more elements into a list, it becomes slower. That's why we use another approach. From the collections module, we import deque, and then I create my stack variable and assign it to a deque. Right. Now I'll perform the same operations I did with the list. I'll use append and pop here. So always remember DQ is preferred over list because append and pop operations are faster here, and everything else works the same way. So let me run it. Now let's look at the implementation using DQ. Let me add a comment here. I'll write here, implementation using DQ. Now, as I mentioned, if I want to implement a DQ, it's a class, right? So I have to import it from the collections module. So for that, I'm writing here from collections import DQ, and then I'll create a stack variable and assign the DQ to it. Now after this, I'll write stack.append, and let me use the value x here. If I print my stack, so when I run it, you can see that my DQ contains x. Now let me add some more values. So I'll write stack here, .append y, and after that, I'll write stack.append, let's say z. And once again, if I run it, I'll write print stack here, and when I execute it, you can see that I'm getting x, y, z. Now let's perform the pop operation, so I'll write stack.pop. And let me put this inside the print function. As we know, if I write stack.pop here, the last element that was inserted will be removed first. So z will be removed here. So you can see that z has been removed. Now if I print my stat, I'm only getting x and y here, so you can see that list and DQ are the same. The only difference is that DQ is faster, because append and pop operations are faster in DQ. So this was the basic idea of stack implementation using DQ. Now let's see the stack implementation using Q. So here in the implementation using Q, the Q module contains the LIFO queue, which means last in, first out. So basically what happens here is that it works the same as a stack, but it has some additional functions. So it has some additional functions and works the same as a stack, right? Now we've seen that in both lists and DQ, we were using pop as well as append operations, right? But here to insert an element, we'll be using the put operation. So if I write put 3 here, that means it will insert 3 into my stack. Similarly, if I use the get function here, it will remove an element. And as I told you, it works the same as a stack, so the last element will be removed first. Now we have some functions available in the Q module. The first function is get. As I already told you, the get function is used to remove an element. Next, maxsize. Maxsize is the maximum number of elements present in the queue. Next, the empty function. If a queue is empty, it'll return true. Otherwise, it will return false. Next, full. Whenever the queue is full, it will return true. Similarly, put. I've already discussed put. If you are inserting any element, you can use put. Suppose I am inserting 2. It'll insert 2 into the queue. Now, queue size will give me the size of a queue. Let's suppose you have 3 elements that are inserted into the queue. 3, 2, 4. So what will be the size of a queue? Queue size will be 3. Now, come into the logic. So how can I import a WIFO queue using the Q module? So I will write here from Q, and then I'll write here import, and I will write here LIFO, and then I will write here Q. After that, as I told you, a stack can be implemented using the Q module. So I'll create a stack variable here and assign it to LIFO Q. So I write here LIFO Q. And now if I write stack.put and I write 2, this means I'm inserting the value 2 into the stack. Similarly, if I write stack.get here, that means I'm removing the value from the stack. So this is the basic idea. Now we will see all these functions in a practical coding example. So let's start with the coding part. I will write a comment here, and inside this comment, I will write implementation using Q. Now after this, what I have to do is import LIFO Q from the Q module. So what I'll write here is from Q import LIFO Q, and I'll create a variable called stack, and now I'll write LIFO Q. So after creating the stack variable, as I told you, if I want to insert an element into a queue, then I have to use the put function, right? So I'll write stack.put here, and let's say I insert 2. So you can see that I've already inserted the element 2. Now let me insert some more elements. I'll write stack.put and insert 3 here, and after that, I'll write stack.put, open parenthesis, 4, close parenthesis. So that's all about the put function, right? So we've seen several functions in the queue. So let me write function here. So here I'll write print, and if I write stack.queueSize here, as I told you, queueSize will give you the number of elements present in the queue. I've inserted 3 elements, so the queue size should be 3. When I run it, you can see that I'm getting queue size is 3. I've also told you about the max size function, right? Just to clarify, the max size function is used to set a limit on how many elements can be stored in a data structure. So here, if I write max size equals 3, it means that the data structure can only hold up to 3 elements, and if you try to add more, it won't allow it. If I write the print statement again here, and if I write out stack.full, just as I did before, then, so as I told you, the full function will return true if my stack is full. Here, I've set the max size to 3, and I've inserted 3 elements. That means my stack is full. So when I run it, you can see that I'm getting true. Right, because my stack is full. Now, if I want to remove an element from the stack, which function can I use? I can use stack.get here, and now if I print stack.full again, will I get a true value? No, because I've removed one element. So if I run it, you can see that I'm getting a false value when it executes. So here you can see that we've used the put function, get function, full function, queueSize function, and maxSize. So this is the basic idea behind implementing a stack using a queue.
Now let's try to understand the queue linear data structure. What is a queue? A queue is a linear data structure. That means all of the elements or items in the queue are stored in a linear fashion, one after another in a straight line. Now, it follows what's called the FIFO principle, which stands for first in, first out. This means there's a rule that whatever item goes into the queue first is the first one to come out or be removed from the queue. Okay, let's try to picture a queue in real life. For example, imagine you're standing in a line waiting to buy a movie ticket at the theater. There's one person at the front, then another person behind them, and then another after that, right? So here you can see there are a few people all waiting in line, one after another, just like the elements in a queue. And you're waiting in a queue. So now the first person in the queue will be the first one to get their ticket, right? Makes sense, right? So he'll be the one who gets his movie ticket first and leaves the queue. Then the next person in the queue is the next one who will get their ticket, right? And let's say a new person joins the line. He's not going to cut ahead of this person. Instead, he's going to get in line behind this person. And when the next person comes, they'll get in line behind this person, and so on and so forth. So this is basically the people principle, okay? The first person in is the first person out, all right? Now, insertion will always happen at the rear end, okay? And if you talk about deletion, it will always happen from the front end, all right? So this is our front end, and this is our rear. Cool. For example, buying tickets at a counter. It could be a movie ticket, or it could be at a bus station. You're at a bus station trying to get tickets for your bus, right? These are some examples. Now, there are 4 major operations when it comes to queues. What are those major operations? Let me clear my screen. So enqueue. So you're going to insert an element into the queue. That's what enqueue means. Dequeue means you're going to remove an element from the queue. Then peek first. You're going to peek at the first element in the queue. And peek last means you're going to peek at the last element in the queue. So you'll have 2 pointers. One is front and the other is rear. And with the help of these pointers, you're going to perform enqueue, dequeue, peek first, and peek last operations. Now, one major advantage of these operations, these 4 operations, is that all of them are performed in a constant amount of time. That means the time complexity for performing these operations is O of 1. That's why when you talk about competitive programming, the queue is the most commonly used data structure because of these things, right? Because of its time complexity, you're able to perform your operations in a constant amount of time. Now, let's talk about applications of queues. So it's used in scheduling algorithms of the operating system, like the first in, first out scheduling algorithm, round robin, and we have multi-level queues. In all these algorithms, queues are used for storing the data or the processes. It's also used in maintaining playlists. Like when you have a playlist, let's suppose you have 10 songs in a queue, right? And after one song, the next song in the queue will be played, and it goes on like this. So for maintaining a playlist, again, a queue is used. It's also used in interrupt handling. Let me give you an example here. You know the process state diagram of an operating system? So it's also used at that point. So when you have an interrupt, and if your process is being executed at that time, that process is pushed out and stored in a queue. Now, the next time when this priority or this interrupt is handled, once it's done, then it starts picking up the process that was in the queue and starts executing it. Meanwhile, if there are other processes, those processes will also be in the queue. So a queue is maintained, and once the interrupt is handled, they will start taking out the process that was being executed earlier, execute it, complete its execution, and terminate the process. So it's also used in interrupt handling.
After learning what a queue is in Python theoretically, let's see how to actually implement it. So a queue will have 2 basic operations. Those are enqueue and dequeue. These will be demonstrated with a simple example in Python. So let's quickly jump into the Python IDE, which is Google Colab. The reason I'm using it is because it's accessible to everyone, since it's available online and it's open source. So let's quickly start a simple program for a queue, showing 2 different functions, enqueue and dequeue. So here is the Google Colab environment where you'll be working. So what we're doing in this particular code is creating a class called Q, right? We're also providing different functions for NQ and DQ. NQ simply means entering or inserting values into the queue, and DQ means deleting values from the queue, right? As you all know, a queue follows FIFO, which stands for first in, first out. So, for example, whenever you want to buy a ticket at a railway station or anywhere else, you stand in a queue, right? Whoever is first in line gets the ticket first and then leaves the queue. It's the same here as well, except the elements aren't people, they're all integer numbers. So whatever number you put in first is the first number to come out, right? Now let's quickly look at this. We have two different functions, as I mentioned, NQ and DQ, and later you'll display. We're seeing three different functions, display, NQ, and DQ. So what happens here is we're using self.q.append, so whatever item or number you provide will be inserted at the back of the queue. It maintains the sequential process of inserting the numbers, integers, or values you give in order to insert them into the queue. And when deleting, you can use pop, right? So it's append for inserting and pop for deleting. And display is nothing more than a regular print statement. You'll display whatever is currently in the queue accordingly. So let's quickly run this program. Here, I've just used some numbers, 1, 2, 3, 4, 5 numbers in total. And after dequeuing, right, what should it display? It should remove 1 first, and then 2, 3, 4, 5 should be displayed. So let's quickly see how it works, okay? So as you can see, whatever the queue is given is printed first. That is 1, 2, 3, 4, 5. And then after removing the first element, right? So the first person will be removed because it's FIFO. So 2, 3, 4, 5 remain. This is how a simple basic queue works in Python. So after understanding a basic queue implementation, let's look at one type of queue, which is the circular queue implementation. There are many types of queues, but I'm choosing the circular queue as an example and showing you the same operations of inserting and deleting elements from the queue. So let's quickly hop into the Google Colab IDE and check out the program, How Can We Build a Circular Queue in Python? Here is the program for a circular queue, and let me tell you about the different elements we have inside this program. The first part is the class declaration. So here, my circular queue is the class, right? The class can be named however you like, so keep it very program-oriented rather than something off-topic. So here it is, my circular queue. And then again, we have two different initializations, one for NQ and one for DQ. So whatever elements we use here, whatever items we try to insert into the queue, we have to ensure whether the queue is full or empty and whether there is still space or not. So all these conditions should be checked. So let's jump into NQ and check out what different conditions you have to verify. So the first thing is to check whether the queue is full or not. So before inserting something, for example, if the queue size is 5 and you're trying to insert a 6th element, then it should display an error message, which is, there are only 5 spaces. They are inserting a 6th element. That is not allowed. So the queue's full. Therefore, to display that, we use the statement, the circular queue is full. Now, the next thing you need to know is how to tell when it is empty, right? For dequeuing, the main condition is that whenever all the elements are removed from the queue, it should be declared as empty. The queue is empty, so there's nothing to delete from the queue. All the elements or items have already been removed. So the error message or the statement to the user will be, the circular queue is empty. There is nothing to pop out, delete, or dequeue. Besides that, if you try to print something and the queue is empty, since it doesn't have any elements, you should display the statement, no element in the circular queue. Why? Because if there are no elements, there's nothing to show or display. The display function doesn't work. Nothing gets printed. So that's the basic idea behind this particular code. And accordingly, we've used iterations and declarations. Next, you need to look at the inputs we're providing. I'm trying to input 12, 22, 31, 44, and 57. Right. So 5 elements have been given to the queue. And what you need to do is first check the initial values. You have to display the initial values, showing the user exactly what queue you've given with the elements, and then which element is deleted. So obviously the first element gets deleted. But yes, how is the circular queue different from a basic queue, right? So let's quickly run the program to see the output. Okay, if you look at the output here, right, the initial queue values are exactly what we entered, 12, 22, 31, 44, and 57. So after removing an element, obviously the first one, And as per the process, the first element will be removed. So now it's 22, 31, 44, and 57. What's the difference between a normal queue and a circular queue? If you look here, right after 57, there's a space allocated at the end. In a normal queue, it's not connected. Here, the front and rear are connected, forming a circle, right? If the first element, for example 12, goes out, then 22 will move to the first position, followed by 31, then 44, and then 57. The last spot will be empty, right? So it's in a circular motion. So whatever you want to insert, again, right? So for example, if you want to insert 6, right? 6 will take the 5th position, which is right after 57. Right, this is how it will be connected in a circular motion, meaning the front will be connected to the rear. So this is the difference between a normal basic queue and a circular queue.
Now, let's talk about the advantages and disadvantages of queues. First, let's discuss the advantages. It follows the FIFO principle, or first in, first out, meaning the elements are stored in a FIFO manner. That means, let's suppose this is a queue, and you have elements in it. The deletion will happen from the front, right? And the insertion will happen from the rear side. So this is known as DQ, the deletion, and NQ, the insertion operation. And both these operations are performed in a constant amount of time. So that's definitely an advantage, right? And insertion at the beginning and deletion from the end also take a constant amount of time. Plus, if we want to do peak first or peak last, all these operations can be performed in a constant amount of time, and this is the most widely used data structure when we talk about CP, which is competitive programming. When we talk about competitive programming, this data structure is most commonly used because of these features. All the operations performed, like insertion, deletion, peak first, peak last, NQ, and DQ, are all done in constant time. Now let's talk about the disadvantages. Since we are only able to delete or insert from the front and the rear, that means deletion from the front and insertion from the rear, there's a restriction on insertion or any manipulation, right? We have a restriction over these operations, insertion and deletion. So this restriction is always there, and the state of the structure, that is the queue, is not very flexible. We're limited. We can only delete and insert elements in a fixed pattern or in the FIFO manner because it's not very flexible.
So now let's start with the linked list. A linked list is a collection of a group of nodes. Now, what is a node here? So here you can see that this is a node. A node will contain both data and a reference. So each node contains data and a reference which holds the address of the next node. So this is a node. And as I told you, a node will contain both data and a reference. So let's suppose I'm inserting the data 20 here, and this is nothing but a reference, or you could say a pointer. So this pointer will contain the address of the next node, right? So as I told you, a linked list is a collection of nodes. So this is just a single node. So let's suppose I have more than one node, and if I connect them, then it'll form a linked list. So we'll look at the linked list representation in the next slide. Now, a linked list is a linear data structure. Now, coming to the last point, we know that in arrays as well as in lists, elements are stored in contiguous memory, whereas in a linked list, elements are stored randomly. Now, let's look at the representation of a linked list. So, as I told you, a linked list is a collection of nodes. So, let's suppose this is my N1 node. This is my N2 node, and this is my N3 node. So, each node will contain data as well as a reference, or you could say a pointer. So, this is the data, and this is the reference. Now, I will give the address of this N1 node. So let me write the address of this N1 node as 2010. I'll give this one the address 2020, and I'll give the N3 node the address 2030. So these are the addresses. As I told you, each node will contain data. So let me assign your data. Let's suppose 10 is here and then a reference, or you could say a pointer. So I told you about pointers, that a pointer will contain the address of the next node. So what is the address of the next node? The address of the next node is 2020. So I'll write 2020 here. So this pointer, or this reference, or you could call it this link, will contain the address of my next node, and the address of my next node is 2020. Now again, this will be data, and this will be the reference for my N2 node. So let me assign the data here as 20, and what will the reference be? The reference will contain the address of the next node. So here it'll be 2030. Now again, this N3 will also contain data, so I'll assign 30 here. So now you might be wondering, what should the reference be here? So now, do you see any node after this n3 node? Do we have an n4 or n5 No. Blank. So this reference will be set to null. So I can write 5 here because there is no next node present, right? Now, coming to the head, what is the head? So the head will contain the address of my n1 node. That means 2010, right? So this is my linked list representation. Now, the question arises, why a linked list? So why do we need a linked list? Because a linked list is more efficient for performing operations compared to a list. So what are the operations that we perform in a linked list? We can perform operations like insertion, deletion, as well as traversal. So it is more efficient when performing these operations. Moving to the next point, as I already mentioned, in a linked list, elements are stored randomly. Whereas in a list, or you could say in an array, elements are stored in contiguous memory. Now, moving on, accessing elements in a linked list is slower compared to a list. So if you want to access an element in a linked list, it will be slower compared to a list. Why? I'll tell you the reason now. Let's look at this slide showing the linked list representation. So here, this is my entry node, right? And if I want to access the data elements of this entry node, I have to go through N1, N2, and N3. Only then can I access the elements. Whereas in the case of a list, we can access elements using indexing, but in a linked list, that's not possible. So you have to traverse. In other words, traversal here means you have to go through each node. So if you want to access the elements of N3, you have to start with N1, then go to N2, and only then can you reach N3. That's why accessing elements in a linked list is slower compared to a list. Now, coming to the last point, in a linked list, memory utilization will be higher compared to a list. So let's start with the singly linked list. I've already shown you the representation of a linked list, which is the same as a singly linked list. So in a singly linked list, each node contains data and a reference. Let's suppose this is my N1 node, this is my N2 node, and this is my N3 node. So as I told you, each node will contain both data and a reference. So I'll put the data as 10 here, 20 in node 2, and 30 here. And each node has an address. So let's say the address of this N1 node is 1000. This one is 1100, and this one is 1200. So this reference, or you could say this link or pointer, will contain the address of the next node. So this will contain 1100. Similarly, this reference or link will contain the address of the N3 node. So I'll write 1200 here. And here, after the N3 node, do you see any other node? We don't have any more nodes. So here, this link or reference will be null. Now coming to this, what is the head here? So the head will contain the address of my first node, which is 1000. So in a singly linked list, traversal is only done in one direction. So what do you mean by traversal? Traversal means that you go through each node one by one. So let's suppose you want to go to the N3 node. You first go to N1, then N2, and only then can you reach N3. You can't jump directly to N3. You have to go through N1 and N2, and only then can you get to N3. Now let's look at some operations in a singly linked list. So there are several operations in a linked list. We have insertion, deletion, and traversal. Insertion and deletion can be done at the beginning, at any specified node, or at the end. Now, coming to traversal, as I already told you, traversal means you have to go through each node. So going through each node of the linked list is called traversal. Now, let's look at the pseudocode for a singly linked list. So if you want to create a node in a singly linked list, what should the code look like? So first, I'll write class node here. So here, I've created a class named node. This class node will also have an object, right? I'll create the object later, but let's see for now. Let's suppose this is my N1 node. As I mentioned, a node will contain both data and a reference, right? So instead of reference, I'm writing next here. I'm using a shorter word here to make the coding easier. Now, this is my node creation. Now, what I'll do here is, in this node class, as you can see, I'm creating an init method, or you could call it a constructor. So to create it, first I'll write the reserved word def, and then I'll write the init method. So I'll first write def, then double underscore init, then double underscore again, and then I'll write self, and then comma comma data. Why did I write self? I'll explain that later. I've also passed data as a parameter here. Inside this, I've written self.data equals data, and self.reference equals none. Why did I write this? Because my node will contain both data and a reference. In this method, I'll write self.data equals data, and for self.reference, since I've written next here, I'll use next here as well, is equal to 9. So when you're creating a node, let's say this is node n1, initially it will have some data, and since I'm just creating the node, I'm not linking it to anything yet. So the link, or you could say the reference, will be none, right? So this is my initial node. I've written here self.data equals data and self.next equals none, right? Now this is a class, so I can create an object from it. How do you create an object? I'll write 1 equals class name 7, and inside the class, I'll pass the parameter 7. Now, what will happen? Instead of self, my object will be passed here. So my n1 will be passed here instead of self. So now it will be n1.data equals, and what is my data? The data is 7. Now the next step is self.reference equals none. Let's look at this here. Self.next. So instead of self, it's my n1 there. So n1 will be passed here. And for n1.next, I'll have none. So this is basically just creating my node. Now, if you want to check, we can use the print function. And when you write node1.data inside a print function, you'll see that you're getting the value 7. Similarly, if you write node1.reference inside a print method, you'll get none. So now this is the idea of how to create a node. Now let's see this in code. So here I'll be using Jupyter Notebooks. So I'll go here to New, and then I'll click on Python 3, and here you can see that I'm getting the name untitled21. Let me change it. I'll write linked list here, linked list, and I'll write Python here. Now let's create a node. So I'll comment it as creating a node. First, I'll create a class and I'll name it node. And inside this node class, I'll create my init method. So here I'll write def, which is a reserved word, and then I'll write init. But before that, I'll write double underscores. Then again, I'll write double underscores, and then I'll write self data here. So why did I write self here? So when I'm creating a class object like n1, I have already shown you in the example, instead of self, n1 is passed. As we know, we can create multiple objects of a class. So if I write n2 or n3 here, then instead of self, I could also pass n2 or n3. So now let's create a node. So I'll write here self.data equals data. And I'll write here self.next, and I'll set it to none. So this is how I create a node. So whenever I have a node, it will contain data and it will have a reference. So initially it's not linked. So the reference is none. So this is my class. Now I'll create an object of node. So I'll write n1 here, and I'll write the class name. And I'll pass the data as, let's say, the value 8 here. So if I execute this, when I execute it, this n1 will be assigned to self, and this 8 will go into the data. So my n1.data is equal to 8, and my n1.next is equal to none. Let me print it. So if I write print here, and inside that, if I write n1.data, again, if I use the print function, and inside that I write n1.next, then you can see that I'm getting the data as 8, and for next, which is a reference, I'm getting none because I haven't linked this node to any other node. So this is the basic idea of how to create a node. Now let's see how to create a class for a singly linked list. So when will my singly linked list be empty? As I told you, if this is a node, let's suppose n1, and this is another node, n2. So n1 and n2 are connected to each other. So we have a head pointer that always points to the first node, right? So if there is no head, if head is none, then my linked list will be empty. So now what I'll do here is create a class, and I'll name the class, let's say, singly linked list. And inside this class, once again, I'll write the init method. So here I'll write def double underscore init double underscore, and I'll put self in the parentheses. Now here I'll write self.head equals none. So this is my setup for creating a class. So if the head is pointing to none, that means it's not pointing to any node, and it shows that the linked list is empty. So now let's look at how to create a singly linked list. Yeah, so let me remove this. Now create a class. Create a linked list. Create a class for the linked list. Singly linked list. Inside this class, I am going to write the initialization method, which is commonly known as the init method. Inside this singly linked list, I'll create an init method. I'll write def double underscore init double underscore, and then I'll put self here. And when my linked list is empty, self.head will be equal to none. So this is the simple way to create a singly linked list class. Now, after creating the class, let's create an object of this linked list. So I'll write SLL as the object name for singly linked list, and now I'll write the class name, which is singly. So capital LL is there, right? So on execution, always remember, whenever you create an object and execute it, the init method inside this class will always run. I'll show you an example. If inside this init method, let's say I write print Gorov. So I've created the object here, SL, and right now, if I execute it, you can see that Gorov is being printed here, right? So always remember, whenever I create an object of a class and execute it, whatever statements are inside the init method will be executed. So when I actually run it, what will happen here is that I'll get skel.head equals none, right? So FLL is my object. So instead of self, SLL will be assigned here. So SLL.head equals none, right? So this is my basic concept of creating a node and creating a linked list.
Let's talk about searching algorithms, and the first searching algorithm we're going to discuss is the linear search algorithm. So what is linear search? It helps us search for an element in a linear data structure. Now let's look at an example where we'll search for an element inside an array. So let's suppose this is an array, and the elements are 10, 20, 30, 40, and 50. Now if we're trying to search for the element 50 in this array, the way linear search works is that it checks each and every element to find the one we're searching for, right? That is, it checks every element in the array, right? Let's talk about this example here with 50. Now, 50 will be compared, right? We'll check, is this 10 equal to 50? No. Is this 20 equal to 50? No. Is this 30 equal to 50? Is this 40 equal to 50? Is this 50 equal to 50? Yes. So here we were able to perform a linear search, right? We were searching for this element inside the array one by one. We compared first with 10, then 20, then 30, then 40, and finally with 50. At the end, we were able to find this element in the array in a linear fashion. Now, this is what is called a linear search. Now, let's talk about the linear search algorithm. Since it is a very straightforward, or you could say a brute force algorithm, right? It's a brute force way of finding an element in the array. This is how it works. We have a for loop where we iterate through all the elements from 0 to n, and inside that, what are we doing? We're looking for the item, that is, the element we want to search for. Let's suppose this is 50. We're checking if this 50 is equal to the element at AR of I, right? And then if that's the case, if we find the element anywhere in the array, we'll return its index, right? That is the index, right? So I will return this I. Now, there might also be a case where we're at the end of the array and we've already checked the last element, and we still weren't able to find the 50, right? Let's say the array is 10, 20, 30, and 40. Now, this 50 is not present in the entire array. At that point, what we're going to return is -1. So we'll say, okay, we weren't able to find this element. Whenever we return this -1 in this array, it means we weren't able to find that element.
Now let's see how to implement linear search in Python. Linear search works with the help of an array here. So what we're doing is searching for a single element throughout an array in a sequential manner. This is how linear search works. So here, as you can see, we have an array, we have the number you want to search for, and you have the starting position variable. During the iterations, the array will move on, searching from one place to another, from the first place to the second, second to third, and so on. In total, we have 5 different elements in the array, which means 4 different places, because arrays start from 0. 0, 1, 2, 3, 4. So the index goes up to 4, and there are 5 elements. First, we need to take the key element we're searching for and compare that particular element to all the elements inside the array. Right. So if it doesn't match, if the array doesn't contain the number you're searching for, it'll throw an error called element not found. If it is found, it'll show you the index value, meaning the position in the array where it is located. So let me quickly run the program for you. So I'm trying to search for the element 1, right? The element 1 is at index position 3, 0, 1, 2, and 3. So x is the variable used to find which number it is. It just acts as a key. X will act as a key, and you can change this and check if you want to search for something else. For example, if it's not there in the array at all, it will say element not found. If you want to search for 2, for example, the answer should be 0, right? Let's check. Right, so the index value is 0. It's located in the first place of the array. If you want to search for 9, it's at the last place, so that's 4, right? So this is how the value you want to search for is always compared with all the elements sequentially, one after the other. For example, 9 is compared with 2. It's not matching, so it will go to the next one. 9 is compared with 4, it's not matching, and then with 0, again compared with 1, not matching, and it'll go to the ninth. The ninth place is where it's located, right? It'll compare the elements one by one, in order. So that's how linear search works in Python.
Now, let's talk about the time complexity of linear search. Now, if you look closely, let's try to understand the best case scenario, okay? So now, if you're searching for an element, and let's say these are the elements in the array, now suppose in the best case, what could happen? You're looking for 10, and 10 is the first element in the array. Now, how many iterations did it take to find 10? None, right? It's constant time, just one single operation, and you're able to find 10. So this is the best case time complexity, where the element you're trying to find is the very first element you search for. In this case, you were looking for 10, and 10 is the first element, so that's your best case. Now, what about the average case and the worst case? Let's say the average case is when you're looking for an element that's in the middle, right? Let me see. 0, 1, 2, 3, 4. Or you could add another one and look for 60. In this case, or you could just skip it. Okay, no need to add one more. Okay, so now you're looking for an element that's somewhere around the middle. Okay, in this case, you're looking for 30. Okay, so if you notice, you're only iterating through half of the elements. That's 5 divided by 2, which is basically n divided by 2. Since constants don't matter when you're talking about time complexity, so that's why the average still comes down to big O of n. Now, what happens in the worst case? You're looking for an element that's 50, which is at the end of the array, or in the worst case, you're searching for something that's not even in the array, like 60, let's say. In that situation, you'll still have to go through the entire array, and that's why the worst case time complexity is also big O of n, because you're iterating through the whole array and the element wasn't found. You're looking for 60, and it's not there. So you end up iterating through the entire array. That means you've performed n operations. That's why it comes down to O of n. Now, let's talk about the space complexity of linear search. When we're trying to find an element in the array, say 10, 20, 30, 40, and 50, we weren't using any extra memory, right? We're not using any auxiliary memory, that is, any extra memory, to find that element. We were just looping through these elements one by one, and we were doing it on the same array that we were given, right? Since we're not using any auxiliary memory, which could be a stack, a linked list, an array, a string, or a queue, we're not using any of those because they're not needed, right? We are searching for an element in this particular array that was given to us, right? So the space complexity of linear search is constant, right? We were able to find it using a constant amount of space, okay? We are not using any extra space. Now, let's try to understand the binary search algorithm. What is binary search? So binary search is one of the searching techniques, right? Like we saw in linear search, where the time complexity of linear search was big O of n, right? We were iterating through all the elements, and now this is a much more efficient algorithm compared to linear search. Now, again, why do we need searching? The thing is, let's suppose you have a given set of elements, which could be numbers, words, or any kind of data, and you want to check if a particular element, a specific value or item, is present in your array or not. At that time, right, you can use either linear search or binary search. Now, binary search is much more efficient compared to linear search, and it is used on a sorted array, or it can be used on an array where some order is maintained, because based on that order, we will divide our array, right? It's a searching algorithm that follows the divide and conquer strategy, which means it breaks down the problem into smaller, more manageable parts, and then solves each part individually. Let's suppose this is our array, and now, since it will be divided in such a way that we can ignore one part of it, right? We will be dividing and then conquering. That means we will then search for our element in the remaining part of the array. Now, let's suppose we are looking for something. Let's take an example where this array is written, or the elements in this array are arranged in such a way that if we skip this part, either the left-hand side will be skipped or the right-hand side can be skipped in such a way that they don't affect our output. So every time in binary search, our search space is reduced unless and until we find that element, or the array is exhausted. In other words, with each step, the number of elements we need to consider becomes smaller and smaller, making the search process much faster and more efficient than checking each element one by one. This is why binary search is preferred when dealing with large, sorted datasets, as it saves time and computational resources. The process continues, dividing the array and narrowing down the possibilities until either the desired element is found or there are no more elements left to check, at which point we can conclude whether the element exists in the array or not. This method is fundamental in computer science and is widely used in various applications where quick searching is required. Okay, so our search space is reduced to half in every iteration. This is what binary search is. We look for an element in such a way that every time we are ignoring half of the array. Let's take an example. When we have this entire array, so the first half, that means if there are 8 elements, 4 on this side and 4 on that side, these 4 will be ignored. Then we have 2 on this side and 2 on that side, these 2 will be ignored. Then 1 on this side and 1 on that side, then this one will be ignored, and so on until we find that element or the entire array is exhausted, right? So this is how your binary search works. Now let's try to understand the binary search algorithm. First, we are going to understand the iterative approach, and then we are going to understand the recursive approach. So iterative, as the name suggests, we are going to use for loops, right? We will start with a for loop and it will iterate, and we will keep iterating as long as the beginning is less than the end, right? Because we will be updating either our beginning in some cases, and in some cases we will update our end. Now, what happens is, since we know that in this iterative approach, or in binary search in general, it doesn't matter whether we use the iterative or recursive approach, the logic remains the same, right? So we will have this array, and it will be in some order so that we can ignore some part of it. It doesn't always have to be sorted. We can still apply binary search even if the array is not sorted, as long as there is some order so that we can ignore some part of it. Because, again, keep in mind that it follows the paradigm of divide and conquer. So now we have the beginning and end in place, and we will always iterate as long as the beginning is less than the end, right? So what happens after that? Now we have this beginning, and what will we do? Let me take new pointers. So this is your beginning, and this is your end. This is your beginning, and this is your end. Now you'll take a new middle index, right? Let's call it M. Now let's label these positions 0, 1, 2, 3, 4. So what you'll do is beginning plus end divided by 2, so that some part of it can be ignored, right? So it will be 2. So your mid is at this position. Now you'll check, okay, the element I'm looking for is, let's suppose, 50, and the element I'm currently at is 30. So obviously, it will never be on this side. There's no chance we'll be able to find 50 on this side, which is the left-hand side, right? First, we'll check, okay, is this 30 equal to 50? No, so that condition will never be true, right? Then we'll check, is my item, that is this 30 less than or greater than 50? If it's greater than 50, right. If the element, that is, if the item, which is 50, is greater than 30, right? Which in this case are 50, the element we're looking for, the item, is greater than 30. So there's no point in searching on this side. So we will skip, or we will ignore this half of the array. That's why our new starting point gets updated. It will be no. It will be the middle index plus 1. That is, the middle index was 2 plus 1. So this will be our new starting point. So we've cleverly skipped half of the array. So now, let's move on. Let's drop all of these things for now, and see what happens in the next iteration. Now keep in mind that we're not looping or going beyond this limit. That is, the beginning should always be less than or equal to n, okay? So this condition must be maintained. Similarly, we'll divide our array again and look for the same things, right? First, we'll look for the element, then we'll skip some part of it. This is the iterative approach for binary search. Now let's look at the recursive approach, or recursive algorithm for the same. Again, the ground rule remains the same. We'll always iterate or recursively call binary search as long as the beginning is less than the end. Done. Now what happens? We'll again find the middle index, which is beginning plus end divided by 2. Then we'll look for the elements. These 3 steps remain the same, even if you're using the recursive approach. Now what happens in recursion? We call the function again and again. That's what recursion is. In this entire tutorial, we'll cover recursion as well, but in the later part of the course. Here you can get a good intuition, or let me give you a brief intuition about how recursion works. Let's suppose this is your activation record. Every time recursion happens, an activation record is created. So let's say you have these three statements, and in your algorithm, you have statements P1, P2, and P3, right? And at P2, you're calling the function again, right? You're calling this function again. So what happens? An activation record is created. It will check, okay, is this statement executed? Yes, so 1 is executed. Is the second executed? Yes, so the second is executed. But at the second, you're calling this function again. So at that time, a new activation record is created. Now the third step is left behind, right? This will be covered when we come back or return from this function call that we made here. So let's suppose this function was here. Now in here, you are returning, right? This function call, let's suppose this is not less than beginning. Beginning is not less than end, so this case is kind of relatable, right? It's similar to what we're looking for. Let's suppose there's a similar situation where beginning is not less than end. At that point, you'll return from this. Now, once you've returned, you'll then call this function again, but this time for this case. And let's suppose this time when you call it, step 1 is executed. Step 1 is executed. Now, again, this activation record is 1, and then again, this is called, right? This is executed, and again, this 2 is called. Again, a new activation record will be created, and these 3 steps, the third step will still be left for execution. So now, here you return, right? Then it will go back to this step, right? And then once you are done with this, now there are 2 positions or 2 possible scenarios where you can return. Either you are returning from this function, just like we executed this condition and returned, right? Another is that once you are done with this entire activation record, at that time, you will also return, okay? So these are the 2 scenarios. Now you have executed this. There is no step to be executed. It will return. Now this was left behind. This will be executed. Now nothing's to be executed. It will go to the caller, which was this. And finally, it will go to the main method where it called this in the first place, this function. Okay, so this is how an activation record is created. A stack is maintained. Okay, even if you might be thinking we're not using any extra space, but whenever recursion is involved, there is extra space in the form of a stack, and that stack is maintained. So you need to keep this in mind when you're dealing with space complexity, especially when you're using recursion. Okay, so now with that being said, let's clear our screen and see how recursion is called here. So again, now recursively, what we'll be doing is, now we have this mid, right? And let's take an example of an array, 0, 1, 2, 3, and 4, 10, 20, 30, 40, and 50. So the middle index will be 0 plus 4 divided by 2, which is 2. So this is our middle index, right? So this is 0, this is our beginning, and this is our end, right? So now we've landed here, right? So again, we check if the 50 we're looking for, this is the item we're searching for, okay? So is it 50? And this is our middle index. Is 30 greater than 50? No, it's not in this case, so this will never be executed. This is not executed as well. Right now, what about this condition, the else part? Now what we'll be doing is, since this 30 is less than, we'll be skipping this part, and we'll focus on middle index plus 1, which is nothing but this. So this will be a new beginning, and our process will start moving right. So now, again, the same thing will happen unless and until this condition is false, okay? So this is how your binary search works when you're using recursion. So now let's try to understand binary search and let's see its demonstration, okay? So we are looking for 20 and this is our array, right? 10, 11, 16, 20, and 23. Now this array is sorted, right? So we can apply binary search, okay? Since we can neglect some part of the array based on some conditions, okay? So now our beginning in the first iteration, what is happening? Our beginning is 0, our end is 4, and our middle is this element. Now what we will be looking for is 16 equal to 20? No, it is not, but 16 is less than 20, so we will skip this part. In the next iteration, what happens? We'll be focusing on these 3 elements, right? That is, we'll be focusing on this part rather, like we say, we'll focus on this part, right? Focus on this part, okay? So now in the second iteration, what will be happening? Our beginning is updated. Now our new beginning is this point. Our end will remain at its own position. Now we'll find the middle index. So it will be 4 plus 3, that is 7, right? And divided by 2, it is 3.5, right? So since this will be truncated, right, the truncation will happen and the integer that is there, the middle index will be 3. So this is our middle index, right? So you can see middle index is 3. Now, is this the element that we are looking for? Yes, so we will return the index. So we found our element at index 3, and hence we return 3. Because if you observe carefully, it is returning, if the element is found, it is returning the index. So this will be returned, okay? So this is how binary search works.
After understanding what binary search is, which is a fundamental and widely used algorithm in computer science for efficiently searching sorted arrays, we'll quickly implement it in Python by switching over to the IDE, which stands for Integrated Development Environment, a tool that helps us write and test our code. So binary search has 4 important elements that are crucial to its operation. The first is the array, which is the collection of elements we want to search through. The second is the element to search for, which is stored in a variable called x. And then there are 2 more variables, low and high, which represent the starting and ending indices of the array, respectively. Why do we need these? Because for any array to perform binary search, it needs to be divided into 2 parts, right? This division is essential for the algorithm to work efficiently. It works like this. If the key, that is, the element you're searching for, matches the middle element of the current subarray, the binary search will exit immediately, returning the index or value of the found element. If not, it will continue searching for that particular element in halves of the array, dividing it into right and left parts and searching for the element accordingly based on the key. So the calculation for the middle index, often called mid, is as follows. Mid is equal to low plus high minus low divided by 2. This is the basic formula we'll use to split the binary array for the search, and it's important because it helps us avoid potential overflow errors in some programming languages. If array of mid, that is the middle element, is equal to the key element you're searching for, it will immediately return the middle element as the found element, indicating that the search was successful. Otherwise, if the middle element is less than x, it will search the right side of the array. If it's greater than x, it will search the left side of the array. This process of having the search space continues until the element is found or the search space is exhausted. So it keeps searching in halves, making the algorithm very efficient compared to linear search. Thanks, SubBuddies, for following along as we break down and implement this essential algorithm step by step. Here, if you look at the array, 3, 4, 5, 6, 7, 8, and 9, you have all these elements inside the array. What you need to search for is 4. So 4 is the second element, and you can spot it right away, but you have to search according to the binary search rules. What happens is it will first split this array into 2 halves using the formula, and then it will compare the key element you're trying to find with the elements already present in the array to locate it. So let me quickly run this. Okay, it's telling me that the element you're searching for is present at index number 1. That means it's giving the array index count, not the element itself. So 0, 1, 2, 3, and so on. So 4 is present at index value 1. This is how binary search works in Python.
Now let's talk about the time complexity of binary search. In the best case, so what is the best case? Let's take an array, and in that array, the elements are 1, 2, 3, 4, and 5. Now, the best case is not like in linear search, where the best case scenario is when the element you're searching for is right at the beginning. In binary search, the best case scenario is when your middle index is at the location of the element you're searching for. Say you're searching for 3 in the entire array. In that case, it will take a constant amount of time, and that's the best case time complexity. Okay, now what happens in the average case? If you talk about this algorithm, let me just clear my screen, it follows a divide and conquer paradigm. So let's suppose you have 8 elements. First, the array will be divided into 4 and 4, because either the left side or the right side will be ignored, and then we focus on the remaining elements. Okay, these 4 elements will again be divided into 2 and 2, then we'll ignore 2 elements, then 1 and 1, and again, one of the elements can be ignored. So there are 1 and 1, and we focus on this element. So the entire operation, or the entire search, will be completed in 3 steps. Right now, if I take this example and calculate log base 2 of 8, what should the value be? Obviously, when I do this, it can be written as 2 raised to the power 3, right? And this can be written as 3 times log base 2 of 2. Now this is 1, and now you get the answer is 3, so this 3 and this 3 are equal. That means If I talk about the worst case time complexity of binary search, it will be around log n, because as we saw, in 3 steps, we were able to find the element, and log 8, which is the answer, is also 3. So you get the point, right? So the worst case time complexity of binary search is log n, and the same goes for the average case, where it will be somewhere around log n divided by 2. Neglecting log n divided by 2, neglecting the constant terms, it again boils down to big O of log n. Okay, now let's talk about the space complexity of binary search. Now, when you talk about space complexity, right, we only think of auxiliary memory, or you can see any extra memory that you guys have used. Since we did not use any extra memory, that can be in the form of anything, or it can be in the form of a stack, or it can be in the form of a queue, or a linked list, or even strings, right? Since we never use these extra memories in our implementation, the space complexity of binary search is big O of 1. That is, it takes a constant amount of space. What is insertion sort? So the question is, what is sorting? You might be thinking, why do we need these sorting algorithms? So if I told you that you have a bunch of students, right? You have a bunch of students and they each have their roll number. They are not present in what? In numerical order, or you can say they are not present in any order. I want that order to be maintained. Let's suppose you have 1 to 10 students in that group, and each of them has roll numbers from this range, from 1 to 10. Now, some of them are absent, and some of the roll numbers have left the school, but the roll numbers haven't been changed yet. Now, what did I tell you? I told you please sort them or arrange them in such a manner so that I can easily understand which roll number comes after which, either in ascending or descending order. Suppose there's 1, then 2, then 6, then 8, then 10. So the rest of the roll numbers I can easily figure out, okay, these are the ones that are either missing or absent. To do this, we have these sorting algorithms, and one of those sorting algorithms is insertion sort. Now, it's the simplest, easiest, and a brute force sorting algorithm. Now, what do you mean by brute force? Brute force means straightforward, right? In a naive way, it means straightforward. That means you're not taking into account, you're not considering any efficiency, or you don't care about time complexity or space complexity. You just go ahead and sort it in the simplest and most naive way. In this brute force algorithm, what happens is, let me give you an example. Obviously, we can sort using this insertion sort algorithm. You can, of course, sort either in ascending or descending order. Let's take an example. We all know about the card game, where you have a bunch of cards. Suppose you have a single card in your hand and a bunch of cards on the table. Now you start picking up those cards one by one. Obviously, the one that's in your hand is already sorted. Because if I told you to sort just one number, obviously if there's only one element in the array or in anything like a linked list, and I ask you to sort it, if there's only one element, it's already sorted, right? You don't need to sort that. Similarly, what happens now is that this card is in your hand, right? It's just like playing cards. Now you have this one card in your hand, and it's obviously sorted. So what do you do next? On your next turn, you start picking up cards one by one from the set of cards on the table. Now let's suppose this is 0, okay? I'm using numerical values here so you can understand and connect the dots. So what happens is, you have the 0, and now you start comparing it. We're considering the scenario where you're trying to sort in ascending order, okay? So now let's try to erase these things so it's easier for you to understand. Okay, so now you have these two elements, right? And we're considering the case where you're trying to sort in ascending order. So you check, is 0 less than 1? Yes, it is. Now you swap them. Okay, now you have 0 and 1. Now these are the two cards you have, and both are sorted. So insertion sort works in such a way that you always have two parts, right? One is the sorted part, which is in your hand, and the other is the unsorted part, which is in the back. So similarly, you start picking elements, or you can start picking these cards one by one and keep sorting them. Okay, now this is a simple scenario where you can apply insertion sort, right? This is the simplest way someone can explain or you can understand the insertion sort algorithm. Now it's simple, right? You start picking these elements and keep sorting them, and at the end, when all the elements are used up, you'll have your sorted array. Now let's try to understand the insertion sort algorithm. So in this algorithm, what happens? Obviously, now we know that we'll have two parts, right? One is the sorted part and the other is the unsorted part. So obviously, the one element that's in your hand, or the element or card that's in your hand, and there's only one element there, right? The one element in your hand is obviously sorted, right? So we won't consider that first element, and we'll start our process from the second element. Now, we understand why we do this, why we start from 2 to n minus 1, or 2 to n, depending on the array, whether we start from index 0 or index 1, right? So we always start from the second element. Then what we'll do is store this value in a temporary variable, and then we'll check if that element is less than the element we have in the sorted part. If that's the case, then we'll shift their positions, right? Now we'll have two elements in the picture, which are 0 and 1, and both of these will be sorted in ascending order. Then what we'll do is consider the rest of the cases, starting from 3 to 0 up to n. Okay, now you might be thinking, how does this actually work? Let me take an example and show you how. Let's consider this array we have here. Index 0, these are all the indexes we have, and this is our array. 23, 10, 16, 11, and 20. So in the first step, we're making partitions. Now this is our sorted part, that is the first element, and this is our unsorted part. Now what we'll do in the first iteration, this is iteration number 1, because this is the case where we start moving from the second index, which is index 1, if we start counting from 0, right? So we start from the second element and continue up to n, right? So now, in the first iteration, what we'll do is compare these two elements. Okay, let me just erase everything so it's easier for you guys. So now, we'll compare these two. Obviously, 10 is less than 23, so what we'll do is swap their positions. Now, this is your sorted part, and this is your unsorted part. We'll do the same thing, right? So in the second iteration, what do? Here comes 16. Now, what do? We compare it first with 23. Okay, we see that 16 is less than 23, so now what do? Let's swap their positions. So this becomes 16 and this becomes 23. Now what happens? Now 16 will be compared with 10. Obviously, it's not less than 10, so it will stay in its own position. That is, its new position at index 1, right? So this is the second iteration, and after the second iteration, this will be your sorted part. As you can see, I've bolded this text, bolded the borders of these two. These two elements, and I've bolded the same for these three elements, because this is the sorted part that we have here, and this is the unsorted part. Now, what will happen in the third iteration is that it will check for this number that was there. It is 11. So for 11, what will we do? We'll compare it with, pay attention to this. Now we will take 11 into consideration, and now we will check it. We will swap them. Then 11 is here, 23 is here, we check them and we swap them. 16 is here, 11 is here, we check in. So since 10 is less than 11, nothing will happen. So what will happen in the third iteration? We'll have 10, 11, 16, and 23. These are all sorted, and we are only left with one element that is unsorted. Now, what will happen in the final iteration? Now, this 20 will be in its original position, which is here, and the rest of the elements will be sorted. Since we have gone through all the elements have been checked, and at the final step, that is in iteration 4, we will have this array, which is sorted.
After learning and understanding what insertion sort does and how it operates, let's now quickly move on to implementing it in Python step by step. I'm using Google Colab for this demonstration because it's a platform that's very easy for everyone to access. There's absolutely no need to install anything on your local computer since it's available online and can be used from any device with an internet connection. So let's quickly switch over to the Google Colab IDE, which is an integrated development environment specifically for Python programming. Here you can easily find a file named insertion sort with the Python file extension, which indicates that it contains Python code. With that, we already have this particular program prepared, which makes it much easier for me to explain the concepts and the code to you in detail. So here we're considering a function called insertion sort, right? The function is called whenever some data is passed in as an argument in order to sort the elements inside the data structure in ascending order, right? To accomplish that, we have to write a proper function accordingly, just as insertion sort works. How does that work? You've already learned about the logic and the steps involved in insertion sort. To implement it in code, you have to use a for loop. The for loop has a range, so it'll always checking the elements inside the array one by one to compare them with the key element. Right. So whenever it finds an element that is greater than the key element or lesser, it will swap them accordingly. Right. So we're using a while loop to do that same task. So we're swapping from the current position where it's found, whether it's greater or smaller, accordingly. We'll swap it, right? So then we have the data that's given here, which is 5, 2, 1, 7, 8. So what happens with this particular data is when it passes through this function, every element will be sorted with the help of the insertion sort function we've written here. So first, it will compare the elements and try to sort them in ascending order. For example, if you want to sort in descending order, then you just need to change a single element. That is, this key should be greater than the array element. That's about it. Nothing else. No change. So after that, insertion sort is the function contains the data that's present here. So all these functions will be completed, and then we'll print the final output. How do you print it? Once the function has finished sorting, the result will be stored in the variable data itself. So that particular data is printed. After sorting, the elements will be displayed, right? So this is just a print statement, sorted array in ascending order. If you're doing it for descending order, you can change it to sorted array in descending order. So let's quickly check how this output looks like. So here you have an array sorted in ascending order. So that's 1, 2, 5, 7, 8, right from the smallest to the largest number. Now let's quickly make a small change here so that it'll give us the descending order. Let's try to work on that. Right. If you look here, if the key is greater than the array element, then you'll get the descending order, which is 8, 7, 5 to 1. So you can change it like that. Okay, I didn't change the print statement, so I'm just changing it to descending order, right? Run the same code that's already declared. So this is how insertion sort works in Python. And as you can see, the code is very short and quickly eliminates all the variable initializations we usually make. You just need to have the function, pass the data, get it sorted, and the output is done. So that's everything about insertion sort in Python.
Now let's talk about the time complexity of insertion sort. So in the worst case, when all the elements are in reverse order and we need to sort them one by one, obviously we're talking about the outer loop, which runs from 1 to n, and then the inner loop, which runs backwards. In the very first iteration, we only consider the 0th element, but as we move along, it will be running from n to the 0th element, right? We'll be considering all n elements. So in that case, the time complexity in the worst case will be order of n squared, because we have two nested loops. One is a for loop, and inside that for loop, we have a while loop, right? So this is the worst case, and it also happens in the average case, where some part of the array is already sorted. Let's suppose we have 5, 4, 5, 6, 7, 8, and then we have the unsorted part. So half of the elements are sorted and half are not sorted. In that case, it will be n squared divided by 2. We're not considering the case where we talk about constants. We're ignoring the constants. And in that case, the average time complexity will be n squared, right? But the most important thing about this time complexity is the best case. That means when your elements, like 5, 6, 7, 8, 9, and 10, when the elements in the array are already sorted, what happens in this case? If you observe, the for loop that runs from 1 to n will always be there. N is always there. The time complexity, the big O notation, big O of n, will always be there. But in this while loop, where we were checking if j is greater than or equal to 0, and if array of j is less than 10, right? In that case, this will never be executed because array of j will always be greater than 10. Why? Because we're talking about this element and we're checking if the 6 is less than 5. No, it's not. If the 7 is less than 6, no, it's not. So this condition will always be false for all the elements. So in a nutshell, we're just checking these steps only once in every iteration. That's why the whole time complexity in the best case will be O of n and not O of n squared in the best case. Okay, now let's talk about insertion sort's space complexity. If you've noticed, in the algorithm and in the implementation, we never talked about any auxiliary memory, right? We weren't using any extra space, whether in the form of an array, linked list, stack, queue, or anything else, right? So that's why the space complexity of insertion sort is O1. That is, it uses a constant amount of space. Now let's talk about insertion sort analysis, where we'll be looking at the number of comparisons, number of swaps, whether it's stable or unstable, and whether it's in place or out of place. So first, let's talk about the number of comparisons required. Here, we'll discuss two scenarios, the worst case and the average case. In the worst case, the number of comparisons required is n squared divided by 2. Now, if we actually talk about the average case scenario, it's n squared divided by 4, which is exactly half of the worst case scenario. Right, it's half. Now, if we talk about the number of swaps required in insertion sort, again, we'll consider two scenarios, average and worst case. In the average case, it's n squared divided by 8, and in the worst case, it's n squared divided by 4. These are the number of swaps required. And if you want to check whether these statements or equations are correct, you can always try an example where you will consider both cases, even and odd. So take an example and run through it. Now, if you talk about the stability of insertion sort, it is a stable algorithm. What do you mean by stable? So if you have an array that contains 1, 3, 1 prime, and 5, in this array, the relative position of these two ones, that is this one and this one, let me change the color and show you, the relative positions of this one and this one will remain unchanged. What does this mean? It means that whenever you are sorting it, you can sort it in two different ways, right? This is also sorted, and this is also sorted. That means you can either have 1, 1 prime, 3, and 5, or you can have 1 prime, 1, 3, and 5. Obviously, this number is repeated, but this is the first number. This one occurred here the first time, and here it is the second occurrence. Now, you want to keep their relative positions intact, right? So both of these are sorted, right? But if you talk about stability, this one is called stable and this one is unstable, okay? Now insertion sort, whenever you try to implement insertion sort, it is stable. That means the relative positions of both these ones will remain intact, okay? So if someone asks you whether insertion sort is stable or not, you will say yes. Why? Because the relative positions of the numbers that are repeated remain intact. Now, what about in place or out of place? Since we are not using any auxiliary memory, right? We didn't use any stack, queue, linked list, or array. That's the reason that whenever you are not using any extra memory, it is considered an in-place algorithm. So if an algorithm sorts within the original array, that means you are not using any extra space. That algorithm is known as an in-place algorithm, which is clear now in insertion sort since we are not using any extra memory. So insertion sort is an in-place algorithm. Now let's look at an example where we will implement insertion sort. As you can see, we have this example here where we have 6, 5, 3, 2, 8, 10. 9 and 11, and we've been given this k. What this k signifies is the maximum swaps or comparisons needed for this 3 either on the left side or on the right side, right? The number of positions that this 3 needs to move to get to its original position is 3. So this is a question that's known as a nearly sorted array or k-sorted array. We don't need to sort all the elements in the array. We're specifically looking for those elements that aren't in their original position. And if we want to get them back to their original position, the maximum number of comparisons or swaps we need is 3. So if you look at this 3, its original position is here, 5. That means in the sorted array, it would be here. Similarly, if you look at this 2, the number of swaps it needs is 1, 2, and then it'll be in its original position. Or you could say 1, 2, and 3. So at most, it can move up to 3 positions, right? So it'll be the same for all the elements. So at most 3, okay? And at the very least, it could be that it doesn't need to move at all, that it stays in its original position, like 11, you see? 11 is in its original position in both the original array and the swapped array. So at most, you have 3 positions. Now let's try to understand what sorting is and why we need sorting. Sorting is a process where we arrange our data either in ascending or descending order, right? So let's say you have a group of students, 10 students, and all of them have roll numbers assigned from 1 to 100. If you want to know which roll numbers are present, which are absent, and which students have left the college or school, in that case, you can easily use sorting. When you have the data sorted, you can quickly figure out which students are absent or not, right? So that's where sorting comes in handy. In this tutorial, we're going to learn about the quicksort algorithm. It's one of the most widely used algorithms, and it follows the divide and conquer paradigm. What does divide and conquer mean? Basically, we'll be dividing our array in such a way that every time we split it, let's say this is an array, now we'll divide it into, then we'll divide it further into 2, and then again into 2, and so on, right? We'll see in the algorithm section how we can implement this divide and conquer paradigm. In this tutorial, we'll be implementing quicksort using recursion. We'll see how we can recursively call those functions based on a pivot element. Now, in this recursive call, we'll choose a pivot element. Let's suppose you have this array, and we were choosing this element as the pivot. Of course, you can choose any element as the pivot, right? It could be the first element, the last element, or any random element. But once we've chosen that pivot, what do we do in each iteration? In quicksort, what happens in each iteration is that this pivot will find its original position, that is, its position in the sorted array. Let's say this is our pivot. After one iteration, this pivot will be in its correct position, and all the elements less than this pivot will be on the left side, and all the elements greater than it will be on the right side. Then we'll choose another pivot. Now, what are those pivots? We'll look at the algorithm in more detail to see how we can choose the pivot. Let's suppose we've chosen this pivot, and it's here. And after the second iteration, what happens? This will be our next pivot, and this will be our next pivot. Now we'll have two pivots. This is how we implement the divide and conquer approach. With each step, our problem gets divided into two, which leads to quicksorting, or the quicksort algorithm. So now we'll be dealing with this subarray and this subarray, and we'll apply the same procedure to each subarray. That means this is the pivot, and this is the pivot. Now let's try to understand the quicksort algorithm. So first, we have this method called quicksort, in which we'll be calling quicksort recursively again and again. But the first time around, what happens is we check, okay, now we have this edit. We always check that the beginning should less than the end, because that way we can keep track of which part is already sorted and which part is still unsorted, right? So after checking that, we call this method. We'll see what this method is, we'll look at the algorithm, and we'll see how this partitioning happens. We'll get the index of, let's say we pick this element as the pivot, and after partitioning, what happens is that this pivot ends up in its original position at index 3, right? That index will be returned and stored in this pivot index variable. Now what happens is that we know this is its original position in the array, so when we get the sorted array, this will be its correct spot. For example, if this element is 8, it will be at index 3, and after each iteration, this element will be in its original position. The first time the partition is performed. Next, the quicksort algorithm is called again recursively, first on the left-hand side, meaning this portion. In this portion, this will be your pivot. You see, we're sending the arguments as beginning and pivot index -1, which means we're not including this element because it's already sorted. We're not including this element, and we're calling the function on this subarray. Again, and this time, this will be our pivot, and the same thing happens. Similarly, when we're done with the left-hand side, we move to the right-hand side. That is, we implement it starting from pivot index +1, meaning from this element to the end of the array. This time, this will be our pivot. Okay, so with that said, that's what happens when we're implementing quicksort. But now, what about this partition method? Let's see how that works. So in partition, what happens is we set up the pivot element. That is, we choose the element that will be our pivot. Obviously, you can pick any element, but in this tutorial, what I'm going to use, and what you should try first, is to pick the last element as the pivot. Of course, you can pick any element, and the time complexity depends on which pivot you choose. We'll talk about that in the time complexity section. Okay, so we've set the pivot as the last element, and now what we're doing is saying, okay, the pivot index, this step refers to what? Let's suppose this is the pivot index, and what happens is, this will be our pivot. What happens is that this pivot index maintains the order. So from this index, everything on the left-hand side is less than the pivot, and everything on the right-hand side is greater than the pivot. We'll see an example, and I'll show you how this pivot index is very important. Okay, now what we'll do. Obviously, at the start, it's at this position, which means we haven't. We don't yet have a situation where some elements are less than the pivot and some are greater than the pivot. Okay, so now let's suppose this is our array, this is our pivot, right? And this is our p index, that is the pivot index, and it's currently at -1. Okay, now these two steps are done. Now what happens in the third step? Now we will iterate from the beginning, that is from this point, and we'll check if any element is less than the pivot. If that's the case, then what do? We increment this and swap those elements, that is the array element and the first element at that index. That means now if you look at this step, we've incremented it first. Right, now let's suppose if any element is less than the pivot, we first increment the pivot index, so the pivot index will be here, and we'll swap it with ARI. ARI is also at this location, so this element will be swapped with itself. Now, you might be thinking, okay, why are we doing this, right? Why are we swapping it with its own position? You might not get the intuition in this step, but in the next step, you'll definitely understand. Now, let's suppose this is what happens in the for loop. Now, let's try to reiterate this. If an element is not less than the pivot, let's say here we had 5 and here we had 3, so it was less than and we swapped it with itself. Now let's suppose we have this element 6 and it's not less than the pivot, right? So what happens here? So we won't execute this if block, right? And then we'll have this or-with. Now it will be here. Now it will be incremented. And this time we have 2. And the p index is still here, right? Now this time it's less than 2, right? And now what we'll do is we'll first increment the p index. It'll be pointing here. And then what we'll do is swap these two elements, right? These two elements will be swapped. So now you have 2 here and you have 6 over here, right? So you see, this is the reason why we have this pivot index in place and why we're swapping them. So in the first step, it happened because the element was less than the pivot, and if the element hadn't been less than the pivot, then we would have incremented the I pointer and the p index would have stayed here. Now finally what happens, now once the entire iteration is complete, and let's suppose we have 8 over here and then 10, now once the iteration is completed, what we'll do is swap these two elements. That means 5 and 6 will be swapped, and we have 5 here, 6 here, 8 here, 10 here, 3 here, and 2 here. So you see, after one iteration, all the elements that are less than the pivot will be on the left-hand side, and all the elements that are greater than the pivot will be on the right-hand side. And finally, we will return the pivot index, which is p index plus 1. That means we will be returning this index so that this element is not considered, or will not participate in any further iterations or any further recursive calls. Because you see, if you observe carefully, we were sending pivot index minus 1, that is, all the elements on the left-hand side without 5, and plus 1, meaning all the elements on the right-hand side without this index. Okay, this is how partition works. Now, you might be a little confused, so let's try to demonstrate this with the help of an example. So you see, we have an example here, right? We have 5, 10, 9, 6, and 7. These are the elements in the array. And we have this pivot here, the last element. We've chosen the last element to be the pivot. After that, what are we doing? We have this end pointer, and we have this beginning pointer. Also, we have that pivot index, which will be somewhere around here, right? That pivot index, which will be minus 1, now this 7 will be checked. Okay, is 5 less than 7? Yes, 5 is less than 7. So it will be swapped with itself, and the pivot index will be incremented first and then swapped with itself. Now the pivot index will be here. Next time around, our I pointer will be here. First it will be here, and then it will be incremented. Now, again, we will check. Is 7 less than 10? No, it is not. So our I will be incremented. I will now be here at this position. Right now, again, it will be checked. No. Again, it will be checked. Yes. So now what happens? 7 and 6. The 6 will be replaced with what? 10. So you have the 6 in here. Obviously, the pivot index will be incremented first, and then we have the 6 over here, and it will be swapped with 10. So 10 will be here, right? Done. And finally, when we are at the end, once the entire iteration, this is step 1. Once the entire iteration is completed, we have 5, 6, and then 7 will be the last swapping that we did. The last swap that we did, if you observe here carefully, this swap that we are doing, this is the one that is responsible for swapping this 7 with the pivot index, that is pivot index plus 1, which is this location. And we have this 7 over here, and it will be replaced with 9. So that is why we have 9 over here, and 10 was here, and this is the array after the first iteration. Now, you might be thinking, okay, now this element is fixed. Now we'll never talk about this element because this is at its original position in the sorted array as well. Now, what will we be dealing with? We'll be dealing with this left part and with this right part. So now, what happens in this part, right? And what happens in this part? You see, now we have new, this is our beginning, and this is our pivot, because this is the last element that we will be picking, and this is our end. Similarly, this is our beginning, this will be our pivot, the last element in this subarray, and the end will be here. Now we'll be again doing the same step, and this time around, we'll be checking. Okay, pivot is less than, no, nothing will happen, and then we will be swapping this thing with itself, right? And now, once this entire subarray is completed, we'll not go any further because this time around, beginning is not less than end. Both elements are at 0, and 0 is not less than 0. And now, if you observe carefully, this is the condition that we were setting at the start of the function. That is the quicksort function. And we're checking if beginning is less than end, right? So this is the importance of that. Similarly, the same thing will happen over from this side. And again, beginning will not be less than index end part, and we will not go any further. So after 2 iterations, our entire array is sorted, right? So this is step 1. After step 2, our entire array is sorted.
After learning what quicksort is, let's quickly implement it in Python. So here we are using a Python IDE, specifically Google Colab, one of the IDEs I mean, and then we'll implement that particular program there. So let's quickly hop into the IDE now. So here's the program for quicksort in Python. So let's understand how this program works, right? The first part is that we need to create a partition, right? In quicksort, any array needs to be broken into 2 separate halves, and then we'll start sorting those different pieces individually. So partition positioning will be accomplished with the help of the array's low and high variables, which represent the starting and ending indices. We'll always consider the rightmost element as the pivot element. The rightmost element of the array is the pivot. That's the rule in this method. To do that, we'll use the statement pivot equals R of H, right? Then we need a pointer for the greater element. So to compare elements that are greater, we'll use this pointer to traverse through the array, keeping one pivot element in mind and comparing it with each element. We use this for loop for that. If there's an element smaller than the pivot, we'll use I equals I plus 1 and immediately swap the element at position I with the one at j, right? That will be done using R of I and j equals j. And we'll exchange, if you look here, I and j have been swapped to j and I. So we're exchanging the elements. If it's smaller than the pivot element, then swap the pivot with I. If it's greater than the pivot, right? If any element is greater than the pivot element, wherever I is pointing, that element will be swapped with the pivot. To do that, we'll use this specific condition. Then we'll return to the initial position where we started the partitioning, right? Where we split the array into 2 parts. The partitioning is done there. We'll go back and try to start from the initial position, then the quicksort function will come in. So here, in quicksort, again, we need 3 different elements, array, low, and high. If low is less than high, that is, if there are elements smaller than the pivot, they will all go to the left side. If there is an element greater than the pivot, it will go to the right side. So the partitioning is done accordingly. So this is the recursive call that we use for quicksort, right? Again, we'll have array, low, and pi minus 1. Pi is pivot minus 1. So for the right side of the pivot, we have a recursive call function, which is declared here. Once all these steps are done, we need to provide data in order to sort something, right? Here, we're focusing on sorting the given array in ascending order. So the data set is specified here and has been assigned as D. So the set has been assigned to us as D. 9, 8, 7, 2, 10, 20, and 1. These are the elements we're trying to sort, right? We're printing the unsorted array, meaning however the input is given here, that's how it's printed as it is. Unsorted array is equal to and so on, which is already there, and we're not performing any functions yet. Then we have print D, which means it will print immediately. Then size equals length of D. We'll consider this when printing, right? We have to print each element one by one. So again, we print 9 first, then 8, then 7, then 2, and so on up to 1. After that's done, we'll send this particular raw data, the unsorted data, to the function called quicksort, which we've created here, right? So that's sent. Once it's sent, it will follow all the procedures mentioned here, all the functions, will be passed the data, and finally, we'll print the sorted array in ascending order, which is sorted using quicksort. So let's quickly run this program and check out what the output is. So it will take some time to get the output, so let's quickly check. Okay, so that's what I mentioned. The unsorted array is simply the array provided by the user, and the sorted array is shown after performing all the functions assigned for quicksort. As you can see, it's in ascending order, starting from 1 and ending at 20. So that's all about quicksort in Python.
Now let's try to understand the time complexity of the quicksort algorithm. In the quicksort algorithm, we've seen that partitioning of elements takes place, and we're partitioning all the elements. That means all n elements. If there are 8 elements, we iterate through all 8 elements, right? So partitioning them takes n time, that is, order of n time. Then the quicksort problem divides it by a factor of 2 each time, right? Every time we're dividing it by 2. So the entire process, or the time complexity of quicksort in the best case, and in the average case, it takes order of n time. That is big O of log n. And the same thing happens when we're talking about the average case as well. But why is it n squared in the worst case? That's the question, right? So let me clear that up. So the question is, why does this happen if you're picking either the smallest element in the array or the largest element in the array? As if you pick the pivot like that, you end up traversing all the elements again, which means this n is already there for partitioning. That means you'll be iterating through the array, but there's an extra n. And that means inside that n, you're again traversing all the elements and swapping them. Because in the worst case, your pivot could be either the smallest or the largest element in the array. In both these cases, you'll end up swapping all those elements with themselves. For example, this element will be swapped. Let's say this is the largest element, say 8, so nothing will really happen. If it's the smallest, it'll be swapped with itself, this one will be swapped with itself, and so on. So all the elements will be swapped, and finally, this element will end up in its original position at the end. This is what happens if you pick your pivot as the smallest or the largest element in the array. Okay, so in these two cases, that's not ideal. If you pick your pivots randomly, that's different. In a nutshell, when you pick your pivot element as either the smallest or the largest in the array, that's when you get the worst case time complexity, which is big O of n squared. Now, let's talk about the space complexity of quicksort. You might be thinking, okay, we're not using any extra space, right? We're not using any auxiliary memory like arrays, stacks, queues, linked lists, or anything like that. But by calling this function, the quicksort function, we're using recursion, right? We're calling quicksort again and again. There are 2 quicksort calls. And to maintain the call stack, we need order of n space. So the time complexity will be bigger, and when we use this approach, in the worst case, all the elements will be on the call stack. Okay, so in the worst case, the space complexity will be big O of n. But if we modify this approach of storing the elements and managing the call stack, we can reduce it to big O of log n. Now, let's try to analyze the quicksort algorithm. First, let's try to understand its stability. So, suppose you have this array, 1, 3, 1 dash, and 4. Now, an algorithm is said to be stable if both of these ones, this one and that one, preserve their original relative positions in the sorted array. Now, you have this sorted array, right? And both ones, this one and that one, are maintaining their relative positions, just like they were in the unsorted array, right? So if that is maintained, right? If that is maintained, the algorithm is stable, otherwise it is not stable. Obviously, there could be another way where this is also sorted, but it's not stable. This is unstable. If you are sorting in such a way and you have these things placed, this algorithm is unstable. So if you talk about the quicksort algorithm, quicksort is an unstable algorithm. Although we can make some modifications to stabilize it, or we can make this algorithm stable, as of now, if you talk about the quicksort algorithm, it is an unstable algorithm. What about in place and out of place? Since we are not using any auxiliary memory, right? We're not using any extra space explicitly, like an array, linked list, stack, or even a queue. We're not using any extra memory. So this algorithm, the quicksort algorithm, although we are maintaining a call stack, where we are maintaining a call stack and we have a space complexity of big O of n, but since we are not explicitly mentioning these auxiliary memories, this algorithm is considered an in-place algorithm. These are the 2 analyses that can be done on quicksort. So in a nutshell, if you talk about quicksort, right, it is an unstable algorithm. What about merge sort? If we talk about merge sort, let's first try to understand sorting. Sorting is a way of giving order to your values, right? So let's suppose you have some random values, 10, 30, then you have 5, 2, 1, and so on, right? You have these values, and now you want to maintain some order. So in order to visualize this data, let's say you want to see it in ascending or descending order. That's what you mean by sorting. So let's suppose you have a class, and in that class you have several roll numbers, and some of the roll numbers are missing. And then you want to sort those roll numbers in ascending or descending order. That's when you need sorting. So this is the basic intuition behind sorting, trying to give order to some kind of values or some kind of data set, right? So in this particular tutorial, we are going to talk about merge sort. Merge sort is a classical sorting algorithm. In this sorting method, every time your problem is divided into subproblems so that your problem set gets smaller, and then you focus on that subproblem. Similarly, every time you divide your subproblems, you keep dividing them until there is only one element left, right? If you compare it with simpler sorting algorithms like bubble sort, insertion sort, selection sort, or even quicksort, when you talk about its time complexity compared to these algorithms, this one is much more efficient. Now, it follows the divide and conquer paradigm. What does that mean? This means that first you keep dividing your subproblems, then you conquer those problems, and finally you combine everything together. Okay, so here we'll see that when you're dividing your subproblems, and then when you have your problem sets, and those problem sets are conquered, that means those problems are. Furthermore, when you talk about this example, those subproblems are sorted in this case, and once you've conquered them, you then combine them. That's your merge phase, where you bring your problem back together, forming a single subproblem again. So every time you divide a subproblem, you conquer it and then combine it. This is how the divide and conquer paradigm works. Basically, when you're dealing with merge sort, you're focusing on two functions, the merge function and the merge sort function. Now, let's talk about the divide part. That means you're dividing your subproblems, and you keep doing this until there's only one element left, because a single element is already sorted, right? That's your divide phase. What about conquer? Basically, you conquer those individual sets and then merge those two subproblems into a single problem. You repeat this at each step, and finally, you end up with your original array, now sorted. Now, let's talk about the merge sort algorithm. First, let's discuss the merge sort method. In this method, what we're doing is dividing our array into further subarrays. How do we do that? Basically, if we have this array, let's say it contains 8 elements, right? This is our array, and let's suppose this is our left pointer and this is our right pointer. And now what we're doing is dividing it. So we need some kind of iterator where we'll store the sum and we try to calculate the mid value. How would you do that? Simply put, we calculate left plus right divided by 2. That's it, right? So we have this division, and then we'll divide this part because we're calling this function again, right, on the left-hand side. So this is going to call on this side, meaning we'll now be talking about only 3 elements. So let's take 4 elements on this side and 4 elements on that side, so our mid will be 3.5. So we'll be talking about elements from 0 to 3. So we'll be talking about 4 elements, and then these 2 steps remain. Why? Because we're implementing this in a recursive fashion. So now let's suppose this is our first function call, and you have these 3 steps. 1, let's name them 1, 2, and 3. Okay, so in the first function call, 1, 2, and 3. So this is the first function call. And in this, we're calling again. This is the second function call, and we're calling again. These 2 remain, right? And we're calling again, 1, 2, 3. Right. So in this case, again, we're calling it on these 4 elements, and it will be divided further into 2 elements, 0 and 1. Right. And in this case, again, this will be called on these 2 elements, right? Here we're talking about only 2 elements. So this is the third function call, and again, we'll be dividing it. These 2 and 3 steps are still remaining. So in the 4th step, what are we doing with only a single element, right? And in this case, we're talking about only this element, right? And further, we won't be able to divide it. And in that case, our left is not greater than. Our left will be greater than or equal to, right? And in this case, it will be equal to. So we will return. So now it will be returned, right? And then whatever was left over. Right. Now we talk about this single element, the other element that was left behind. We'll talk about that. So again, that will be divided into 1. Right. And again, this will be the second option. I'll just erase it because it looks a little bit messy. So now what happens? Let me just put it again in red. So here we call this the 4th time. In this time it returned, right? So in this case, now we will be on the second step. Now again, it will be called on that single element. And again, left is not greater. It will be greater than or equal to. In this case, it will be equal to, and then we return. So again, we are returning. So we have these 2 elements, 1 and 1. That means not 1 and 1 element, but there is only a single element in both these areas, right? Why am I saying that? In these 2 arrays, we will check when we talk about merge, okay? We'll see how that is implemented, okay? So now these two function calls are done, and then we deal with merge. Now, before going into the merge, let me show you a demonstration of how things look. So you have these elements, and here you have how many elements? You have 5 elements, right? And now you're dividing it into 3 and 2. Now, this is your first step. The second step will be this. So now, will you go ahead and create this as your third step? That means you will move on to this? No. Because we saw that unless and until there's nothing left on the left, we won't go to the right. So this is your second step, then this will be your third step, this will be your fourth step, and now you'll move on to your fifth step, right? And now, once you don't have anything on the left or the right, then what happens? Will this be your sixth step? No, your sixth step will be the merge. So let's move on to the merge now.
So in the merge function, if you look at the algorithm, it's pretty straightforward. You create 2 subarrays. One is your left array, and the other is your right subarray. Now, in this case, as you saw in the previous example, we have a single element here and a single element there. Now, once we figured out the lengths of these arrays, what the lengths of these subarrays should be, and we've declared and initialized these arrays, after these 3 steps are done, what we're going to do next is create 3 iterators, I, j, and k. And those iterators work like this. The I iterator will handle the left array, the j iterator will handle the right array, and k will handle the original array, which helps us insert the elements. So once we have everything set up, the next step is to compare the values, right? If this element, that is the element in the left array, is less than the element in the right array, we're going to insert it into the original array. So now, let's say you have 10 here and 20 here. Since 10 is less, we're going to insert it and increment the k pointer. And now our I pointer will also be incremented. Earlier it was at 0, and now it will move to 1, right? And now what's happening is our I is pointing to 1, and our length is also 1. So now, in that case, when one of the arrays is exhausted, the next area, whichever side is left, right? It could be either the left area or the right area. Those elements will be directly inserted into the original array because we know for a fact that both the left and right areas are already sorted themselves. Okay, so let's see. What is the next step in the demonstration? So here we had our steps, right? And this will be the 6th step, where we are going to merge this. Now, will this be your 7th step? No, your 7th step will not be this. Your 7th step will be here. This will be your 7th step. Now, the 6th step is done. Now you will be dividing it and creating all those arrays. Once you have your right array, and there is no right because this left is already done, and now you had your right, left, now this is also done. Now your 8th step will be this. You will be merging it. This will be your 8th step. Then you'll be merging it. Now, will this be your 9th step? No, you have this array. That is your left array in place. But what about the right? Is this in place? No, it is not. So now let's try to calculate that. Now, what will be your 9th step? This left is done. This is your 9th step. Then what will be your 10th step? This is your 10th step. Well, now there is no left. Right. Now we'll move on to this right side. So this is your 11th step, because this is the right side, right? And now, when you don't have anything on the right, you'll be merging these 2 steps, and this will be your 12th step, which is over here. So this is your 12th step. That means you'll be merging these 2, and the final sorted array is this array, and you'll get this array in the 12th step. So you see, 10, 11, 16, 20, and 30. Now, if you observe carefully, you have these individual arrays 1 and 1. So now, while you're merging them, you're also sorting them. So the left array is sorted, and the same thing happens on the right-hand side as well. If you look at 3 and 4, these 2 elements are sorted in this left array. So this is the reason in the right array, not the left array. So now, when you're merging them, you'll again get an array that is sorted by itself. You see 10, 16, and 23. So if one of the arrays is exhausted, the remaining elements from the other array can be directly inserted into your original array. Let me erase this. And you see, you have your left array, which is sorted, and then you're merging it with the right array, which is also sorted. Now, if one of the arrays is exhausted, whether it's the left array or the right array, the elements from that array can be directly inserted into the original array, because we know that the elements in either the left or the right array are already sorted. Okay, so this is how you execute your merge function.
So here's the program for merge sort in Python. So how does this merge sort work? Generally, a single array will be broken into two different pieces. Then, those two subarrays will be broken down further into even smaller subarrays. After that, whatever results we get at the end will be combined together in order to finish sorting that particular array. So we are merging all the answers we got from the subarrays to make a final result. So quickly, let's see what we need to do to implement merge sort in Python. First, we need an array that will be passed through this merge sort function. So what happens inside this function? First, the length of the array is calculated. Once that's calculated, it's divided by 2. So you get the left and right parts of the array. Right. So after splitting the array into two different halves, we perform merge sort on the left side of the array and merge sort on the right side of the array, right? Then we'll use a while loop here with the help of looping constructs. So first, we'll check whether the right array index is less than the length of the left array, and then again, whether the left array index is less than the length of the right array. So we'll try to merge and sort the elements right then and there. So later, we'll go back to the left and right parts inside the while loop here. We have the length of the array on the left side. We're checking whether it's less than or greater than, and based on that, we're deciding where to merge the results we've gotten from the subarrays, right? So then we'll always have the option to print these particular arrays. We'll do that at the end. But before that, in order to merge all the results we've gotten from all the subarrays, we'll use a for loop here, right? So all the array results will be merged together and we'll get the final sorted array, which contains as many elements as were in the input given by the user. For example, if there were 5 different elements in the array, after combining all the subarray results, we'll get those 5. We are going to sort the elements in ascending order in the array by using a well-known and efficient algorithm called merge sort. So let's quickly take a detailed look at how this particular merge sort algorithm works in practice. Here we have an array that contains 8 different elements inside it. And as you can see, this array is currently not sorted. We need to sort it in ascending order. Once this array is passed through the merge sort function, the algorithm will perform all the necessary operations step by step, dividing the array into smaller subarrays, sorting those subarrays, and then finally merging all the sorted arrays together. After all these steps are completed, the sorted elements will be displayed in the print list, right? So let's quickly run this program and check out the results to see how merge sort efficiently organizes the data. Even though we're calling it an array, we're actually using a list here in Python to store it, right? So this is the sorted array that we get. Here, as you can see, we didn't have a sorted array before, but now it's sorted in ascending order, that is, from smallest to largest. So that's all about merge sort.
Let's start with the very first topic, which is, what is Pytest? Okay, now I just want to point out something small here. You've probably heard the name Pytest before. Maybe you're not sure what exactly it is, what it's used for, or in what context it's relevant, but you must have at least heard of Pytest. So what is Pytest? It's a testing framework that's used to carry out different types of tests. Now, as we know, whenever we're building any application or working on something new, we always try to run some test cases on it. This is so that whatever application we've developed is completely bug-free and ready for users before it goes to market. That's the goal. So how do we actually run those test cases? In that context, Pytest is one of the frameworks used to perform various types of tests on your application, whatever you've built. So Pytest is a kind of testing framework that's used for testing. Testing here means you'll be creating and running test cases for your application or software, whatever you've built. Why do we do this? As I mentioned, we do it to make sure that whatever content or features you're providing in your application, when you launch it in the market, it's completely bug-free and everything you've added works perfectly. Okay, so that's the idea behind running those tests. Secondly, it allows you to easily write tests and run them. Now, Pytest is one of those testing frameworks where you can write tests very easily. It's really convenient. It's very easy to write tests using Pytest, and it's also very easy and convenient to run those tests. Okay, so as I mentioned, it's very easy to write tests in this case. So we can say that Pytest is a very easy tool as well, right? Because if it's basically easy to write and run tests, then with Pytest, that's all you do with the Pytest library. You just write the tests and simply run them. So when both of these cases are actually covered, we can easily say that Pytest is one of those libraries that lets you easily write and run tests as well. Okay, so I hope that's clear. Next, we have that Pytest can actually be used to build a simple test in a very easy way. Okay, now let's say you just want to create a very simple test. In that case, with the help of the Pytest library, you can build that simple test in a really easy way. Yeah, so actually, as I mentioned earlier, it's easy to write and run tests. So this is a related point I'm making now. You can simply build scalable tests very easily. Okay, it's a tool that automatically finds the tests you've written and runs them. So whatever test you've written out yourself, it automatically finds them and runs those specific tests. Okay, so this is the kind of tool that can automatically detect any test cases you've written and simply runs those tests as well. All right, so this is exactly what Pytest is used for. It's especially used for running test cases. And the reason why it's actually preferred is because it's one of those tools that's very easy to use for running and performing tests. The tests themselves are really easy to write, and it has a straightforward guide for writing tests. Plus, it can automatically detect the tests you've written and run those specific tests as well. So I hope I'm being clear about these 4 points mentioned here about what Pytest actually is. Now let's talk about what the features of Pytest are. Here, I've listed 4 features of Pytest. Let's go through them one by one, line by line. All right. First of all, Pytest includes useful plugins. Okay, so actually, Pytest is one of our testing frameworks, one of our tools, which also includes useful plugins. So when you're using them, you can simply use those plugins depending on what function you need to perform with them. All right, Pytest does not require any API to use. Okay, now with this particular tool, whether you call it a library, a tool, or a framework, whatever you want to call it, Pytest doesn't need any API for you to use it. So it's not like you always have to set up some kind of API before you can work with the rest of the features in Pytest or anything like that. You can run the test or you can write the test. It's nothing like that. Because of this, it's actually a very simple and easy to use tool. So in that sense, you also don't need any APIs here. All right, next. Pytest is used to run unit tests and doc tests. Now, there are 2 types of tests. The first one is unit tests. Maybe you've heard about unit testing too, right? So Pytest lets you run both unit tests and doc tests. Okay, these are the 2 types of tests to solve functions of this, which you have out here. So yes, by this actually allows you that, yes, using the Pytest, you could write up the respective code, and you could run up the unit test and the doc test as well. Okay, next, by this can be written as a method or a function. Now, Pytest can be written, okay, let's you want to perform out a test for any of the cases, right? So now in that case, what you could do, you could simply make up a method or you could make up the fact. Okay, that's with the help of the Pytest only. So it's not that case that Pytest shall only be written using a function or only shall be written using a method or any specific thing like that. With a Pytest, you could write up the Pytest in a form of a method or in a form of a function as well. So whatever the type of work you're doing, or whatever you are actually comfortable with, you could write the Pytest in according to that as well. Fine. So these are some features of Pytest which we are having up you. So let me go through them once again, as it says that, first of all, Pytest tools out the useful plugins. Plugins, you could call that as, if I say in a very simple manner, so you could call the plugins as an extensions as well. Okay, so that's the idea. Then this does not need any API to use. So you do not need out any API to use up the Pytest. It simply is a very simple tool actually. You have some installation process, you install that out, and after that you could simply go ahead and use out that respective Pytest to write up your code. Okay, you do not further need out any API or any special tool exists to write up the Pytest and all those things, right? It's not that. or needed in this respective case. So that's why actually it is one more thing said that's one of the easy tool, okay? That's why in the previous slide, that was what is Pytest, I mentioned up that it is very easy to write up the test and run in the Pytest too, right? That was only the reason in which I mentioned up the statement, that why was it very easy to run and write up the test? This is only the reason for that respective thing, okay? That it doesn't needs out any API. Next, Python is used to run another unit and a doc test. That I already mentioned up, that there are two types of tests. First one is a unit test, and second one is a doc test. So Pytest is used for running out both of those tests. And last but not the least, Pytest can be written as a method or a function. So Pytest is one of the tool or framework, whatever you say out. So in the Pytest, you could declare a method or you could declare a function as well. No queries or no issues in that case, okay? So hope I am very much clear. Now, we'll be talking about the advantages of Pytest and what those advantages are. So here are the advantages of Pytest listed out. Let's go through them one by one, line by line. All right? So the very first advantage of Pytest is that it's free and open source. Yes, that's the first and most important advantage, I would say, actually, that it's free and open source. It means that it doesn't ask you for any money or anything like that for installation, actually. Okay, you just have a very simple command. Just type in that command and you'll have Pytest installed on your device. And then you can go ahead with and perform your tests or whatever you want to do. You can just go ahead with that, all right? So it's free and open source as well. Open source means that it also has its official library and official website. So you can just go there and you'll find extensive documentation about Pytest. So you can go through those documents and learn about Pytest as well, all right? So it's free and open source. Next, we have that it allows you to run multiple tests in parallel. Okay, it allows you to run multiple tests in parallel. Let's say you want to run 1 or 2 tests at the same time, all right? And it's not possible for you to run 2 tests at the same place, and in a single code file, it's not possible for you to run both of those tests, right? So Pytest is a framework, it's a tool, or you could call it a library, that allows you to run multiple tests in parallel, okay? That means you can run 2, 3, 4, 5, 6, or any number of tests at the same time, all right? No matter how many tests you want to run at once, you can run all of them in a single go, okay? So this is another very important feature that you get with the Pytest library. Next, it allows you to run an entire subset of the suite of tools. Okay, if you remember the suite of tools, we learned about Selenium at some point. So Selenium has a suite of tools. It has a full suite of tools, which we have in Selenium. So there's WebDriver, RC, and IDE. So we have like the suite of tools here in Selenium. So with that, we're just saying that you can run an entire subset of the suite of tools. So if this Pytest is one of the libraries that lets you run those suite of tools as well. So you can also use it to run the entire subset of those suite of tools. Okay, so I hope that's clear. Next we have, it has a very simple syntax, so it's easy to learn. So the syntax you have in Pytest is for writing tests. So it's super, super, super easy, and actually a very simple syntax. So when we have a simple syntax, obviously it's much easier for us to learn it, right? So it has a very simple syntax, and that's easy to learn. We'll also look at some examples later. Next, it allows you to skip a subject during execution. Now, let's say you've written some tests and you just want to skip a subject in that particular case, okay? So if you just want to skip some part of the code or a certain subject in between, yes, while the execution is happening, you can skip that particular subject as well, okay? So even then, it's not going to give you any kind of error or anything like that if you skip a subject, right? So that's exactly why it's said that it allows you to skip a subject while that particular test is being executed, right? So these are the advantages of Pytest. Now we'll learn how to install Pytest, okay? So in the Python programming language, Pytest is specifically for Python. In Python, to install any library, we use a very simple command, and that's the standard way to install any library. Okay, so the syntax we use in Python is you type pip, then install, and then the name of the library you want to install. Now, in our case, the library we want to install is called Pytest. So in this case, I would just type pip, then install, then Pytest. But where should we enter this command? So again, let me tell you that there are no restrictions on where you can write this command. There's no place where you can't or shouldn't write it. See, if you're using any IDE and that IDE already has an integrated terminal, you can use that. For example, in my case, I'll be using PyCharm. PyCharm already comes with its own terminal. Okay, so in that case, you can enter the command in that terminal. You just need to type pip install Pytest. Now, let's say you're using an IDE that doesn't have its own terminal for installations. In that case, you can open the command prompt and type this command there, pip install Pytest, okay? So I hope I've made it clear about installing Pytest, that to install any library in Python, we use a very simple syntax that's commonly used for library installation. That syntax is pip install followed by your library name. So the syntax for installing Pytest specifically is pip install, and my library name is Pytest. So altogether, it becomes pip install Pytest. I'll also be showing you how to install Pytest when we move on to the PyCharm ID. The very first topic here is about identifying the test files and the functions. Okay, so let's move ahead and check that out. So now we're going to learn about identifying the test files and the functions, and let's see what we have here in this particular section. Okay. Now, let's say you want to run a test file. Okay, let's say I give you a scenario. I put a case in front of you where you want to run a test file, but you haven't specified the name of the file. But in that situation, you want to run a test file and you haven't specified the name of the file. So what happens then? In that case, Pytest will automatically run the file. Okay, Pytest already has its own format, so it will automatically run files that follow that specific format, files that start with test and then anything after that, or files that match the pattern with a double asterisk and test. So if you have any files like this, or files in this specific format, then Pytest will automatically run all the files of those formats that you have stored in your directories or subdirectories. It will quickly run all those files that match the format test followed by anything, or anything followed by test, if you haven't specified the name of the file you want to run. Okay? So what it does is, it automatically picks up those files, the test files. Okay, we have a specific format for naming test files. So whenever you use that specific format, it will automatically recognize it as a test file format and run it accordingly. Right, that's how this actually works. Okay, now the next thing is that it also requires the name of the test function to start with test. Now let's see, you start with the test. Okay, so in that case, it might also require the name of a test function to start with test. Before running the test and everything, it will need the name of a test function, which has to be declared or used. Alright? Now, next, let's say if a function is in any other format except starting with test, then it doesn't consider them as test functions. I've mentioned that before as well. I'll repeat it once again. If you have a file and that file doesn't follow the format of test star or star test, then it will not consider them as test functions. No matter what you've written inside that file, no matter what kind of test you've put there, if it's not in the test underscore or underscore test format, it's not going to recognize it as a test function, right? So I hope I'm clear here about how test files and functions are identified. So here, if I scroll up again, let's say you want to run a test file, but you haven't specified the name of the particular test file you want to run. So in that case, what Pytest will do is automatically pick up files that are named in the format test star or star test, which are stored in your directories or subdirectories. It will use that specific format and automatically run all files matching the test star or test star pattern. Right, that's what it's going to do here. Next, it will also require a test function to start that test. Before starting a test, it also needs the name of a test function, and if a function is named in any other way than the test star or test format, then it doesn't consider it a test function at all, right? So I hope I'm making it very clear to you about how to identify test files and functions and how we identify them. So now we'll start with our very basic test implementation. Okay, now I'll explain how we can write a very basic and simple test. Let's move on. We have 13 very easy steps that are always followed and used. Then we'll move on to writing our test. Okay, here we have our very basic test implementation. So let's follow these steps to write a basic test. The very first step is to create a directory. Okay, creating the directory is a very important step, an important part that you need to do. Okay, then inside that directory you just created, make a test file. Okay, so for the test file, I already told you how we make that. We make it in the format of test asterisk or asterisk test format. Wait! So in that case, you can name the file according to the elements. Still, the asterisk means that after the word .test, you can add anything you need. For example, I can name my test file as test A, test 1, test 1, or test 2. The file's name could be like this. It's not necessary that you have to name the file as test asterisk. Okay, that's not required here. You can either put test at the beginning or at the end. It doesn't matter how you do it. What matters is that test should be written either at the start or at the end of your file name. Only then will it treat your file as a test file. The next time, I name my test file as test 1. Okay, test demo. So yes, that's my test file. Okay. So make sure you write the correct things. So inside that directory we created in the first step, now create the test file in that directory with whatever name you want to use. And after that, add the code into the test file. Now after that, add all the code you want. Put in the functions you want to write whatever program you want inside the test file. Just write that out. Okay, so this is a very simple step. This is actually how we write a very, very, very basic test. Okay, let's go over to PyCharm, and then I'll show you how to implement this step. Now let's do a very quick implementation and get hands-on with how to write a very basic test, right? So here I am in the PyCharm IDE, and we'll be writing that test right here in this IDE. Now, it's not mandatory to use only PyCharm. Whatever IDE you're comfortable with, you can just use that one, okay? So I hope that's clear to everyone. Now, how do we need to proceed up here? To start, first of all, you need to go on the respective, like the click on respective folder to the right-click there. Okay, click on New and click on this Python file. Now put up your respective Python file name, whatever you want to put up. Now remember, I told you 2 conditions in regards of that. The very first condition was you need to put up the test in the starting, or test at the last, right? Either in the starting or at the last. But it was compulsory for you to put up the word that is test, remember? So in that case, what do? Either write up test underscore dash dash, or you write dash dash underscore test. Both of those would work out. Free. So I have already made up a test file for me, but I would do out one single thing. I could write up a new file here that, let's see, test, and this code 2.1. Okay, it would be test underscore 2 on. Okay, great. And he can take the Python value made up for you. Right here, I have my Python file, which I'm writing up my test so as to run up the things. Okay, so what I would do, I would put up the basic implementation of the test as well. Secondly, I would as well put up here only that file execution, that how you execute up the respective file. Okay, for the first, I'm going to import up the module, that's the math module, because I will be using some sort of things of math. I'll be using up import math. Now I'm making up my false function. Now, in making up the false function as well, you have a thing that you need to mention up test in the starting. Write up test underscore or test simply. Test simply test. In front of that, you write up any name that would work. But if you are making up a test, it's case here. So make sure to have that test make sure to have the test in the prefix only. I would write like the test and there's 4.1. That would work for I. Put up the colon and get OK. Now I'll be like having n, and let's say I put up a number that's 4. Now I'll be using up here my function that's assertFun. Now what is that used for? Simply, when we write up a Python code onto that, what we use up simply the if it's condition, right? Let's say I want to check up that if this number is equal to that, or if it is greater than or equal to that, it's the things like that, right? So in that case, we use up this assert function. In the same manner, here in the Pytest, you use up this either. So it is a sort of condition. Okay, whatever the condition you are going to put after this assert function, if that condition is true, then it will show that one of your test case have been passed. And if that condition is false, so in that case, it will show that this respective test case has been failed. Okay, so hope I am clear with that. So first I will be putting math.square root. In the bracket, we have n. Okay, and that is equal to 5. And the colons are not to be put up. We use of the print statements before the same way you use of this assert function. Okay, next test goes as test_2. Okay, calm down. So sorry, here will be 2. Fine, so if the square root of 4 is equal to 2, so in that case, if this condition is 2, so this respective test will show as pass. Okay, get down here, I'll be putting up another condition. My other condition is assert. And let's say if I put up 6 times 6 is equal to 35. Okay, my second test case, which I wanted to put a part in that place. So again, assert is the same function. If your condition is true, then it will show you that the test case has passed. Otherwise, your test case will fail. Now here, this assert is a kind of function that we have only in Python, okay? So no additional things need to be used here. I'll be putting up my third condition as well. Test, underscore, and here goes 3. I put up the bracket and get down here. Here as well goes assert. Let's say my third condition I want to check is 21 equal to 12? Okay, my third condition. Now, we know that this respective condition will not be true, right? This is not the correct thing, right? This will not be true. This will be a fail. This will not pass. It will fail because 6 multiplied by 6 is not 35. It's 36, right? Here as well, 21 is not equal to 12. So in that case, this test will also be a failed test. Okay, so I hope I'm clear with this point. All 3 cases that I mentioned. Now, before running the respective test, I have one thing to show you. What if I remove this test from every function? What if I remove this? Okay, you should also know what happens if I remove the test from every other function. Then what is it going to give you? Wait, so how do we run this? For running, I already have this terminal attached to my PyCharm, so I will open up this terminal and write Pytest. So this is the command you use for running the respective test. Now see what it is showing. It is showing collected euro items, and it didn't show anything. It simply exited from here. Why? You already made a test file here. Test_1 was written. That was absolutely okay. That is the correct sort of thing. But again, why is it showing you no collected item? Because you haven't added the test at the start while making the function. That is the reason I was telling you to make sure to put this test at the beginning. Now, this underscore is not necessary to include. Okay, you can either use the underscore or not use it. Both of those are correct cases. See, here I didn't use it, and here I did. Both are valid cases, so it will run both of them as well. Okay, so here is my terminal. Okay, and I could simply type here as Pytest and hit enter. Okay, now just look at this. I just got some kind of result, some kind of output here. Now, let's understand what we get here as output. So I'll walk you through it from here. See, previously, what was it showing? It was showing 0 items collected, but now it shows us 3 items collected. Now, this green dot you see at the beginning means that 1 test has passed, and these 2 Fs you see mean that 2 tests have failed. So 1 pass and 2 fail. Okay, now here it shows that test2 is a function that's showing you the assertion error. Now, what is this assertion error? So see, whenever you use the assert function and that condition and the respective test fails, it will always generate an assertion error for you. Okay, make sure to remember this once again. Whenever you are writing a test and you use the assert function and that condition fails, it means your test has failed. So it's going to raise an assertion error for you. Okay, that's why for the test_2 function, let's see what the function was. So this was my test_ function, right? So here we're getting that 6 multiplied by 6, which we wrote. So that's why my test case failed here. Fine, so the red line is showing the failure. Okay, then my test 3 has also failed. So in this SR21 equals 12, this is also one of my failed cases because it's not true. So in that case, again, I'm getting an assertion error. So see, at the end as well, it's showing you a very short summary of your test info, that in test1.py, in this test1.py file, test2 has failed, and this was the condition you put, which failed. Then again, in the test1.py file, your test3 has failed, and this is the result, specifically the condition you put here. And at the end, it's showing you that 2 of your cases have failed and 1 of your cases has passed. Right, so I hope I'm being very clear about the specific case I just explained to you here, about how to do this. Now, I'm going to wrap this up here. Now, let's move on. Okay, what I'll do is comment out all of these 3 cases right here, and then I'll go down and write some new conditions here. Okay, so let's define it as, say, test1, add the colon, go to the next line, and my first condition, let's say, is assert 21 equals 21. Okay, now I'll add the correct test cases. Let's say test 2, add the parentheses, colon, go down, and my second condition will be, let's say 3 times 3 equals 9. Okay, so these are the 2 cases I've added. Now I'll try running this file again. So again, I'll just type 5s here and hit end. Now let's see what result we get here. See what it showed? It showed that 2 items have been collected. It showed 2 green dots. That means both of your files, both of your cases have passed. And see what it's showing? It's showing 2 passes in this many seconds. Right. So now I'm going to close this out. Right, so I hope it's pretty clear now how to write a very basic test, and moving forward from that, how to simply execute the file. Now here, we've executed just a single file, right? This was only one file. If you want to execute, let's say I create a new test file as well, I would do it here. And for the second file, I have test, and there's code 2.py. Okay, I would hit enter, and what I'm going to do is press Ctrl+D. So what that'll do is remove everything I've written up here. Okay, now everything has been uncommented in my file number 1. In my file number 2, I'll quickly write something up because I want to show you how to run multiple files and how to run single files individually. So here I would go with, let's say my function name is test, and this or false, let's say my function. Okay, put a colon, go down. So here goes assert, and let's say I would put 12 plus 12 equals 24. Okay, and here goes my second function, div. In that I have test, and this goes second. Okay, put the colon, and let's see. Here, my second condition goes as, okay, that would be, let's say 14 minus 2 equals 10. Okay, that's double equals, so it's not a single equals, it's double equals. Okay, so 14 minus 2 equals 10, right? Let's say these are the 2 cases. Now what I would do is go on and click on the terminal. Fine, now I have 2 files, test1 and test2. I would simply run my file right up here as file test. Okay, see what it does? It actually runs both of those test files for me. What did it collect? It collected a total of 5 items. In the test_1.py file, 1 was a case that passed and 2 failed. Let me zoom in so you can see what I was trying to show you right here. See now, right here, green dot means 1 has passed, FF means 2 have failed. In the test2 file, 1 has passed and 1 has failed. So in total, you have 5 items right now. Let's get down here. Now, just have a look at what it's showing you. It is showing you that for test 2, this was the test 2 you mentioned, and it has failed. And it shows you the assertion error. The reason for that, I already told you, right? Going down to test 3, this was the one that failed. Okay? Test and test second and test second. Fine? And this is the one in test second that failed. So what's the short summary? Here's the short summary you have. So in both of those, here's your summary info. In the test1.py file, test2 failed. In the test1.py file, test3 failed. And in test2.py, test_second failed. So in total, 3 tests failed and 2 passed. Right now, this is the complete overview. Now, it automatically ran both of these test cases for me. It automatically ran both of these test files for me. Now, let's say I want to run a specific one. In that case, I would write here, I would write Pytest and the file name I want to run. Let's say test_2.p, okay? And then -p and hit enter. Now what it's going to do is, see, it simply ran only one file for you, which is test2. In this, test_first passed and test second failed. So here you have one failed test and one passed test, right? So I hope I'm being very clear about these things. First, how to write a very basic test. Second, how to run a single file. And third, how to run multiple test files, okay? Now, let's learn about the different ways to run a subset of the test suite. All right, so there are several different ways to do this. Let's go over them and understand how they work. Right, so about the subset of the test suites, I already told you that we have a complete set of test suites, as I mentioned earlier. The IDE, RC, and a couple more that we have. Now, let's say you have a lot of test files, and each file contains many tests as well, right? So let's say you have a lot of test files, and in each and every file, you've written many tests. Okay, now let's say you want to run only a specific set of tests. For example, you have many files, and in one single file, you've written a lot of tests. And now you have a scenario where you want to run just a specific set of tests from that file. So what are the ways or tools used here to run a subset of the test suites? There are 2 different methods that are commonly followed. The first one is deciding based on the markers applied, selecting a group to run the tests. Now, we have markers here that are actually applied, and those markers are kind of like hints. We'll discuss this in more detail later. So there are markers that are applied, and you can run, based on whatever markers you've used, you can select the groups and run those tests. So this is one way you can go about it, deciding based on the markers you've set, and according to those, you can select the groups and run those tests. Okay, moving on, the second way is deciding based on test names using substring matching. Select the group to run the test. The second way is that you can decide based on the test names using substring matching. With substring matching, you can choose which tests to run according to their names, and based on that, you can run those specific tests. You can select the group to run the test in that particular case. So these are the 2 different ways you can use to run a subset of tests. First, I mentioned that you can use markers to select groups and run the tests. And second, you can use substring matching on the test names to select groups and run whichever specific tests you want. In Pytest, you have these options as well. For example, if you have many test files and each file contains a lot of tests, in that case, you can simply use these methods, set things up, and run them accordingly to get your desired output or run the specific test cases you want. So these are the 2 ways I already told you about for that scenario. Now, let's talk about how tests are grouped, okay? So we do have a command for this, but before we get to that, there are a few things you should keep in mind. So let's go over those first. The functions you create using Pytest let you add different markers to them, all right? Now, this is one of the important points to note, the functions that are created using Pytest, okay? So those specific functions let you add different markers to them, all right? So if you have a function that's created as a Pytest test, only then can you add different markers to that particular function. All right. Next, we're assigning features or attributes to the test cases using markers. So now, what's the purpose of these markers? Why do we use them? Because for the past slide or so, we've just been talking about and checking out markers and unmarkers. So what are they actually used for? They're used to set up features or attributes for the test, okay? Whenever you want to assign features or attributes to a test, that's when you use a marker, right? So they're used for assigning features or attributes to the test. Next, parameterize, skip, and so on are some types of built-in markers that we have in Pytest. So in Pytest, you also have a lot of built-in markers. So one or two examples have already been mentioned here. For example, parameterize or skip. So these are the types of built-in markers you have in Pytest. There aren't a lot, but yes, there are some built-in markers in Pytest that you can use to assign features or attributes to your test. So to run markers, what command do we use? The command we use is Pytest. After that, we write, then put angle brackets. And inside those, you specify the marker underscore name. Inside those angle brackets, you write your marker name, whatever marker you have. You put its name there, okay? And then after that, you have -p. That -p is also one of the commands you need to use. So the main thing here that's a bit different is that inside the angle brackets, you need to write the marker name, and also after Pytest, you need to add -m as well. The -p doesn't work, okay? So make sure you do that. So for grouping the tests, first of all, the functions that are created using Pytest allow you to add different markers to them, okay? Now, okay, let's say you're now allowed to add markers. Now, when you, why do you even use those markers? So those markers are used to set features or attributes for the test, okay? So we use markers on the tests that need to be set up. Then you have parameterize, skip, etc. These are some types of built-in markers that we have in Pytest. So yes, there are also built-in markers in Pytest, like parameterize and others, okay? And to run tests with markers, you use a command here, which is pytest-m marker name. And then you have the dash, right? So these are some points about grouping tests. Now, let's see basically how we set up markers, right? I hope you remember I told you about markers as well, that these are another kind of thing we have here in a Pytest. So let's check out how we set up markers, okay? But before that, I have something for you. See, what I've done is, I have these two files with me, okay? test_1 and test_2. Now, let's see what happens if I have a function name that's common. Let's say I have a word that's common in both files. Then what is going to happen? Now, let's say here I have test under first. What if I just go ahead and change this one as well to test first, okay? Now, what is going to happen if I go to my terminal at the respective location? So I'm going to write a command, pytest-k, and what was my word? My word was first, right? Right-click, put that up, and do -v and hit enter. So both of the functions that I had in both of the different files, test1 and test2, both of those functions have been picked up here, right? My test first in test_1.py file has passed, and in test2.py, test first has also passed. Both of those functions have actually passed here, right? So now just have a look at what it's showing me in this stream. It's correct. With 3 items, 3 were deselected and 2 were selected. 2 selected means that those 2 functions we're talking about here, those have the word first in their function name, so both of them were selected. And the functions that didn't have the word first in their function name, those were deselected, okay? So here I'm getting that both of them have passed. 2 passed cases and the rest deselected, right? So this is what happens whenever you have a function name and that function is actually some kind of thing, okay? Now I'll change it back to the one we used previously. Fine, great. So I hope you remember this command now, okay? Now let's learn about setting up markers, how we put different markers into our tests. So now you're going to import that file. Whenever you're setting up markers, it's compulsory for you to do that now, okay? Let's make a function, def sli, okay? I put the brackets, then the colon, get down here, I use my assert, and let's say the thing I want to use is 2 multiplied by 7 equals 14. Okay, now how to make up the marker? So wherever you have declared up your test, just above that one, put up at the right time in front of that. Write up errors Pytest, here goes your function, which is marked now. Put up the respective marker which you want to make up. Let's say my marker I want to make up here is completely. Let it be a fine. So I just put up that respective marker which I wanted to make, and yes, this has been made up a marker by me. This is how you make it up. Later, this is my second function, def, test, and this for b. Put up the bracket and put up the colon. Here we have the assert function, and into that, let's say I put up some sort of condition. Let's say I put up the 32 minus 0 is equal to 31. Okay, it's a mensu by candy again. Above that, what I would do, I would make up a marker. So Pytest hot mark hot. Let's say this is b. Okay, getting down, let's say I put up one more third function here, div, and let's say now I am having this standard force, C. Okay, put up the bracket, put up the colon, and get down. Here you have the absolute function. Let's say I put up 21 is equal to 21. Okay, and this is as well done up. Now I would make up that marker for phi is dot mark. Okay, dot mark dot t. Okay, so my third marker again has the makeup. So this is how you make up the markers. Let's say this is one of the things which has been made up here. Secondly, into the test file too, here I would make up some markers. Let me make up some changes into this one only. I would write up here import file. Okay, let me make up the marker here. Let's say that pytest.mark dot, and let's say I put up the same name. That's A. Okay, let's start B. If I do not put up A, I would put up with some sort of 1. Okay, here as well, let's say I give up the same name. That's mytest.o, my.1. See, whenever you are making up the markers, it's not compulsory for you. That is that each and every time you need to give up different name of month. It's not compulsory actually. Okay, it totally depends upon your choice that what sort of markers you want to give up here and what sort of things you want to use up. Okay, so let's see. Here I import up one more, that the math as well. So import math, and here I am going to put up if, and let's save that test underscore third. Into the bracket I put up the full, and get down here. I have the assert function. Okay, so here let's say I just put up this square root of some sort. So it math dot, let's say the square root of 12, okay, is equal to, I put up 2. Okay, and for this as well, I could make up a marker. So I could put up here goes by this dot mark dot c. Fine, that has been made up by me. Now, for both of the cases, for both of these test files, test 1 and this test 2, we had made up the markers for both of them. Right? Now, how to run this out and what's actually the thing that I was wanting to tell you. First of all, I would simply write Pytest. Okay, let's see what result we get. You see, it's basically the same as before. It's giving you a lot of different things. Okay, assertion error, and in test 1, it's showing that test 1 passed, test 2 passed, and the one in the middle failed. Okay, so in total, 2 passed and 1 failed. And this test 2, it's showing us 1. 1 passed and 2 failed. Okay, so a total of 6 items. Okay, I'm going to close this out and bring up the terminal here. I'll enter the command. Let's say you use dash for whatever marker you want to search for. Say I want to search for the marker OK and add dash B. So whatever marker you want to search for, you can just put that specific marker here in the respective field. Now let's take a look from the outside. Let me just minimize this. In test 1, we have the marker C for test C. So it's showing that here for test underscore C. Okay, this testy, it's in test 1, and that one passed. So that means it's showing that 21 equals 21, right? If I go to test number 2, and here, if I check this number, that's C. If I check this particular C, the marker has been set as a bias. So in that case, now my file is test underscore 2, right? Let's put up that test 2. Now, what was the test? My test name was test dash. So I quickly entered that, and that's fine. It's showing failed, so that means this particular test has failed. So in the end, what is it showing me? It's showing me that failed test-2.py is, so this equals this, and 1 failed, 1 passed, 4 selected, and warnings. We have that. That's totally fine. You'll get all those kinds of things, so no issues in that case. But here, it's showing 1 failed and 1 passed. That's absolutely true, right? 1 failed and 1 passed, right? So this is how you do it. Let's see if I give you one more. Okay, here we made 1-1. Okay, fine. This should work. A, B, C. Let's give it one more try right here. So I would put up here again, Pytest-M. My marker name is, let's say, 1. Okay, and here we have dash. Field and hit out it, but this also, it will give me one field, one path. So let's go above and check that out. So for the test, and it's for 2 files, my first was 12 plus 12 equals 24. That's completely okay. And the second was 14 minus 2 equals 10. So the first one passed in this test, and the second failed. And that's absolutely true. Right now, let's get down here, and here we have a summary that in this respective case, this is the failed case, and one failed and one passed, so deselected. Okay, so I hope you got the idea about how you can completely make different markers here with respect to the different types of functions you have. So markers could be made for all of the functions, all the test cases that you have defined, and for those respective test cases, you could make markers. Right after making the markers, you simply give the same marker names, or you could give different marker names as well, right? So, and what's the use of the marker? I've already told you in the PPTs we discussed regarding the markers, regarding everything we've discussed now, okay? So in that case, I did already mention what the use of the respective markers is, right here at this very place. Now, let's talk about fixtures in Pytest. What are fixtures in Pytest, and how do we use them? Right, so here we have fixtures in Pytest. So what exactly are fixtures? Fixtures are functions that run before the test functions they are applied to. Okay, so the functions that you run before the test functions they are applied to are called fixtures. So I hope I'm clear about what functions are used as fixtures. We have some functions that actually run before the test function. Right before the test functions, there are some functions that we apply, and those applied functions run before the test functions. So those are called fixtures. Right, now what are these used for? So whenever you want to set up some data for the test, okay, so whenever you want to set up some data for the test, that's when fixtures are used. All right, now what's the syntax for marking a function? Oh, sorry, I mean marking a fixture, for creating a fixture. For that, you use add_pytest.fixture. Now, in the last one, when you just, one second, let me show you that. When you learned about the marker as, for marking as well, you use the same command, which is basically @ followed by the marker. Okay, this is the exact command that's used in that particular place. Alright, so for fixtures in Pytest, the functions that run before the test functions they're applied to, those are called fixtures. Basically, there are some functions that run before the test functions, and those are the fixtures. And these are used to store data for the test. So the syntax you use here to mark up a function is @pytest.fixture. It's very simple, right? @pytest.fixture. Now let's quickly check out how we can add pictures to our test. So here I'm going to create a new file. My new file will still follow the standards, so let's do that for free, okay? And hit enter. My next test file has been created for me right here in the right place. Let's get started. First of all, I'm going to import Pytest. Now please listen to me very carefully here. After you've written a very basic test, a very basic Pytest where you're not using fixtures, markers, or anything like that, you don't need to mention or import Pytest. But in cases where you are using fixtures or markers, in all those respective cases, it's mandatory for you to import the Pytest module. Otherwise, you'll get different kinds of errors, okay? So make sure you do the respective thing. I'm going to make a function here, def d.canIs for value, okay? Now, as we've learned about fixtures, what are fixtures? Fixtures are basically executed before your test case. So these are types of functions that run before your test case, right? So in that same case, we're going to set, let's say, the value for I as 20, okay? And here I've written a very simple program. But what I'm going to do is create a fixture here. How do we do that? Write your Pytest, and here goes my fixture, F-I-X-T-U-R. This is how you make a fixture. Now, whenever you run this program, whatever functions or test cases you write after this function, those test cases will run after this fixture runs first. After that, those test cases will execute, okay? Let's say my test case is def test underscore check 1, okay? And I put the brackets like this. Get down, okay? So let's set up a case. I multiplied by 2 equals 4, okay? Let's say this is my respective case, which we have fun. Now, here's one thing to mention here. Actually, I just wrote that to show you. One thing to note is that if you want to use this value, which is I, then in that case, you need to mention the respective function name that you're using here. Okay, a searchable underscore value multiplied by 2 equals 4. Now, let's say I want to create the next one as well. So it's test underscore check 2. Okay, I put in a bracket. All right, so right here, I go down here for the assert function. Just a second, let me scroll down. Assert, then we have 6, and this is for value minus n equals 11. Okay, now, first of all, let me explain a little bit here, and then I'll move forward with the rest. See, first of all, importing pi was very important for me. That's why I already mentioned to you why it was important. Because right here, at this point, I wanted to mention the spiders, since I'm using fixtures. So if you're writing a very, very simple test, meaning if you're writing a very simple test without any fixtures or anything, then you don't use the spiders. But if you're using any add-ons for writing your test, then in that case, it's very, very important for you to use this library. So import that. Next, fixtures are for functions that run before your test gets executed, right? Fixtures are a kind of function that will run before your test gets executed. So first, this respective function is going to run. The stake value function will run. And after that, your test will actually execute. Okay, so that's how it's going to proceed. So here, I just set a value for I and simply returned I right here. Then I declared a function test check 1. Now, please note, I mentioned take and restore value because this was not a test case that needed to be tested. That's why I didn't mention a test at the beginning. But now, these are my test cases that need to be tested and evaluated as pass or fail. So in this context, it was really important for me to write this test at the start. Otherwise, it won't recognize these as test cases. Let me repeat that again. I'm repeating from the very beginning. So on that note, make sure that whenever you're writing a function, you include the test at the beginning, okay? Please make sure of that. All right, so this test underscore check 2 is done and everything is sorted. Let's quickly open up the terminal right here. Okay, now after opening the terminal, let's see how we write that particular thing. So now what we'll do is mention that specific value, that specific, let's say, word, which we've used as a comment in both of the functions. So we've used a common word, which is check, right? So I would write that in some kind of condition. So it's by test dash k, and we have the word, which is check dash, and then hit n. Okay, so great. Here we have S3, and both of these. What is it showing? It's showing that, okay, unsupported operand. So it has 2 failed cases and 1. Okay, wait, how come this, 1 second. Let's scroll up and check it out. So 20 multiplication, okay, 1 second, let me minimize this for a bit. So take and display value, I equals 20, return I, that's completely fine. If test check 1, take value 2, yes, so it is, so take value minus 10, multiplier 2 equals 40, equals check 1, check 2. Oh, I guess that's completely correct. I don't see any kind of issue here. Oh, let me scroll up real quick. Let me open up the same terminal. Let's see what's actually coming up here. Okay, oh, right. Let me just check about that. What kind of, oh, it's showing unsupported operand. That's multiplication. Let me scroll up. Okay, 8 items failed. 1 second, let me check right here. And what if I put this percent sign like this? And what if I put it like this? Then let's see what's going to happen. I would open up the terminal, write the same command by test. After that, we have -t. Other than that, I was having check -3 and hit out, right? Let's see what's happening. So yeah, 2 failed, that's completely fine, but it's not supporting the operand. But I don't know why it's not supporting that particular operand, because percent and all these kinds of things are supposed to be handled. By this time, it's been imported by us. After that, we are taking the value input, we've taken the return, we've made the function test with the name test. Oh, I'm so sorry. I didn't input the values here. I didn't input the values, so it will show you an error. Great. So here we have to put that respective variable, that respective function name, okay, in which we are taking the value, that take, and there's a for value up, okay? Right here, I have to put take and this for value. It was important, and now I will. Put in my respective sign. I would put in my respective sign as I needed it. Let's go to the terminal and write it. Try it out, right? I'll check it, give it a try, and there it is. Let's see. After that, we have the dash key, we have the word that's check, and we have the word that's sweet. Hit enter, and now let's see what's going to happen. So I guess now it's working. Great, it's working. So see what it showed us. So right here, it showed me that, okay, for the van, it just passed. So for check 1, it passed. So for this one, 20 multiplied by 2 is equal to 40. Yes, absolutely, that has passed. And for check 2, it has failed. So here, test check 2. So yes, 20 minus 10 is not 11, it's 10. So yes, that has failed, right? So 1 failed, 1 passed is deselected. Okay, now I'm going to close this out right here. Great. So we had, I would comment this, everything's fine. Now let's once again run it because it was previously showing things that were actually supposed to be shown. So write -k, here goes check, Tkinter check, and dash, we hit enter. It should be very clear. So see right here, it has collected 2 items, test3.py file, it has collected this test check 1 that has passed, and this test check 2 has failed. So what was here? See, it has taken the value as 20. As I already told you, it will automatically take that. So first of all, the fixture will run. After running that respective fixture, your respective test cases will run. So test check 2 has been done, and its value has been taken, and everything has been sorted, and at last you're getting the assertion error because the test has failed, and you're getting 1 failed, 1 passed test, right? Now let's learn about parameterizing tests, right? We've already learned about many of the topics before this. Now let's go ahead and learn about this particular topic. What does this mean right here? Okay, now how do we set up some parameters or things like that? Okay, let's understand that in this context. So whenever you want to run a particular test, okay? Now, let's say you want to provide multiple inputs to that particular test, okay? You get what I mean by multiple inputs, right? Like, let's say you have a form and you just set up a test for it. And in that case, you have a lot of inputs to enter there. For example, let's say you have 3 or 4 inputs that can be filled in that particular place. So in that case, you use parameterization for the test. Now, from the term parameterizing, I hope you have some idea about it, because we all, like when we study Python, whenever we have a function, we pass some kind of parameter to that function, right? So this parameterizing, this word is specifically related to that concept. Okay, so make sure to remember it this way. Parameterizing a test means that whenever you want to run the test with multiple inputs, in that case, you use parameterization for the test. Right. I hope I'm being pretty clear about this. Now, markers are made for parameterizing the test. Okay, just a few minutes ago, we talked about markers, right? About how we set up markers on a test. So how are those markers actually created? Okay, or what's their purpose? Okay. So the marker is used for parameterizing the test. So in that case, whenever you want to set up or provide multiple inputs, okay, in that specific place, in that specific way, a marker is created. Okay, so I hope now you can connect this to what we discussed earlier, where you can see how the marker fits in here and what the purpose of those things or these places is. Right. Now, what's the syntax that we use? Again, it's super easy to use the syntax. It's @pytest.mark.parameterize. Okay, so you write @pytest.mark.parameterize, and it works absolutely wonderfully for you. Okay, so I hope I'm being very clear about parameterizing tests, how you do parameterization, and why you actually use it, right? And what's the syntax for doing that particular thing? Now let's see how we can parameterize a test. I'll create a new test file here, a Python file, and this will be my test_4. Okay, let's get started. All right, so here I'm going to parameterize the test. So first, I'm going to import Pytest, okay? Now, how do we parameterize a test? We put the @ symbol right at the beginning. Okay. After that, what you do is write out your Pytest, Pytest, and here you put the function that's being parameterized. Okay, parameterized inside the parentheses. Now, for now, we'll just leave these parentheses empty. We'll add that later. Okay. I want to declare a function that's different. Different. And my function name is test_mul. Okay, so we're going to do some kind of multiplication. So here are my two parameters, n and final. My two parameters are set, then I put a colon, and here I have an assert function. Okay, assert. I'm going to write ken multiplied by n equals final. Okay, and what are the n values that I have? So I'll be setting those inside the parameterize. Okay, so first I need to declare the parameter n. Second, again, I need to declare the one called final. Now after that, adding a comma, I'll make a list. Inside the list, I'll declare several different tuples. In those tuples, I'm going to put the value for n and the value for final. Let's say it's 5, 50. Okay, my second tuple is 6, 60. Okay. And let's say my third tuple is 721. Okay, let's say these are my three tuples, which I created here with different values. Okay, now how this is actually going to work is that, first of all, my parameterized function has been declared. I have two parameters, n and final. So here it identifies n and final. And here is the function that I created. That's my test case, right? My condition where I've applied 10 times multiplication. What's the value for n? The value for n we have is 50. So 10 times 50 equals, what's the value for final? That's 50. Yes, this condition is true. So one of your test cases will pass. Same goes for 60. So 10 times 6 equals 60 in the final. Okay, same goes for a third condition, 721. So 10 times 7 equals 70, but here we have 21. So two of your test cases will pass and one of your test cases will fail. Let's try that out. 1 second. This doesn't need to be in different brackets. Okay, don't use different quotation marks. Keep it in single quotation marks only, because this is n and this is final. Go to the terminal right here, type pytest-k, you have mul, and here we have -v. Hit enter here. Right, let's go ahead and check that out. So see what it did? It collected 3 items. So you have a total of 3, 550, 660, and 721. Right? Let's scroll down. Here you have the failures. So test mul, mul, and for this test case, it failed, which is 7 minus 21. It failed for this one. Okay, so the input value was 7 and the final value was 21. So here you have the Pytest parameterize function, and this one failed up here. This particular test failed, right? So in the end, you got an assertion error because you used the assert function. So whenever an assert function fails, you get an assertion error. So finally, what's my short summary? My short summary is that the failed test is in the file, test_4.py. The function that failed is test_mul. Assert is the condition that you set. So overall, you have 1 failed case and 2 passed cases. So I hope I'm pretty clear about this. That's how it works. Now let's see if I fix this as well, right? If I set it to 70, if I go back to my terminal, type in pytest-k, here you have mul, and you add -v, then hit enter. Now it's going to show that all 3 cases have passed because 5 times 10 is 50, 6 times 10 is 60, and 7 times 10 is 70. So all 3 of my test cases have actually passed here, right? So I hope you're pretty clear about this part regarding the parameterized function as well. Stopping the test suites after n tests fail. Now, when you're going to stop the test suites after n tests fail, now let's say you have some kind of value, some kind of number. So as that number of tests fail, what you want is to stop those tests too, okay? So now we're going to understand that particular thing. So we have our function called maxFail. I'll repeat that again. It's max, M-A-X, max, and F-A-L, fail. So this is a function that helps you stop the test suites after n tests fail, okay? This maxFail is a function that helps you stop that specific thing, which is, first of all, a function used to stop the test suites after n tests fail. Let's say what you want is, as soon as another 3 tests fail, okay? Let's say, I'll just give a very simple example here. Whenever 3 test cases fail, after that, you want to stop that test suite, okay? So in that case, this maxFail, and maxFail actually, the maxFail is a function that allows you to do that. MaxFail means that after this maximum number of failures, I want to stop running my test suite. Okay, so the syntax for this is we have Pytest. You can add a small dash. Okay, it's actually a double dash. Pytest, double dash, then you have the respective function, which I told you about. That's the maxFail function, and equals. And inside the angle brackets, you're going to put the number after which you want to stop your test suite if that many tests fail. Okay, so for that, you have num, which is a parameter, and you need to set this value according to your. So here, num refers to the number of test failures after which you want to stop the test. That's what I told you, that n is the respective num, and num is the parameter or variable where you're going to put some value, so that after this number of test failures, just stop my test suite right there. Next, we're going to cover the topic of running tests in parallel. Okay, as I mentioned right at the beginning about Pytest, Pytest lets you run tests in parallel, right? But how does it do that? Let's take a look at that now. Now, let's get some more information about Pytest first. By default, it's a tool that runs tests in sequential order. By default, Pytest runs tests one after another in sequence. This means that whatever order the functions are written in, let's say, for example, the very first one is a function called 1. Below that, I have a function called 2. And below 2, I have a function called 3. So it will only run things in a sequential manner. First, 1 will run, then 2 will run, and after that, 3 will run. So it will run in that way, okay? This is what's called sequential order. All right, so this is the default behavior in Pytest. Now, let's say you have a test suite, okay? And it contains any number of test files. You can add as many test files as you want. You have 50, 100, 200, however many you have, you just put those test files there, okay? Now, in each test file, there are also a lot of tests that you include and run. You write a lot of test files that go into that. Now, if you have a test suite, the test suite contains many test files, and each of those test files contains a lot of tests. So it requires a huge amount of execution time, right? There is a long process, and it also takes a lot of time to execute. So to avoid that long execution time, Pytest gives you an option that lets you run the tests in parallel, okay? By default, Pytest runs the tests in sequential order, but you also have the option to run the tests in parallel in Pytest, right? So that's actually why there's a need to run the test in parallel, okay? That's the reason for doing this, all right? Now, moving on to the command to install this, you just type pip install, then Pytest, put a dash, and then write xdist, okay? This is the command used to install the requirement for running tests in parallel, all right? So I hope I'm being very clear about this as well, about how we're going to proceed with this, right? Great. Moving on, I have a summary of all the topics we've covered so far. Let's quickly go back and review the summary of all the topics we've studied up to now. First, we learned about identifying test files and functions. In that case, we took an example where, let's say you want to run a test file, okay? But you didn't specify which test file you want to run. So in that case, any files in your directory that start or end with test in their name will automatically be run by Pytest, okay? So whatever file you've named with test, either at the beginning or the end, Pytest automatically recognizes those files as test files and runs them, right? So I hope I'm clear about this point regarding how test files and functions are identified. Okay? Now, moving forward, you should know that it also requires the name of a test function to start with test. So as I mentioned, wherever it finds test written as a prefix or suffix, meaning at the beginning or end, it will treat those as test files, right? And if a function is named in any other way except starting with test, then it doesn't consider it a test function. Okay, so now let's try up here. The next topic we're covering, which is the max fail function, right? Remember I told you we have a function here that after a certain number of maximum failures just stops running the test suite. In that scenario, it would stop running the test suite after n number of tests have failed, right? Let's quickly do a practical example of that as well. So I'll comment this out. Let's do it right here in this file. No need to make a new file or anything like that. So first of all, I'm going to import the Pytest module. Okay, import Pytest. And I'll import math as well. Let's use that a bit. Otherwise, we're just writing a really simple program. So let's use some different things too. So I've used math here. Okay, I'll make my function, and let's say it's called def my underscore test name is, okay, fail. And in the brackets, I'll put it like this, add the colon, go down, fine. Let's say I declare our n value. Let's say it's 20. Okay, I use my assert function here. N plus n equals 4. That's my first kind. Okay, I could use it like this. Now let's see. I think of this query. So test SR, let's say. Okay, SR score fit. Put the brackets, go down. Now, I think of this square root. Let's say for that, it's 9. So here goes my condition. Assert math.sqrt of n equals, okay, I put the wrong value. Let's go down and add our third case here. Let's say this one is score m, and this is for the multiplication kind of thing, actually. Okay, so here I could simply write assert 6 times 5 equals 31. Okay, let's say I put this number of cases here in this particular one. I have 3 test cases, one for the Pytest, second for the math. So here we have test add fail, test SR fail, and test M fail. Great, we have all of these things. Now, what was the max fail function used for? It was whatever number you put in front of the max fail function. As soon as that number of test cases have failed, it will not move forward and will stop right at that point. Okay, let me show you how. Let's say I open up the terminal here and I write the command like this. What's my file name? My file name is test4.py, my file, okay, right here. Then we have ~v, we have _ here, and that fail function. And let's put a 1. It means that in my test4.py file, as soon as I get the maximum failure of 1, if I get 1 failed case, in that case, stop executing my program. See what it did? Let me go to the respective place and show you how. See what it did? It collected 3 items from my file, but ran only 2. Why? Because my maximum condition was that as soon as one of the failed values was reached, as soon as one test case failed, stop executing my file at that point only. So one of my test cases failed at this point, which is test_sr.fail. This was my wrong case. So as soon as it found that, okay, the maximum value was 1 and one test case had failed, it would not move forward with this. So it did not take up this next test case here. So see, it showed that test_fail and sr_fail. Only 2 are shown. And for test_sr.fail, it shows that this is the one that failed. You got the assertion error, 1 failed, 1 passed. Okay? And see what it showed. It showed stopping after 1 failure. Stopping after 1. Now, let's say I run this once again. Okay, now let's say I wrote here the file name was test4.py-p ~maxfail, and if I put the value here, now when it will get the maximum failures, it will stop at the effective phase. Now let's take a look. My first case passed, so that was our fail test. The second one failed, SAR fail, and the third one, which is M fail, that one also failed. So these are my failures. My failure is test.sr.fail, and this is another failure, test.mfail. And see what it's showing? It's showing that it stopped after 2 failures. So 2 have failed and 1 is correct. I hope you now understand the idea behind the maxfail function as well, how you use this maxfail function, what it's for, how you set it up right here, and how you get these respective results in the right place. I hope I've made all of this pretty clear to you, how we do the hands-on part for all the topics we've covered in this Pytest session.
Let's make life easier by using Python for automation. You'll learn how to automate repetitive tasks and even build user-friendly GUIs.
What exactly is testing? Let me show you right here. So from this one simple word we have here, testing, let's first of all not get too deep into technical definitions or anything like that. If I just talk about what testing is in plain everyday language, right? What do we say? Testing is basically trying something out, right? So testing means, let's say you have an idea or an app or something you've developed on your own, and now you just want to test it out to see if it's okay. Is this something that's ready to go to market? Is this something I can give to people or something like that, right? So in the same way, in the same process, we talk about testing in the field of software development. What we say is that whenever you're developing any software, any product, any component, let's say it's a website, an application, anything you're developing, any product I'm talking about here, right? What do we have to do? We have to analyze it, right? We need to ask, okay, what features have I added to it, right? After that, we need to evaluate which components basically have errors or bugs that have surfaced. Why is it necessary to do that? It's necessary so that when your product goes to market, when it's delivered, it's completely free of errors or bugs. We all are familiar with that. If okay, let's say you made out a login page. Let me just quickly take an example here. Let's say you made out a login page, right? In that login page, basically, let's say everything is totally and clearly mentioned, and you had just attached out some database to that as well. Fine. Now, whenever you are just running that out, let's say whatever the username or whatever the password a person is saving onto that login page, that is not getting saved again and again. That is showing the error, and you have already sent that in the market. What is that? That is a type of error which is coming into your product, which you have already sent into the market, right? That doesn't go in a right way. So this is the use for testing that why you used to and why basically you just need out to do out the testing. And if you have done out the testing at your end, first of all, you have just removed out all the errors, you have removed out all the bugs which you are having into that. After that, now when you are just figuring out and giving it a test, in that case, what you just figured out that, okay, when I'm entering the username and when I'm entering the password, so that is not getting out saved. So I just need to figure this error, figure this error, or figure this bug, whatever is there into that, so that whenever it just gets delivered into the market, whenever a person buys out this application, or whenever someone logs in onto this particular page, so that particular person does not faces out any error, right? This is what we actually want. What we want is that whatever the things which we are making that are absolutely correct, and if a person is using those things, a person should not actually face any type of difficulties or any types of error in that. So this is the point where you need out of testing, right? Right now, here we are just generally talking about the testing thing. We are not going that you are testing for a software, or you are testing for an app, or you're testing for anything. We're just not going into that particular thing, right? So whenever you just develop out a software component, or you just develop out any project, we need to analyze that. We need to inspect its features. We need to go through the features which you have added. We need to evaluate what are the components you have put onto that particular application. We need to analyze, we need to evaluate that are these components, are these features which you have added into this application, added into this product, are that errors or bug free? And if yes, so whenever and why basically, we just need to check out that is that error or bug free, so that whenever you just whenever this product of yours get delivered into the market, whenever the user uses that product actually, so they do not face any types of errors or bugs, it is totally free of any error or any bug, right? So now this was a point where we actually need to do extensive testing of the software. If I just talk about the software, or if I talk about the product, this is the stage where you really need to do thorough testing of the software, right? Now, when is testing done? I just explained to you what testing is and what it's used for. Now, when is it actually done? Testing is done whenever your application is built out, right? Whenever you've finished building your application, after that, you test it. Give it different test cases, give it different databases. We'll discuss all of that in a little while. So just to give you an idea, you provide different test cases, you define them, you give it different databases, and all those things. So whenever your application is actually ready, whenever your application is fully built and ready to be tested. So in that case, we just go ahead and do the testing, and we deploy it to different test servers or test environments that we have, so that whatever testing needs to be done on that particular application, we can perform it there. Righty, let me just quickly go over that again. Let me quickly explain again what testing is, when it's done, and why we need it. So once you've developed a software component or a project, you have to analyze and inspect its features, and also evaluate the component for potential errors and bugs. This is so that when it's released to the market, it's free of any bugs and errors. That's the point where we need extensive software testing, right? And when is that done? Testing is done when the application is built, ready to be tested, and deployed on the test servers or environments. That's basically what I can say about testing. Testing is essentially to check its features, to see if there are any errors or bugs. If there are, then we fix them, and if not, then it's absolutely ready to go to market and is totally free of bugs and errors, right? I hope you now have a basic idea of what testing is. Now we'll be discussing what manual testing is. So as we already discussed, we've seen what testing is. Now there are two types of testing in Selenium. First is manual, and the second is automation. Here we'll be talking about manual testing. Let's get started. Let me move on to the second one. All right, now again, I would say, let's not get too technical here. Let's just simply understand what the word manual means. If I talk about manual in simple English, I would say manual means anything that's done by hand, right? Anything that's done by you, done manually, that's what manual means. And if I talk about testing, as we've already discussed, we implement different tests, we implement different features and pages, all these things, to make our product error-free and bug-free, right? I hope you now have a basic idea of what testing is. Now we'll be discussing what manual testing is. So as we already discussed, we've seen what testing is. Now there are two types of testing in Selenium. First is manual, and the second is automation. Here we'll be talking about manual testing. Let's get started. Let me move on to the second one. All right, now again, I would say, let's not get too technical here. Let's just simply understand what the word manual means. If I talk about manual in simple English, I would say manual means anything that's done by hand, right? Anything that's done by you, done manually, that's what manual means. And if I talk about testing, as we've already discussed, we implement different tests, we implement different features and pages, all these things, to make our product error-free and bug-free, right? So here, if I just combine the simple idea of manual and testing, I could just say, without any technical definition or anything complicated, that testing which is done manually is called manual testing. Isn't that simple, right? Yes, exactly. So I would just ask you not to jump straight into the technical definitions. First, try to analyze, okay, what is the name of the topic? Simply, the name of the topic is manual testing. Manual means anything you do by hand, and testing you already know. It's to test your software, to test the products you've made, so that when they're released to the market, they're completely bug-free, right? So this is where the definition of manual testing comes in. Now, if I talk about things in more detail, I would say that manual testing means the application you've made, the application that's actually developed by you, the product developed by you. So here, we'll specifically be talking about the application, okay? So from here on, I'll be using the word application. Manual testing means that the application, basically the application that's made, is tested manually for issues. This is simply what manual testing is, right? So whenever you've created any application and you test that application manually, that's what's actually called manual testing. Now, when you're doing manual testing, what are the things that need to be done? The tests that are there actually need to be performed manually in every environment using different data sets. At the beginning, I also mentioned data sets, right? We use different data sets, and we even create some test cases and then try to implement and test our software manually, test the product, test the application manually, right? So whatever tests you're performing manually, that's all part of manual testing. Whatever tests you're performing, they need to be done manually in every environment you have. Right? In every environment, you'll be using different data sets. After using those different data sets, you'll also note down the rate of success and failure. Okay, whatever transactions you're performing, whatever data sets you're using, for each data set, you'll be recording the success and failure rate. All of that will be recorded. This is what actually happens in manual testing. Let's say you develop an application. Let's just say you developed any application and now you want to test it. If you're going to follow the manual testing procedure, first you need to test that particular application in every environment, each with different data sets. For every environment, you'll also be noting down the success rate and the failure rate for each transaction and for each data set you're testing. This is what actually happens in manual testing, right? Everything is recorded, but this is all about manual testing, what it is and how we do it. Next, when I talk about manual testing, I would say that it is absolutely mandatory, meaning it's very important. It's important for every newly developed software before automated testing. So whenever we go ahead and, let's say, develop a new application or new software, in that case, it's mandatory to first do manual testing and then move on to automated testing. I mean, it's mandatory for every newly developed software to go through manual testing before automated testing. What is this automated testing that we're going to discuss in a few minutes, right? So let's not go too much into detail about automated testing just yet. But the way I explained it to you is by breaking down the words. If you break the term automated testing into two parts, the first being automated and the second being testing, if you break down both of these and figure out what they mean, then absolutely, you're right. The definition you're thinking of for automated testing is absolutely correct. I'll be proving this to you in just a little while. All right, first of all, let's discuss manual testing in detail. Now, what happens in manual testing is that you're doing everything by hand. You test in every environment, you test with different data sets, you provide different cases, you note the success rates, you record the failure dates, all of these things. When you do all this, it absolutely requires a lot of time and a lot of effort. But when you're doing anything manually, when you're handling things on your own, when something is tested manually by testers, it does give you a certain assurance of bug-free software. Machines aren't yet so automated that they can guarantee bug-free software. But if you're doing it yourself, yes, that gives you complete confidence in having bug-free software. So if I talk again about manual testing, it means that the application, the web application you've built, or any application, is tested manually by QA testers. The tests you perform need to be done manually in every environment using different data sets, and the rates of successful and failed transactions should also be recorded. Why is manual testing necessary? So, manual testing is mandatory for every newly developed software before automated testing. This kind of testing actually requires a lot of effort and time as well. But it gives you bug-free software, a guarantee of bug-free software. Right, that's about manual testing. Now, if I talk about the challenges, what are the challenges that manual testing faces? Well, there must be some challenges, some limitations. In manual testing, right, that's why we were introduced to an automated tool like Selenium. There must be some challenges in this type of testing, and that's actually the main reason why automation testing was introduced. So let's look at what the challenges are in manual testing. First, it requires more time and more resources. Absolutely true. So when you're doing anything manually, right? When you do anything manually, it will definitely take more time compared to doing it with an automation tool, right? So this was one of the challenges faced in manual testing. It actually required more time, and even more resources are needed, right? Differences in GUI object sizes and color combinations, etc., are not easy to spot in manual testing. So whenever you're doing manual testing, whatever GUI objects you've created, whatever color combinations you've used, whatever size differences you're dealing with, or the different color combinations you're trying to figure out, all of these things are actually not easy to find in manual testing, right? These are things that really aren't easy to catch manually. After that, running the same test over and over again is also a time-consuming and tedious process, absolutely. So whenever you're doing things through manual testing, what did we see there? We saw that in manual testing, first of all, whatever application you wanted to build was actually built. After that, when the tests were performed, what was happening in that case was that the tests were run in all environments. Then different data sets were provided, and after those different data sets, you had to record the success rate, you had to record the failure rate, and all these things were actually done. So all of these things were done manually. So it was a very time-consuming process to run the same test over and over again, to execute the same test repeatedly. Yeah, it actually takes a lot of time, and it's also a difficult and somewhat challenging process. So these were the three challenges faced in manual testing. First, it requires more time and more resources. Second, the GUI object size tip. Prints and color combinations are not easy to identify in manual testing. And third, running the same test over and over is a time-consuming process as well as detailed, right? So here we discussed manual testing and its challenges. Now I'd like to introduce you to what automation testing is, what we actually mean by this term. Again, I don't want you to just quickly read the slide. No, I don't want you to do that. First of all, in simple English, think about what automation actually is. Automation means to automate anything using any kind of machine. Wait, automating means making something automatic. Testing? We're already familiar with what testing is. So basically, in automation testing, we already have a framework. We already have a set of tools specifically for that purpose. The tests that need to be performed on any application are carried out automatically, so you don't have to manually record the success rate or failure rate, you don't have to manually test every single data set, and you don't have to manually run tests in all environments. None of these manual steps are required in automation testing. Automation itself means that everything is done automatically. Right, so in automation testing, whatever tests you run, all of them are actually executed automatically. Right, let's read this. As the name suggests, automation testing takes software testing activities and executes them using an automation toolset or framework. As I mentioned at the beginning as well, in automation testing, what happens is that you just take whatever software testing activities you want to do and simply execute them through an automation toolset or framework that you already have. So you just put those things into that automation toolset or framework, and whatever tests you want to perform for any software or application, you can just perform those tests on it. Now, if I put it in very simple words, what does automation testing actually mean? We can say that it's a type of testing in which a tool you have executes a set of tasks in a defined pattern automatically. Automatically is an essential word to include in a definition of automation testing. So this is a type of testing where a tool automatically executes a set of tasks in a defined pattern which is already set up, and it automatically performs and executes the tasks that are given to it. Right, this is what falls under automation testing. Now, where is this method actually used? This automation testing method uses scripted sequences that are executed by testing tools. We already have many scripted things written for this. We already have scripted programs written for this automation testing method. We just simply use them, and they are executed by the testing tools we have here. Wait, this tool executes examinations of the software outcomes and compares the results with earlier test runs. Now, what are the things that automation testing tools can do? So in that case, it can execute examinations of the software, it can basically report whatever outcomes there are, and it can even compare the results with the earlier test runs that were actually done. It can compare those tests, and we can just see the comparison in the results for whatever earlier test runs you have carried out, right? This is what is here in this automation testing thing, what it actually does. So it executes examinations of the software, it reports the outcomes, and it even compares the results with the earlier test runs. Right, this is about automation testing. If I give you an overview of automation testing, so we can say that, as the name suggests, automation testing takes software testing activities and executes them via an automation toolset or framework. So we have a tool set or framework through which this automation testing actually takes place. If I put it in much simpler terms, I could say that it's a type of testing where a tool automatically executes a set of tasks in a defined pattern. So basically, in this automation testing method, we use scripted sequences that are executed by testing tools. What these testing tools do is help us carry out examinations of the software, report the outcomes, and even compare the results with previous test runs, right? So I hope you first got the idea about what manual testing is. What were the challenges faced in manual testing? That's why we needed to introduce automation testing. After discussing those challenges, we simply learned what automation testing is. Now, in the next part of the video, we'll be talking about Selenium in detail. We'll go through an introduction to Selenium. So now, we'll be discussing it, and I'll be guiding you through the introduction to Selenium. This is actually where we start with Selenium. So let's get started. Let me just take you to the new slide, and here we go. First of all, we'll be going over who introduced Selenium. Basically, who was the founder, or you could say who developed Selenium. After that, we'll look at how things are done and what Selenium actually is, right? So Selenium was introduced by Jason Huggins in 2004, right? So we can just say here that Selenium was introduced by Jason Huggins in 2004. So he was an engineer at ThoughtWorks. So basically, how did the idea come about to introduce something, some automated tool? So what he was actually doing was working on some web applications, right? He was just building some web applications, working on his web applications. Suddenly, he realized he needed some testing technique, right? He suddenly realized, okay, I need to go ahead and test this particular web application that I'm building. Now, doing manual testing absolutely takes a lot of time and effort, as we've already seen in the previous slides. Manual testing, first of all, takes a lot of time and also a lot of effort. Why? Because the tests that are actually there are carried out manually, first of all. After that, the tests have to be performed on all the environments, and you need to create different test cases for that. Then, whatever the success rates or failure rates are, you have to note them down and then come to a conclusion. This is what happens in manual testing, and it's definitely a long, hard, and time-consuming process. So then, basically, Jason Huggins thought that there must be some tool with some automated features to make testing easier and faster. This is where Jason Huggins introduced Selenium as an automated tool for testing frameworks, right? So if I just quickly talk about who introduced Selenium, the name of that person is Jason Huggins. He was an engineer at ThoughtWorks. So one day he was working on some applications and needed testing. At that point, he developed and introduced the Selenium Automated Testing Framework, or you could say tool, right? Now, any testing that we do with the help of Selenium or by using Selenium is called Selenium testing. Again, just from the word itself, it actually tells you what Selenium testing is about. So testing that is done using Selenium. Any tests we perform with the Selenium tool are referred to as Selenium testing. Now, what exactly is Selenium? So it is an open source tool. First of all, the very first thing is that it's an open source tool, a portable framework that's used for automating tests carried out on web browsers. Selenium is first and foremost an open source tool, which is great. It's a portable framework, so you can use it anywhere, and that's also a plus. It's specifically used for automating tests that are run on web browsers. Actually, Selenium works on different web browsers. It has the capability to operate across various browsers, right? So whatever tests we have, basically, it's used for automating tests that are performed on web browsers. What are the web applications you can test with Selenium? You can use this framework, Selenium, on them. So those web applications you can test include shopping carts, email programs like Gmail, Yahoo. All these cases, in all these places, you can actually use the Selenium framework. So first of all, it's a completely open source tool, which basically means you can just download it. It doesn't require you to pay for any version or anything like that. It's totally free of cost. After that, it's a portable framework. So you can use it anytime, in any situation, and it's used for automating tests that are run on web browsers. The kinds of web application testing you can do with Selenium include shopping carts or email programs like Gmail. Yeah, these are the kinds of things you can actually do using Selenium, so I hope you got the idea. First of all, let's talk about who introduced Selenium. So Jason Huggins was the person who introduced Selenium in 2004. So who was he? He was an engineer at ThoughtWorks. Why and how did he come up with the idea to develop and introduce Selenium? Well, he was working on some web applications and suddenly needed a testing technique. Manual testing was a very long, very time-consuming task, and it actually took a lot of time to do all that work. So this was a situation where there was a need, And that's when Jason Huggins developed Selenium, an automated testing tool. So any testing you do with Selenium is called Selenium testing. And what exactly is Selenium? It's an open source tool, a portable framework that's used to automate tests that run on web browsers. It's only used for testing web applications like shopping carts or email programs such as Gmail or Yahoo. You're all familiar with shopping carts, and nowadays everyone prefers shopping online and all that. So these are the kinds of applications where you can use Selenium. Now, why should we use Selenium with Python? As I mentioned at the beginning, Selenium is one of those tools that can be used with the Python programming language, and you can also use Selenium with JavaScript. So what's the use, and what are the advantages? Why should we use Selenium with Python? Let's take a look at that. First of all, we're all familiar with the Python programming language, and there's no doubt that one of Python's important features is that it's very fast and also easy to learn, right? It's a very simple language. So that's the first reason why we should prefer Selenium with Python. Python runs very fast, absolutely. It's a very fast language. It uses indentation to start and end code blocks, so the indentation in Python is a very systematic thing that you need to follow very strictly. So let's say you apply a condition. When you do that, first you write the condition on the first line, and then when you go to the next line, you leave some space at the beginning, and then you start writing the block of code you want inside that condition. That's what indentation is, and it actually helps us see where a particular block of code starts and ends. It makes it easier for us to analyze all these things, and that's why the use of indentation is so helpful. Great. Next, it's very simple. Absolutely right. The syntax we have in Python is also very simple and compact. Yes, getting started is straightforward and much more compact compared to other programming languages. I hope by now you're all pretty familiar with Python. So you must also be familiar with the features I just mentioned. It's much faster, and the indentation we use here helps with that. It's very simple to use and also compact. If I compare this with other programming languages, this is the first reason why we use Selenium with Python. The second thing is we have a tool called WebDriver. In Selenium, we have this tool, right? WebDriver is a very important tool in Selenium. We'll be discussing this in upcoming videos. For now, just understand that WebDriver is an important tool in Selenium. This is the tool I was talking about. I was telling you about WebDriver, which actually has very strong bindings with the Python programming language, right? So this is an important tool for easy user interfaces. That's WebDriver. And it really does have strong bindings for Python. This is another reason why we prefer Selenium with Python. Moving on to the third point. It runs rapidly compared to other programming languages. It's true, Python actually runs faster when compared to other programming languages. Also, the programming language is free and available as open source, which is absolutely true. Python is an open source language, so anyone who needs it can just download and use it. You can use it freely in any environment. Yes, that's also the case. It's not like you need a specific environment to work with Python. No, you can download any environment you prefer, then just download the Python programming language and use it right there. So we can say it's free, open source, and you can simply download and use it in any environment you choose. And the last one, it's easy to code and easy to read. That's one of the important points, one of the key features of the Python programming language. It's really easy to write code in, and even easier to read. So I hope you now have a clear idea about these 5 points, these 5 reasons for using Selenium with Python. Let me quickly give you an overview. Python runs very fast and uses indentation to start and end code blocks. It's very simple and compact compared to other programming languages, right? We have a very important tool in Selenium, which is the WebDriver, and it has strong bindings for the Python programming language. The Python programming language runs quickly, especially if we compare it to any other programming language. So it runs quickly, and this language is also free and available as open source. So if you just need it, you can quickly download it and use it freely in any environment. And finally, it's very easy to code in, and the syntax, the programs you write in the Python programming language are also easy to read. So those were the 5 reasons why we prefer Selenium with Python. Now here, basically, we've discussed what Selenium is and why we should prefer Selenium with the Python programming language. In the next set of videos, we'll be looking at the advantages and limitations of Selenium testing. Now we'll see what the advantages of Selenium testing are. Let's go ahead with that. First of all, the very first advantage of Selenium testing is that it supports various programming languages for writing test scripts. As I mentioned in the previous video, I already told you when we discussed the topic of why Selenium with Python. I mentioned that you can actually do Selenium testing with other programming languages as well. I gave the example of JavaScript, right? So the same advantage is mentioned here. For writing test scripts, there are many programming languages that are supported. So whatever you are, whichever language you are familiar with, you can absolutely choose that language and go ahead with it for writing your test scripts. Another very important advantage, and I could even say a really great feature of Selenium, is that it is supported on various web browsers as well. You can use Mozilla Firefox, or you can just go with Google Chrome. Whatever web browser you're actually using, Selenium supports many different web browsers, right? Let's say you use Firefox, Google Chrome, or any other browser you want, you can just go ahead and use that. Next, it supports parallel test execution. Now, what parallel test execution is, I'll discuss in detail later. For now, we just need to understand that Selenium also supports parallel test execution. It means, just to give you an overview, that you can run many tests at the same time on a particular application. This is, you could say, a simple definition of parallel test execution. Selenium actually supports this feature. Another thing that's also mentioned in the definition of Selenium is that it's open source. So you can use it whenever you want. Just download it and use it as needed. It's completely open source software, right? Next, Selenium also supports different operating systems. I mentioned and told you that it supports various browsers as well. Along with supporting various browsers, it also works on different operating systems. Whether you use Windows, Linux, or Mac, whatever you choose, it supports all of these operating systems. So these are some of the advantages of Selenium testing. Now, what about the limitations? As I mentioned at the beginning, if something has advantages, it will definitely have some limitations as well. So let's look at the limitations of Selenium testing. I mentioned that it works on web browsers, right? I pointed this out specifically. This is one of the limitations of Selenium. It only supports web-based applications. Whatever application you are building, it only supports applications that are web-based, that basically run on Google Chrome or Mozilla Firefox. It simply supports only those web-based applications. Now, whenever new features are introduced in Selenium testing, there's no guarantee that they will work or not. Sometimes they might work, sometimes they might not. So this is another limitation we're seeing right now with Selenium testing. And here are some important last 3 limitations about Selenium testing. There are some use cases where Selenium just doesn't work. First, Selenium cannot perform testing on images. That's the very first thing. It cannot perform any testing on images. The code written for this testing and everything else does not support testing on images. You also cannot automate CAPTCHAs using Selenium. Right now, in today's world, we see CAPTCHAs everywhere. Whenever you log into any website, they ask you to fill out a CAPTCHA, right? Selenium cannot automate that. So CAPTCHAs cannot be automated using Selenium at all. And finally, barcodes cannot be automated using Selenium. Neither CAPTCHAs nor barcodes can be supported or automated using Selenium, right? These are some of the limitations of Selenium testing. I hope you understood that, but let me go over them once again. So Selenium only supports web-based applications. Whatever applications you have, Selenium only supports web-based ones. It doesn't support applications that you've built for any other environment or anything like that. It just doesn't do that. Okay, second, the new features that are being introduced, they're a bit unreliable. In that case, sometimes we have doubts about whether they will work or not. we're not really that sure about them. So this is what we mean by the unreliability of the new features. Now, Selenium basically cannot perform testing on images. So if you want to perform any tests on images, Selenium just can't do that particular thing. The captures you have, these are not automated using Selenium, and barcodes are also not automated using Selenium, right? These are some of the limitations of Selenium tools.
Finally, we'll cover GUI development. You'll learn how to create interactive desktop applications using libraries like Tkinter. We'll guide you through building your own GUI applications from scratch, making your programs more user-friendly and visually appealing.
So let's start with graphical user interfaces. As I already mentioned, a graphical user interface allows users to interact with electronic devices through graphical representations. When I talk about graphical representation, I mean things like buttons and icons. Examples of GUIs include Microsoft Windows and Mac OS, and there are several other examples as well. So basically, what happens here is that you can communicate by interacting with the icons. So that's the basic idea behind a graphical user interface. Now let's look at the different types of graphical user interface libraries available in Python. There are several libraries used in Python for creating GUIs. We have Tkinter, Kivy, PyQt5, WXPython, and PyGUI. Now let's get an idea about Tkinter. Python's Tkinter is simply a standard GUI library. Basically, when Python is used together with Tkinter, it allows you to create graphical user interfaces quickly and easily. It also provides the TKGUI toolkit with a sophisticated object-oriented interface. So that's the basic idea behind Tkinter. All you need to know is that it's a Python GUI library, and then we'll see how to create a program using Tkinter. Now, if you want to create a simple GUI application with Python Tkinter, there are certain steps you need to follow. First, you have to import the Tkinter module, right? So you can simply write from Tkinter import star to import the Tkinter module. The second step is to create a main window. How do you create a main window? Basically, you create an object of Python Tkinter. Next, after creating the main window, you can add multiple widgets to it. And after adding the widgets, you can enter the main event loop to perform actions. So now there are two primary approaches that the user has to follow. Right. So first, as I already told you, you have to import the Tkinter module, and the way to do that is by writing from Tkinter import star. So after importing the Tkinter module, what do we have to do next? We have to create a main window. So how do you create a main window? I'll just simply write main window here, which is nothing but a variable. So to create the object, I'll just write TK here, make sure that the T is capitalized. And then in order to run the application, I'll just write main_window.mainLoop. So basically, main loop is nothing but an infinite loop, right? That'll run your application. And then it also waits for an event and processes it as soon as the window is open. So this is the basic idea of how to create a simple Python application with a GUI. Now let's look at a practical example. So what I'll do now is just write from Tinker import star here. So this is basically the Tinker module that I'm importing here, and then after that I'll create a main window. So let me write a variable called window here, and I'll create the object. When creating the object, make sure that T is capitalized. And now we'll just simply write window.mainLoop here. So we know that main loop is an infinite loop that will run the application, so if I execute it, you can see that we've created a simple GUI application, right? So this is the basic idea behind Python TK. Now that you've seen how to create a GUI app, let me change the title here. So if you run it now, on execution, you can see that it says TK here, right? And if I want to set the title to create learning instead of TK, I'll just write here, right at the window, title, and I'll write here, welcome to create learning. So now let me run this, and when you execute it, you can see that at the top, we're getting welcome to create learning as the title. After this, let me change the window size. So I'll just write here window.minSize. And I'll just write here, let's say width as 100 and height as 200. So if I run it now, you can see that this is the minimum size of this window. And if I click on this maximize button, you can see that this is the maximum size. So let me change the maximum size as well. To do that, I'll just write window. So I'll just write window.maxSize. And again, let me set the width to, let's say 300. And let's set the height to 800. So when you run it, you'll see this is the minimum size of the GUI and this is the maximum size, right? So that's the basic idea behind Python Tkinter. So after creating our first GUI, now it's time to learn about widgets. So what are widgets? Speaking generally about widgets, they're basically elements of a GUI. And in Tkinter, widgets are considered objects that represent buttons, frames, and so on. So basically, Tkinter offers many controls, and these controls are nothing but widgets, which we'll be using in GUI applications, right? As I already mentioned, they represent buttons, labels, and text boxes. So there are different types of widgets available in Tkinter, like label, button, entry, check button, canvas, frame, and many more. So that's the basic idea behind widgets. Now let's understand the geometric configuration of widgets. So we've already got the idea about widgets, but if you want to organize the widgets, you need geometry manager classes. Primarily, there are 3 types of geometry manager classes: pack, grid, and place. After adding a widget, I have to organize it, so I'll be using these 3 geometry manager classes. The first one is pack. When you use the pack function, it means you're placing a widget at the top. Next, when it comes to grid, it's used to organize the widgets in a table-like structure. So when I'm talking about a table-like structure, that means rows and columns. Next, we have place. It's used to organize the widget at specific positions. So here, I'll just write X and Y. So here, if you write, let's say, X equals 20 and Y equals 40, that means from left to right, you're placing a particular widget. And now coming to the Y, that means from top to bottom, you're placing any widget. So this is the basic idea about the geometric configuration of widgets. So now it's time to discuss the different types of widgets that are present in Python Tkinter. So the first widget we have is the label. So when you're talking about a label, basically it's used to represent a display box in which an image or text is added. So what's the syntax for a label? So I'll just write a simple label here, and in parentheses I'll put master, comma, options equals value. Coming to the master is nothing but the main window that you've created, and here we can provide several options as arguments. So in options we can write BG, command, font, image, width, and height. When I'm talking about BG, that means it's the background, right? And we also have FG as well. FG means foreground teller. So when you write FG equals blue, your text will be blue, right? So that's the basic idea behind the label widget. Now let's look at a practical example. So what I'll do right now is, once again, I'll just import the Tkinter module. So I'll just write here from Tkinter import asterisk. And then after that, I have to create my main window. So let me write the variable name window, and I'll create the object as TK. Now I'll just simply add a widget here. So I have to add a label widget, right? And we know that only after creating the main window can we add a widget. So let me write here, Elvin equals label. So this is my label widget, right? So in label here, I have to specify the master. What's my master? Master is nothing but the main window. So I'll just write window here. And then in options, I can provide several options. So let me write options here. Let's suppose I just write text here, and I'll put great learning. So this is the label, right? And also, if I want to organize the widget, then I have to use the geometry configuration, right? So let me use Elvin pack here first. And if you want to run the main application, then I have to write window.main loop here. So if I execute it now, on execution, you can see that great learning has been printed up the top of this. Window, right in the middle. So this is about the pack geometry class. Now, after pack, if I use, let's suppose, grid, so we know that grid contains rows and columns, right? So what I'll do here is just write row equals 0 and column equals, let's say, 1. Now, if I execute it, you can see that great learning has been printed here. So as of now, we've just started coding. So as you write more code, we can also change the row and column. And then we have one more geometry class, which is place, right? So I'll just write place here. Basically with place, if you want to organize the widget at a specific location, you can set X and Y. Let's say I write X equals 5 and Y equals 10. So basically, this is the position. When I write X equals 5, it means you're placing your widget from left to right. Similarly, when I write Y equals 10, it means you're placing your widget from top to bottom. Let me run this. So when you run it, you can see that date learning has been printed. If you want to place it at another position, you can just write X equals 50 and Y equals, let's say, 100. And if you run it, you'll see we get the output like this. So this is the basic idea behind the label widget. Now, let's say we've already created a label widget with the text create learning, right? Let me run this. So if you look, this is create learning right here. Now, if I want to add a background color along with the foreground color, how do I do that? I'll just go to the options here, and let's say I want the background color to be blue, so I'll just write blue here, and for the foreground color, I'll just write red here. Let me put this blue in double quotes. So now if I run it, you can see that when it's executed, this create learning, the foreground color will be red and the background color will be blue. Also, if you want to increase its width, so let's say your width is set to 40. Now, if I run it, so when you execute it, you can see that its width is increased. So this is the basic idea. So in the label widget, you can add more options like background, foreground, image, font, and many more. Yeah, so after learning about labels, now if I want to add an image to my GUI here, so what can I do? So let me run this again. So if you look here, let's say I want to add an image here. So what should I do? So first, what are we going to do? Let me just remove this. Let me write the variable name here as Ivan, and I'll just use photo image here. So you can also see that it's showing the photo image option, right? So inside this photo image, what I'll do here is just write file here. And if you look here, let me grab a file from the desktop. So if you see here, this is basically the file. And it's an image file, right? As you mentioned. So I'll just go to properties, and if you look, this is the location. So I'll just copy this, and the file name is Python, right? So the image file is named Python. So what I'll do here is simply put double quotes, and inside that, I've just copied and pasted the location, and the file name is Python, right? So I'll just write Python here, and it's a PNG file. Just write python.png here. Now, instead of the backslash, we just need to replace it with a /. So I'll just write it like this. So now after this, what I'll do is create a label. So I'll just write here Elvin equals label. And inside this label, I first have to put the master, right? So my master here will be the main window. So I'll just write window here, and then I'll write the option. So in the option, I'll just write image, and what's the image here? So image is equal to Ivan. So now if I run it, you can see that I'm getting nothing. Why? Because I have to use geometry classes here, right? So for that, I'll just write here, let's say elvin.back. So now you can see that in the output, we're getting the Tkinter image here. So this is the basic idea behind the label widget. So the next widget we're going to talk about is the button. So basically, a button is used to display a button in an application. And it also has a very simple syntax. We just have to type button, make sure the B is capitalized, and then instead of master, our main window will be there. And in the options, we can pass several arguments like BG, command, font, image, width, and height. So here, we can also use the command option. So when you're writing commands, basically when we create any function, we'll just assign that function's name to the command. We'll understand this better when we get to the coding part. Now let's look at the practical implementation of how to create a button. So to create a button, I just simply write here, let's suppose B1 is the variable name, I will write button here, and I'll write window here. So window is my main window, right? And after that, let me write text here. So if I'm writing here, text equals enter. And again, I have to write P1 here. I can use pack here. I can use place here. I can also use grid here. But let me write pack here. Now, if I execute it, you can see that this is my enter button. So let me set the color here again. So for the background, let's say I set it to green. And for the foreground color, I'll simply set it to yellow, which is a bright, noticeable color. Now, when you run it, you can see that this enter button has a yellow foreground color and a green background. So now we've seen how to create a button widget. Now let's see how to create an entry. So what is an entry? In an entry, let's say I've created a widget, which is a label widget, and its name is username, right? And I want to allow the user to enter something, right? That's why I'll create an entry where I can write a value in the form of a string as well as integer values too. So let's create the entry here. So I'll just write here an event variable, and for entry, I'll just write entry. And in entry, I'll just write window. And then let me set the width for you as well. So let's say the width of this entry is 20. So I'll just write here even pack, and now I'm running it. So you can see that when I run it, I get this entry, right? So here, I can enter a string value as well as an integer. So how can we use this entry? So let's say you're making a website, right? And for that particular website, if you want to access it, you need a username and password. Then we can use an entry there, and we also need to create a button for that. So let's say you want to change the font style here. What I'll do is simply write font equals, and let me put Calibri here. And let's say I want the font size to be 20. So I'll just write 20 here. And now if I run it, you can see that the size has increased. So now if I type Gore here, it's in Calibri, right? Now, what can I do here? If I write BD equals 5 here, so what does BD mean here? So BD is basically used to represent the size of the border. So when I write BD equals 5 here, you can see that the entry box looks like this, right? So that's the basic idea behind the entry. Now let's make a simple GUI here. So what we're going to do first is create a label, then an entry, and then we'll create a button. So for the label, I'll use employee name as the name, and for the entry, I'll just enter any string value. When I click the submit button, whatever string value I entered in the entry will be displayed. So basically, I'll be using two labels here. The first one will have the name employee name, and the other label will start off with no name. So whatever string value I enter in the entry, when I click submit, that value will be shown instead of nothing. That's the basic idea. So let me create a simple GUI now. I'll just write here again, from Tkinter import asterisk, which is a symbol, and now I'll just go ahead and create a mean application window. Let me give it a title as well. So once again, I'll write here window title, and I'll just write here, welcome to great learning. And let me just write here window minimum size. So I'll just set the width to, let's say 200. And then for the height, I'll just write 400. Ready? So for the maximum size, what I'll do here is set the width to 400. Let's just double the minimum size. And then for the height, I'll write 800 as well. And let me write here window.mainLoop, because if you want to run the application, you have to write this, right? So as you can see, this is my output, and this is the minimum size, and the maximum size is this one. And here on the title, I'm getting welcome to Create Learning. So these are the things we already know, right? So let me create a label view. For the label, I'll just write here L1 equals label, and L1 is my variable, right? So inside this label, let me write master. So master will be my main window. And now in the options, let me write text. So for the text, let me put here, let's say employee name. And then let me also set the foreground and background colors here too. So for the foreground color, let's use blue. And for the background color, let's say I'll use red. And since this is a label, basically it's a widget, I have to organize this widget. So for that, I'll just write here L1. I could also use pack here, but this time let me use place. With place, I can position my widget at any specific location. So let me set X equal to 0 here and Y equal to 10. And when you run it, you can see that this is my label, which is called employee name, right? Now, let me create an entry button here. So for the entry button, I'll just write here even equals entry, where even is my variable. And once again, I'll specify the window, and let me set the window, and let me set the font here. So I'll just write font, and in the font, I'll change the font style. Let me change the font style to Corbel, and let me set the size to 18. And let's use bead 2. So why are we using bead? As I already told you, bead is used to represent the size of the borders, right, of an entry. So if I'm writing here BD equals 5, let me write here even dot entry. So now, what will I do? Now I have to place this entry, right? So once again, I'll write here even. Let's use place here, and let me set X equal to 40 this time, and Y equal to 10. And if I run it now, you can see that I'm getting this output, right? So it's not coming out perfectly. So let me just adjust the size here. So instead of 40, let's suppose I write 80 here. And now if I run it, you can see that I'm getting employee name as the label here. And this is the entry field where I can type any name, okay? So let's create a button as well. So for the button, I'll just simply write here B1 equals button. And let me set the master here as window. And as an option, I'll give the text as, let's say, enter. Let me also set the colors for this button. So for the foreground, I'll use yellow. And for the background, let me use green here. So now we need to arrange this button widget as well. So for that, I'll just write b1.place here. And let me set X equal to, let's say, 100. and y equal to 40. I'm just using random values here. Now, if I run it, you can see that I'm getting it like this, right? So let me just rearrange it. If I set x equal to 120 here, okay, now it's coming in the middle, and let's set the y value to 60. Now it's coming out perfectly, right? Now, if I'm typing here, let's say Gorov, and I press enter, you can see that nothing happens, right? So what I'll do now is just create another label, and this label will go here, and I'll just write nothing in it. Now, after that, whatever string value I type here in this entry, if I press enter, then instead of nothing, the value should be whatever I entered. So for that, what I'll do is create another label. So I'll just write here L2 equals label, and I'll just put window here. And after this, I would just go ahead and set the text to nothing as planned. And let me set the foreground color to, let's say, black. And for the background, let's go ahead and set it to a nice warm shade of brown, just to give it a cozy feeling. And let me place this widget. So I think X will be 120 here. I'll take Y as, let's say, 90 or maybe 100. And now, if I run it, you can see that label is not defined because L needs to be capitalized here. Now it's good to go. So when I run it, you can see that I have another label that says nothing. Now I need to make it so that if I type Gorov here and click on this enter button, it should work, right? And instead of nothing, I want the value to be Gorov here. So for that, what I'll do here is create a variable. So now, after this, what I'll do is just create a string variable. So let me create a variable, v equals string variable. So when I'm writing string variable here, basically that means we're dealing with string values, right? So we're creating a string variable here. So now what I'll do is, inside this entry's options, I'll just write text variable, and it will be equal to v, because we're dealing with string values, right? Now, I want my button to work. So for that, I'll create a function. So whatever function you're creating, let's say the function name is add text. Then I can use the binding functions, and I'll write here in the button, command equals add text. Now, how do you use this add text? So I'll basically create a function. So I'll just write here, def add text. And now, after this, I'll just simply write, let's say my variable is v, right? So if I want to get any value, I'll just write v.get. So let me create another variable. X equals v.get. Right. And now after this, I'll just simply write u. So now what I'll do here is I just want to print this value. So I have to write print x. Now, as I told you, I created two labels. The first label was employee name, and the other label had nothing written on it. I told you that whatever value I put into the entry should be updated in the label that currently has nothing written on it, right? So I'll just write L2 here, and I'll use your config function, and inside this config, I'll just write text equals x. Now, what will your x value be here? So I've written here x equals v.get, right? And we don't add v equals string, so basically we're dealing with string values. So now what I'll do here is, I'll just run this, and let's say I type Gorov here, and if I click on this enter button, you can see that I'm getting Gorov here, right? And also, if you look at the output, I'm also getting Gorov in the output. Why? Because I've written print x here. So now let's make a few more changes. Here, the name has changed from nothing to Gorov, and let's change the color as well. So how can you change the color? So in this config function itself, I'll just write here background as, let's say, yellow, and then foreground as, let's say, blue. Now, if I execute it, so let me stop and rerun this, and this time, once again, if I type Gorov here and click on enter, you can see that the name has changed, and the background color is yellow, and the foreground is blue. So this is the basic idea behind the label widget, entry, and the button. Right, so this is a very simple GUI application. So the next widget we have is the check button. The check button is used to display a selection of choices as checkboxes. Let's take an example. Let's take an example of male and female. We can use them as check buttons. Now let's look at the syntax. So the syntax is simple. You just need to write check button, and inside the parentheses, your master will be the main window. And then there are several options that can be passed as arguments. We can have a title, background, as well as active background. So this is the basic idea behind the check button. Now let's look at the practical implementation. So now you can see that this is basic Tkinter programming. Now what I'll do here is just create a variable. Let's call it CV, and I'll just write check button here. And inside this, I'll just put window, and then I'll add text here as well. So as I was explaining, we can take the example of male and female. So let me just write male here, and then I'll just write CV. Let's use pack here, and now if I execute it, you can see that I'm getting male as a check button, right? So this is my check button. So the next widget we have is the frame. Basically, a frame serves as a container and is used to organize the widgets. Now, what is the syntax for a frame? It's simple again. You just have to write frame, then the master, and then the options. So here, as arguments, we can pass several options such as BG, BD, cursor, width, and height. Right. Now let's look at the practical implementation of this frame. So now, once again, I'm back in PyCharm. I just simply write the f1 variable there. Let me create a frame, and inside this, I didn't pass any master or options. So I'll just write f1.pack here, f2 equals frame. And I'll just write f2.pack here. Now, if you run this, nothing will happen, right? So what I'll do now is create an element here. Let's take a label, I'll create it here, and inside this, I'll pass f1 as the master, and then let me set the text here. So I'll just write here, text equals great learning. And if I write low1.pack here now, so let me run this. When you execute it, you can see that I'm getting great learning. Now I'll just create another label. Let's say L2 equals label. So I'll just write F2 here again, and then let me write text equals bottom, and I'll just simply write L2 pack. So now if I run this, you can see that I'm getting bottom. So here you can see that basically I have two frames, right? Great learning and bottom, but I want bottom to be displayed at the bottom. So for that, what I'll do here, you can see that I've written F2 here, pack, right? So I'll just write here side equals, and I'll just write bottom, and bottom will be in all caps. So now if I run the code, you can see that great learning is at the top of the window, whereas bottom is at the bottom of the window, right? So the next widget we have is the list box. A list box is used to provide the user with a list of options. So basically, in simple terms, you can say that a list box contains a list of options, and as we know, a list can contain different types of data values. So a list box will contain a different list of options. Next, we have the syntax. So what's the syntax for a list box? Once again, we'll just write list box, and inside add master and the options that we can pass as arguments. So what are the options that we can pass as arguments? It's like BG. BG stands for background. BD is used to represent the size of the border. Then we can also use font as an option, as well as image, width, and height. So now, let's look at the practical implementation of listbox. In the practical example of the listbox, we'll see how to remove an element from the listbox, and also how to insert any element, or you could say items, into the listbox. So now, what I'll do here is just write LV equals, let me create a listbox. So this is my listbox. And I'll just write window here, and let me set the width. So if I set the width to 20, let me just write LV pack here. So here, else should be capitalized. So this is my list box, and if I run it, you can see that I get an empty list box. Now it's time to insert the options into the list box. So for that, I'll just create a list. So let me give you the list as Elvin, and let's insert several values. So how do you add multiple values to a list box? Let me write the name Mew here. So let me write Tony here. I'll write Elvin here. Look at a few more names. Let me write Kurtika here, and let's take one more name, Ipsa. So these are the 4 values, right? And I want to insert them into my list box. So for that, what would I use? We can use a loop, right? A for loop. So I'll just write here, for I in my list, the name is Elvin, right? So what's the name of my list box? So the list box has a variable name, which is LB. So I'll just write here LB dot, and then I'll just write insert. And let me put end here. And I'll just write I here. Now, if I execute it, so on execution, you can see that I'm getting Tony, Advent, Kurtika, Ipsa. So what can I do now if I want to remove, let's say, Ipsa from here? So let me create a button. We have to create the button, right? So for the button, I'll just write here B1 equals button. And I'll just write here window and text equals. Let's say if I want to remove Ipsa, so I'll just write here remove. And let me set the color as well. So I'll just write here, let's set the background color to red. Now for the button as well, I have to write here B1.pack. Now, if I execute it, you can see that this is the remove button. But if I just click on this IPSA and then click on this remove button, it's not removing. So we know that it won't remove it unless we're using a command, right? So what is a command? A command is nothing but a binding function. So in the button, I'll just write here command, and let's use that. I'll write edtech here. So here you can see that I've assigned edtech to the command. So what does that mean? It means that I've created a function named edtech, right? So what I'll do here, okay, let me just create a function here called edtech. And inside this function, what I'll do is simply write LB. So what is my LB? LB is just a list box variable. And if I want to remove an element, then I'll use the delete function here. And inside this delete, I'll just write anchor. So what do you mean by anchor? So that means if you want to select a single item and remove them one by one, then we can use anchor here. So if I run it now, let's say I want to remove, for example, Girtika, and I click on this remove button, you can see that it's been removed from the list box. Similarly, we can do the same for Ipsr, right? So this is the basic idea behind the list box. Now that we've covered the label widget, button widget, and several others, it's time to talk about some additional widgets. There are various other widgets available in Python Tkinter, including menu button, menu, message, radio button, scale, scroll bar, text, top level, spin box, and paned window. We'll look at some of these widgets in the practical exam. So let's get started. Now let's talk about the radio button widget first. To create a radio button, let me write here RB1, and the R needs to be capitalized. So this is my radio button, and for the master, I'll just put window here. After that, I'll set the text to yes, and then I'll write rb1.pack. So when you run it, you can see that this is the radio button that's been created, yes, right? Let me create one more radio button. So I'll just write here rb2 equals radio button. And again, for the master, I'll put window here and set the text to no. And of course, we need to place the widget, right? We have to organize the widget. So for that, again, I have to write rb2.pack. So now you can see that I have two radio buttons, yes and no, but you can see that both of them are selected, right? So for that, what I'll do here is just write value here is equal to, let's say for yes, I'm giving the value 1, and for no, the value is 0. Now, if I run it, you can see that only one can be selected at a time. So now, if you look, these are the radio buttons, right? But let me create a button so that whenever I click on yes, I want the value to be printed in my output. So for that, I'll create a button. Let me create a button. I'll just write here b1 equals button, and then I'll just put window here. And for the button, I'll set the text to enter. And again, let me just write b1.pack. Now, if I run it, you can see that I got the button, but if I click on this enter button, you can see that nothing is printed in my output. So what can I do here? Let me create a variable. So I'll just write, let's say, v equals infar. So that means basically we're going to deal with integer values. And after this, I'll just write variable, and we know that our variable is v. So I'll just simply write variable equals v. And inside the button, when I'm writing command, that means we're using a binding function. So for command, once again, I'll give the name here as edtech, and I'll create the function named edtech, right? We know that whatever function we're creating, so let's suppose we're creating an edtech function, then in the command, we'll assign edtech here. So let me just write def edtech, and inside this, let me just write a simple print, and since v is my variable, I'll just write v.get. So we know that for yes, we've assigned the value 1, and for no, the value is 0. So now, if I execute it, when I click on yes, and then click this enter button, the button will work. So when I run it, you can see that I'm getting the value for yes as 1, right? We've already assigned the value 1 to yes. Similarly, if I click on no and then click this enter button, it'll give you the value 0. So that's the basic idea behind a radio button. So the next widget we're going to talk about is the message box. Now, talking about the message box, it's used to display a message box in Python applications, right? So what can I do here? Let's create a message box. To create a message box, you have to import message box. So I'll just write here from Tkinter import. I'll just write here message box. Now my message box has been imported. Now, what I'll do here is, first, let me create an entry. I'll just write here event equals entry, and in this entry, I'll just write window. And let me also set the font here. So for the font, I'll just change the font style. The font style is set as Calibri, and then the font size is 18, right? And let me set the width as well. So I'll just write here width equals 20. And after this, let me just organize this widget. So I will be using event hack. And now if I execute, you can see that this is my entry box, right? Now what I'll do here is let me create a button as well. So I'll just write here v1 equals button. And inside this button, I'll just write window, simple. And then in this button, I'll just write text equals, let's say enter, right? And I'll just write here v1.pack. Okay, so now what I want to display here is a message box. So let's say even if I'm not writing anything and I press enter, then it should show some message box, or you could say a warning message, right? In the form of a message box. And let's say if I write any string value, then it should show that, yeah, it's successful, and it should print that particular value. So for that, what I'll do here is I'll just create an int variable. So I'll just write here simply v equals int verb, or instead of int verb, I'll just create a string verb, right? Let me write string verb here. So I'll just write string verb here, and then what I need to write is just a text variable here, equals v, right? Now, we know that we have to write a command here, which is basically a binding function. So for the command here, once again, I'll create a function. I have to write the function name here and assign it to the command. So what I'll do now is just create a function here, that at tech. And let me add the condition here. So let's suppose if I'm writing here, if vget, so we know that vget will give me the value. If I write here equals equals, and it's empty, so I'll just write message box here. Now I'll be using message box here. Python provides several functions for this, so I'll just write show warning. So I'll be using show warning here, and as you can see, we have the title and the message. So for the title, I'll just write cosin, and after that, I'll write it's empty. It's simple, right? When you haven't typed anything in the entry and you click the enter button or the submit button, it should show something, right? Like, please enter something, it's empty. So I've just written the instruction, it's empty. Next, I'll add the else condition, else. I'm working with a message box. Now, I can actually use another very useful function that is provided by Python. I'll just go ahead and write show info right here. And for the title of the message box, I'll put successful as the label. This way, the user will clearly see that the operation was completed successfully. And then, let's say I want to display v.get here. So I'll just write v.get. Whatever the value is, I'll get it here, right? So now, if I run it, now when I execute, this is my entry, right? And if I don't type anything in the entry and click this enter button, you can see that I'm getting causal as my title and it's showing it's empty, right? So this is the message box. Similarly, if I type, let's say, Gaurav view, now you can see that I've entered Gaurav here in Calibri 18, right? So this is the Calibri font style. And if I click on this enter button, it's showing successful Gaurav, right? So that's the basic idea behind the message box.
Python is a widely used advanced scripting language that is interpreted, interactive, and object-oriented. Python is intended to be a very understandable language. It uses English-like words in its code. Compared to other scripting languages, it also features strict syntactic structures. In the fields of web development, game development, data analytics, and machine learning, Python is a widely used programming language. Nowadays, automation plays a vital role in the technology sector. This video on a Python automation project will teach you about the most common and fascinating module you can build for a voice command recognition system using Python. Sounds interesting, right? Why wait? Let's jump right into the video and learn more about it.
So the very first library we're going to use here is the TTX3 library, okay? So this is one of the libraries. What is it used for? It's used for converting text to speech. Whatever you write will be converted into speech. Super fun, right? So yes, in the Python programming language, we have this library called Pytest-X3, which is used for converting text to speech. So this is the very first library that we'll be using up here in our project. Moving on to the next one, we have speech recognition. Now, what is this particular library used for? So this library is used for converting, let's say I'm saying something, okay? I want to turn that into text. So speech recognition is one of the libraries that lets you do that. It means that whatever words are spoken, the speech recognition library converts them into text, okay? Next, we have Automate Wikipedia. Now, this particular Automate and Disco Wikipedia library helps you work with Wikipedia, okay? Now, you don't need to go to Google, type in Wikipedia, and then search for the thing you want. That's not something you'll have to do anymore after completing this project. You'll simply say, okay, search Python for me, and it will automatically pull out the relevant information, the required text from Wikipedia, and let you know, like, see, this is the text, and this is what Python is according to Wikipedia, right? So that's how the Automate Wikipedia library works. Then we have web browsers. So today, what we'll be doing is also automating web browsers with the help of the Python programming language. Let's say I say open Google, so it will automatically open Google for me. Yes, that's actually possible, right? With the help of the Python programming language, it's completely possible. So web browser is a library that we'll be using to automate web browsers. Okay, then we have the SMTPlib library. This particular library is used for working with emails, sending emails, retrieving emails. So for all these kinds of tasks, the SMTP library is used. So in that case, what happens is, let's say you want to send an email to a particular person. After that, it would ask you what message should be sent, and you let that person know, like, okay, this email has been sent through the Python programming language, and the email you dictated would be sent to the person whose name you provided. So it works with the SMTP-lib module. Then OS. OS stands for operating system. It's used to work with or interact with the operating system. The next one we're going to use is datetime. As I mentioned earlier, we'll be checking the current date and time with the help of this project. In a similar way, it's also used for working with dates and times. Great. So I hope it's very clear, first of all, what libraries we're going to use, what the tasks of these libraries are, and what they actually do. Great. So I hope it's very clear, first of all, what libraries we're going to use, what the tasks of these libraries are, and what they actually do, right? Now, let's not waste too much time here, and let's get started with writing this task. Let me first give you a very clear idea about the project we're going to work on. So up until now, we just wrote some lines of code and were able to automate different things, right? Now, what if you could do this just by speaking? Let's say you say, open YouTube for me. And guess what? YouTube opens for you. You say, search Python on Wikipedia. And guess what? Wikipedia searches for Python for you and reads out loud what's written about Python on Wikipedia. Yeah, that's totally possible in the Python programming language too. So today we're going to make a project like that. Whatever command you give to that project, it will do it for you. Let's say I say, tell me the current time. So it's going to say whatever the current time is right now, it's going to speak out the current time. So yeah, just listening to this sounds like a lot of fun. So when are we going to start? It will be really, really exciting to go ahead and put all these things and projects into action. All right, I won't waste too much time here just talking about it. Let's get started. Let's gather the things we need for this particular project. All right, so before we move forward with anything or start writing code, let me first tell you which libraries we're going to use for this project. Okay? Now, this is the kind of project where you'll say something and it will be converted into text. Okay? I have that. Or like the microphone and all those things will be automatically accessed just through the project we're about to write, okay? Now, okay, like before we start, I really want to suggest that for the next little while, listen to me very carefully, pay attention to everything I say here, and please follow all these steps closely to make this project a success, all right? So here, I'm going to write out, first, I'll be importing the very first library, which is Pytest. Okay, so if you haven't installed this library, go to the terminal. See, I'm using PyCharm. Okay, so in PyCharm, I already have the terminal here in this IDE. Now, other than PyCharm, if you're using any other IDE, make sure you open up the command prompt and type the same command I'm writing here. The command is pip install, and then type pytesseract, okay? And hit enter. For me, this library is already installed, so it will show me that it's successfully installed. But if you haven't done that yet, it will take some time and then show you that your library has been installed. Okay, so make sure that before starting this project, you install the relevant libraries we're going to use today. So yeah, this one was already done for me. I would open up a new terminal here, and now the second library I need to install is type pip install, and the second one is speech recognition. Now please make sure and look here on the screen at how I'm writing speech recognition. It should be lowercase for speech, but uppercase R for recognition, okay? That's RECOGNITION. Please make sure you're spelling it correctly, okay? So for me, again, it's already satisfied. So it showed me that the respective library is downloaded. For you, you need to install it if you haven't done that yet. Now, the third and last library you need to install is Wikipedia as well. Type pip install Wikipedia and hit enter. For me, Wikipedia is also installed, so it showed me requirement already satisfied and all that, but if you haven't done that yet, it will take some time depending on your internet speed, and it will install the Wikipedia library for you as well. Okay, great. Now, nothing else needs to be installed. So I imported the Pytesseract library, then I'm going to write import. Okay, 1 second. It's import. Next, we'll be writing import speech recognition as SR. Now, speech recognition is a long name, no doubt about that, so whenever I need to use speech recognition, I'll just write SR, and that will work for me, okay? It won't give me any error. So what we actually do in Python is whenever you have libraries with long names, we give those libraries a short form, okay? And wherever you want to use that library, you can simply use the short form and it will directly refer to your library. So that's one thing we do. Next, we're going to import the next thing, which is datetime. So import datetime. Next, we're going to write import, and here we'll be writing or to import, to meet, and this is for wiki. Okay, so sorry. The last import is Wikipedia. Okay, the Wikipedia library is also imported here. Here goes import, and here is my web browser. Import web browser, okay. My next library, then I have import, and here goes OS, my operating system. And at last, here goes my import smtplib, and at last, my last type we'll be importing is import datetime. Okay, so yes, okay, datetime, I had already written that out. Fine, let me remove this from here 1 second. Great. So these are the 7 libraries that we'll be using throughout this particular project: Pytesseract, speech recognition, datetime, Wikipedia, web browser, OS, and SMTP. Okay, great. Now, the very first task that we are going to do is set up the engine and initialize the Pytesseract library. Okay, so first of all, what we'll be doing is we'll be just doing some things so that whatever voice and audio we already have on our devices, we are going to extract that audio and those voices. Fine, great. So here I'm going to write engine equals, and here goes py3, okay, dot, and as I mentioned, I'm going to initialize that. In the brackets, I'm going to write sappy5. Now, what is sappy5 actually? It's a kind of driver, you could say, or a kind of voice, you could say. Okay, so please make sure you write the correct spelling. For now, you can understand that it's a kind of driver that helps you get the voices, which helps you in the Py3 library. That is, for converting text to speech, it helps you in that case. Okay, next we have the variable voices equals. Now, next you have engine. Okay, engine, my function goes get property, okay? Get property is my function here. Now, in the brackets, I'm going to write voices, okay? Get property, and here goes my voices. And shift to the third line, it goes engine. Now I'm setting up, well, what I did, I got the property. Get the property means that I try to get the property, which is voices. Now, from that voices property, what I'm doing is I'll be selecting one voice. Now, you'll actually just see what I'm doing. First, for this, write out engine.setProperty voices1.id. Now listen to me. This 1, why did I write 1 here? Because 1 is for the voice of a female. If you want a male voice, in that case, you could mention 0 instead of 1, okay? 0 is for the male, and for the voice, when I have written the bracket 1, so 1 refers to the female voice, okay? You can set that accordingly. Fine, great. So my voices are being set up for what sort of voice I want, and all of the things are completely fine here. Next, coming down, what I would do is I would be making up a new function now. Okay, what this function will do is allow the things we write to be spoken out loud. So here, my function goes, and the function name is speak. In the brackets, I'm going to pass audio as a parameter. Okay, so here goes engine, say, and in the brackets, audio. Okay, just a single A goes here. Fine. Now, what we're doing is, engine is my library, which I've already initialized with this 3. That is, to convert text to speech. Okay, so now, where is my written text that I'm converting into speech? So the written text that I'm converting into speech, for that, I would make a separate function, and that function will only handle that. Okay, up to now, we haven't made any specific function for converting text to speech. So far, we've just initialized the library, nothing more than that. Great. Coming down here, I would set up one thing here, engine.run and wait function, and it goes in brackets. So what is the run and wait function for? Let's say my program has been run, okay? After that, whatever text I write will be converted into speech. After that, from the speech recognition library, whatever I speak will be converted into text. So for handling the process of all these things, we've set up this function, which is run and wait. Okay, so as soon as we run this program, it will run and it will simply wait, first of all, to say whatever needs to be converted from text to speech. After that, it will listen to my words, whatever I'm saying, and then it will convert them to text. Then it will perform the relevant function, whatever has been ordered. Fine. I hope I'm very clear about the idea of the project and what I've written, what these things are actually about. Right now, let's move forward with the next things, and that will be the next function I'll make, and that is def, and here goes the next function, wish me. What's that? What is the function def wish me? Now, let's see. You've written the respective thing. Now, here we'll be using the datetime module. Okay, now why am I making this function, and what's the need to add this function into the program? So that whatever modules I've covered in Python for automation, you get a very clear idea of how to use them in a project. See, listen to me. Using modules for simply writing 2 lines of code, or using a module within a project, these two are very different things, right? So, first of all, I told you how to use that particular module while writing 3 or 4 lines of code. Now, I'll explain to you how that module will be used whenever you want to insert it into some sort of project. Okay, that's the reason I'm making this function. So what I'm going to do is make a variable. Let's say that's R. And here, I'm going to get the current date, current time. Okay, so it will go like this. Datetime.datetime.now. Right, it'll help me get the current time right now. Whatever time we have right now, it will help me get that. .r. Okay, so whatever time I have, it will show me in the format of, like, let me get the time from here. Now, I haven't set any format here for the time, like what format it should give me the time in, because this isn't the function where I'll be asking for the time. See, what I'm actually doing here is making it so that it will extract whatever the current time is, and based on that time, it will decide whether it's morning, afternoon, or evening. Okay, we will be setting it up in a way that once we've gathered the current time, okay, whatever the time is right now, let's say for you it's 7 a.m. in the morning, right? So 7 a.m. is actually morning, right? So what will it do? It will extract that it's 7 a.m. So it will automatically understand that it has to greet good morning. So in that case, it's going to say good morning, right? Now, let's see. Here, there could be some confusion. It doesn't actually understand AM or PM, okay? It doesn't understand AM or PM because this is just the time. So it takes the time in the form of 727. Okay, it takes it in the form of 7:30 or 8:30 or 9:30 or 9:10, whatever time you have. So what it actually does is, let's say in the afternoon, at noon, at 12 o'clock. Okay, it will understand that, okay, 12 is written. So that is noon. Now, after that, what? When I write one again, it will automatically understand that it's in the morning. So in that case, like we used to write, okay, let me add a comment here. So as we actually used, let's say 12 is my noon, right? So for 12, it'll simply be noon or afternoon, whatever you call it. After 12, when we write 1, what will my program actually understand? It will think it's in the morning, but what I'm actually referring to is 1 p.m. Right, so in that case, what I need to do is mention this in the form as 13 o'clock, okay? 13. Now it will automatically take that as afternoon. Okay, let's say you want it for 18 o'clock. Okay, let's say you want it for 18. 18:00. Now this will understand it as evening. But instead of this, if you write out 6 p.m., if instead of this, you're going to write out 6 p.m., it won't understand that, okay? So I hope I'm very clear about how I'm going to set up the timings accordingly. Fine, great. Let's get down to setting up those respective things. So here, I'm going to mention that if R, okay, if R is greater than or equal to 0, okay, and R is less than or equal to 12, okay, so in that case, you could simply say, good morning. Good morning, my dear friend, okay? Good morning, my dear friend. This is what you could say. It means that from the morning until 12 o'clock, okay, if the time is between that, so in that respective case, it has to read, good morning, my dear friend. Next goes my else if condition. Else if. Now, if R is greater than or equal to 12, and R is less than or equal to 18. Okay, so in that case, what do you need to say? You truly need to say here, a very good afternoon to you. A truly good afternoon, my dearest friend. How are you doing today? Now, okay, one more thing to mention here is that whenever we wanted to print anything, whenever we wanted to print something, what do? We use the print statement, right? Now, whenever we want anything to be spoken, okay, anything should be spoken. So in that particular case, we use the speak function instead of the print statement, okay? These are small details that need to be mentioned here and actually need to be taken care of. And here comes my else condition. I'll speak. Good evening. Let's just try to behave ourselves for a brief second. A very good evening to you, my dearest friend. Good evening, my dear friend. Okay, so I hope that's very clear as well. Next. Okay, these conditions have been set up. Whatever conditions I wanted, I've simply written them here. Right. Now, what I'll do is write a mandatory speaking condition. This means that now I'm going to write out a condition. A condition means I'm going to write out some necessary statements that need to be spoken. Whether it says, good morning, my dear friend, then this statement would also run. Or if it says, good afternoon, my dear friend, then this statement would also run. Or it says, good evening, my dear friend. Then the respective statement would also run. That's why I'm writing that outside of any condition, because this is mandatory, a statement that has to be spoken in any of the three cases. So for that, I'm writing, let me know how can I help? How can I help you? Okay, let me know how can I help you? Let's say we wrote out, what are you looking for? Okay, let's say this is the statement you want to put out. Let me know how I can help you. What are you looking for? Let me just add a simple comma here. Alright. So this is the statement that I wanted to be necessarily and mandatorily included after putting up any of the three conditions I mentioned. Right? So this wish me function is now complete. But how does it know whether it's morning, afternoon, or evening? Well, from this date and date time now, it will extract the current time, and based on that, it will determine what to say and run accordingly. Okay, so that's the clear idea. Wonderful. Now let's move on and add the second command here, the second function that we're going to use in the appropriate place. All right, my second function will be called div, and here we'll give it the take command. Okay, div take command. What will it do? First, it will greet me, good morning, evening, or afternoon, whatever is appropriate. After that, it will say, let me know how I can help you. What are you looking for? Okay, then what it's going to do is first, it will show me a message that says listening. Let's say I say, open Google. First, it will display that it's listening. I say Google, so after whatever I've spoken, it will show recognizing the voice. That means, is your voice clear and loud enough that the mic on your laptop can pick it up? Whatever you're saying, is it loud and clear enough for the command to be understood? Let's say it is. In that case, it will process it and automate the respective action you've given. But if your voice isn't clear and loud, then it will show you a message saying, I am not able to understand what you are saying. Please say that again. So this is the kind of thing we're going to write inside the take command function. All right, let's not waste too much time. Let's get started here. So here we have our variable, and we're going to use speech recognition. The spoken words will be converted to text. Whatever I have spoken, it will show me that as well. That is, it will tell me, I'm able to extract this much from your speech, whatever you said. Okay, let's say I said, open Great Learning Academy. In that case, let's say it's only able to extract open Great Learning and can't understand academy. So it will simply show me that you said open Great Learning. It will actually write that out in the output, showing that you said open Great Learning. Okay, so in that case, we are using the speech recognition library. It means whatever I am saying, even want that thing to be displayed in the output box, fine. So sr dot, and here goes my function, which is reco, okay? That is, R would be capital because nicer, okay? It will help me to do so. Getting down here, now we are giving access to your microphone with sr.microphone, okay? With sr.microphone as source, with sr.microphone as. So let's get down. First of all, what to print first? For printing that, listening, okay? Listening to you, Shampy, okay? You could put your name or whatever you wish out, okay? Listening to you, Shampy. Great. Next, we have the next thing, which is r.pause threshold equals 1. So what is this pause on the screen? Pause threshold is used for, so as soon as it has printed the statements, listening to you, Shambhavi, it will wait for some time, it will wait for a minute, and then it will show me recognizing your voice if you had said something. So in that case, it will recognize you, or if you haven't said anything, it will print recognizing your voice, and after that, it will show you say that again, please. Okay, this is how it's going to be. So we set some pause time here, and then here goes. Audio equals r.listen, and in the brackets, in the brackets, I'm going to use the source. What's that source? Source for which I have used sr.microphone. Okay, great. So this is what you've done. Now inside this, I'm going to use my try and accept block. So here goes my try block. 1 second, let me go back. And let me now just go down a bit. Great. Now, what am I going to print out here? That recognizing your voice. Okay, let's see. This is the statement it will print after that in the try statement. Then you are going to write here query equals, here goes r dot, here goes my function, which is recognize, and let's go to Google now. This SR, 1 second, this is the speech recognition library. I wrote that it is used to convert spoken words into text, and it works on APIs. It works according to the APIs. So right here, it will be working with the Google API. So in that case, I am using recognize_Google. Here goes my variable, which is audio separated by a comma, and now we have to set up the language as well. So language I am setting up as English, and that's so of Indian. EN and -IN. Okay, English India. Fine. This is the language which I'm setting up in which I want to communicate, and even I will be speaking up in this only sort of language. Whatever language you will be speaking, mention that language here. Fine. Next, coming down here, now I want an auto print statement to be printed. and it'll show me what I actually spoke. So now I'll be writing some kind of F string at the start, and here I'll write, let's say, my dear friend. My dear friend, you said, my dear friend, you said, and here I'll be putting it in the bracket. So what was the variable in which I am recognizing the voice? That's the query, right? So I'm writing the query variable here because that's the variable that will store whatever I have spoken. That's why I'm using query here. And here goes a backslash, and backslash means that with this program I'm writing, it will run in an infinite loop. Let's say I said open Google, so it opened Google for me. After that, it won't quit the program. It will again start with please let me know, and it will start with the statement listening to your Shambhavi, or whatever you said. Now let's say the second time you said open Great Learning YouTube channel, so it will open that for you. Again, it will say listening to your Shambhavi. So it's not the case that you say one statement and it stops running in that scenario. Okay, let's say you wanted to open multiple things at the same time. So yes, you could do that specific thing with this project, right? So I've already mentioned the query. Next, we'll be writing the except statement. So here goes my except exception as E, okay? Except exception as E. Moving on, I'll be printing a statement. Print Shambhavi. Okay, yeah, I'll mention it now. Here, Shambhavi, please. Okay, let's not write it like this. Let's write Shambhavi, say that again, please, okay? P-L-E-S-E, Shambhavi, say that again, please. And I'll add some dots here, okay? Next, what I'll be returning at the end is none, meaning nothing. Okay, and 1 second, tab, and here goes my return query. Return query. Fine, so great, hope I'm clear with this. Returning query, here goes the respective thing. Now this is all sorted. This particular thing is done. Now what I'm going to do is make a function, and that function will help me access the email. So here goes def, and my function name is send_email. In the brackets, I have two parameters, to and content. To means who you want to send it to, and content means what message you want to send, what email you want to send out. Okay, now here goes my library. That server is equal to, I'll be giving access to the SMTP. Here goes SMTP, P would be capital, in the brackets, mention smtp.gmail.com. Okay, that's gmail.com. Okay, comma, and here goes 587. It's the server. Okay, 587 smtp.gmail.com. Okay, this is how you need to set up the thing. Moving on, you'll be writing next as server.start. Okay, that is start TLS. It means that it will help you. It will start up the server for you, which is the SMTP server, and only through this will you be able to send emails from here. Fine. Now here goes server.login. Now, what's your email and email ID from which you want to send the email? Now, please make sure you listen to my words very carefully, because here, if even a little thing is wrong, then it won't send the emails for you, okay? First of all, inside the login function, you need to write the email from which you will be sending. Okay? So I have some sort of email, and I would just mention that quickly right here. Fine. Here goes here goes gmail.com, and my email has been mentioned, from which I want to send. After that, put a comma, put the inverted comma, double or single quoted comma, and right here, mention now the password of your email from which you will be sending the email. So I'll be simply mentioning the password for my email from which I want to send the email. Make sure that you are doing things correctly, otherwise it won't be able to access things for you, right? Get down here now. Next, whole server dot. Here goes the send mail function. In the send mail, first of all, write the email from which you are sending. That means your own email, the one you wrote above. Put the same email, okay? So I'm putting in the same email that I mentioned above. So here it goes, separated by a comma. Now, what email now? Okay, next thing, you need to put in the to field, and then you put in the content. Fine. So yes, these are the email and password, as I mentioned to you here, that you want to use to send. And here goes the server.close and put the bracket. Right, Sue? This is the function that's created here for sending emails, okay? Now I'll go down and start something new from here. Initialize the main function of the Python programming language. Okay, now inside this main function, we'll be writing everything for the auto meeting. Okay, so first of all, I just want this wish me function to run. I simply want this wish me function to run, which will help greet me according to the time, whether it's morning, evening, or afternoon, whatever. Okay, moving on, I'll set up an infinite loop. As I told you, we'll be setting up one of those infinite loops. So here goes my while. Get down here, and here, once again, query is equal to, it will be take command dot lower. Okay, so that means whatever text is being said, whatever you're saying, all of it will be converted to lowercase. Now, if a person says, if I say, let's say open Wikipedia. If I say that in the query, it means that when it asks me, now let me know what you want to open. So in that case, if I say open Wikipedia, then what command should be executed in that case? First of all, it should speak. That searching is S-E-A-R-C-H-ing. That's searching Wikipedia. First of all, it will be W-I-K-I-P-E-D-I-A. Okay, it should say searching Wikipedia next. Okay, here goes that query. Okay, query equals, here goes query.replace. Okay, query.replace now. Okay, that's Q-U-E-R. Now here, set up the variable, which is Wikipedia, comma, and here goes double quotation marks, right? So whatever term you say, like searching Wikipedia, if I say open Wikipedia, it will say searching Wikipedia. Okay, so after saying open Wikipedia, in that case, whatever term you want to search for, you can put that in. Okay, here goes the results. R-E-S-U-L-T-S, results variable. Now, what I'm going to do is use that Wikipedia library we used above, dot, and here goes my summary function. In the brackets, I'll mention our first word, query, and how many sentences you want for that respective topic to be spoken. Let's say I want the first 2 sentences. Okay, let's have just the first 2 sentences, not more than that. Okay, then it will speak it in a form like, according to Wikipedia, and then it will start speaking whatever topic you searched for. Okay, and I want to print the results as well. That means whatever it's going to say and whatever 2 sentences it has extracted from Wikipedia, I want to print them as output as well. So it will be printed. And after printing, I want those things to be spoken as well. I use speak in the results. Fine, so I hope I'm clear about this part, about what needs to be done here for Wikipedia. Next, let's see. If you want to open Notepad, I would write here, if open, and here goes. If open, Notepad in the query. If you see that it says open Notepad, then what should happen? So now I'm going to provide a path here. Now go to the search, type in the search option, and search for Notepad. Okay, see, it has actually opened up for you. Now go on and click here on Open File Location. Okay, you clicked on Open File Location. Right now, just let that open up. After that, I'll let you know what to do next. Fine, Notepad has been opened up for you. Now, right-click here. Click on Notepad and then right-click. Fine, after that, let's see. Just give it some time to open. Now here, go to Properties. Okay, after this, go to Properties here. I clicked on Properties. Now, just do one simple thing. From here, copy this system32 notepad.exe, okay? Copy that from there. Fine, and that's actually done. The system32 part is done. Fine, and now I would close it out. Now, from here, okay, 1 second. I just need to do that. Right away, so let me go back. Okay, it's in the Start menu, then it's Programs, I guess. What was that? Okay, let me just do it once again. I would open up I will search for Notepad. You click on Open File Location. Yes, drop down here and see. Okay, from here, just click on Notepad, just click on this, single click. Now just drop down here. Okay, so see, it's telling you that it is in the C, it is in Windows C. Fine. So now just check that in which Windows C or D you have that. And now here, put in the C, colon, double slash. For me, it's in the C. Okay, it would be like that. Sorry, now it was in the Windows. INDOWS, right? After that, we searched that, right? It was system32 and then notepad.exe, right? So I'm going to write here, system32, and then it was double slash, and it was okay, it was notepad.exe. This was the complete path, right, that I showed you. It was system32 / notepad.exe, and from that, I saw that it was in the C drive. Fine. So for you, as we just searched that quickly, mention the respective path. Let's say this is for Notepad. Now, let's see if I want to automate Paint. So if I say open Paint, okay, open Paint and query, first say that out, then what to do. Okay, I'm so sorry, I just missed one statement here. That is, I need to write now OS. OS is now the library which will be used, that is operating system. It would be, now the function would be start file, okay? Operating system. From the operating system, that is Windows, start file. Which file to start? The file to be started is the one I have written in the InPath variable. So it means, statically, this notepad will open up for me, right? Let's get down here. Right there as InPath equals, now we are having that for Paint, right? So for me, Paint would be as well in the same, is as well at the same position. So I would simply copy this from here, Control-C goes, and here goes Control-V. Okay, and instead of Notepad, I'm going to write out MS Paint, P-A-I-N-T. Fine. For you as well, you could search that accordingly, and you could just put that up as well. Fine. You could just search that. Again, let me tell you, go on to Paint, hit End. Okay, sorry, I have opened up Paint, but that's not needed. Let me close this out. Paint, go on to Paint, open up the file location. See, just beside, just below Notepad, we had Paint as well. So you could put that as well here. No issues in that respective case, right? Great, let's close that out here. So Paint is done as well now. These were the two EXE, I would say functions or apps, whatever you call them, that we had on our device. On your laptop or computer, whatever you are using, you had those stored. Now, let's say we want to access anything online. Oh, online means I want to access anything in the web browser. Let's say I want to open up YouTube now. So what is the name? Okay, here goes my if condition. Okay, right here again. Okay, here I just need to do one thing, a single thing. I need to write os dot. And here, what is my function name that has to be put up? It is start file. And that's the end heart, right? Great, let's get down. Then again goes up my elif condition. Now we have opened YouTube. Open YouTube? What's open YouTube? Here we have the query, open YouTube. And this is my query, right? Let's get down to it. Now, I would simply use webbrowser.open. What's that? YouTube. It's www.youtube.com, right? It's YouTube. Sorry, not that line. Like that. Or you could just type youtube.com here as well, okay? You can put youtube.com. That would actually work, okay? So, youtube.com. This will actually help me open up YouTube. Now, let's say you have some website that you use regularly, okay? How do you access that particular website through this program? So I would write, let's say I'm going to open, now I'll be using it to open up Great Learning Academy. Open Great Learning Academy. Okay, open Get Learning Academy in query and query. Okay, put up the colon, get down here, goes web browser. Here goes webbrowser.open. Now, what you need to do is that, let me show you. Let me just open up the Google here very quickly. So right here, it goes and. Now what I'm going to do here is that, first of all, okay, there was one more thing. When you're doing that sort of thing, like when you're accessing and when you specify to access the email in Gmail, right? In that case, you need to search for List Secure App Access right here. List Secure App Access. Enter that, go to the respective website, which is Sign In Google Account, okay? Sign In Google Account. Now, you need to check this box. Only then will you be able to send emails using the SMTP library, okay? So great, that's done. What was I doing? I was opening up Great Learning Academy, right? I was just opening that up. So here goes Great Learning Academy. Now just quickly fetch the website and the link for this. I'll close this out from here. Quickly copy it and paste it here in the respective position. And that's quickly done here. So whenever you see Open Great Learning Academy, it will open up Great Learning Academy for you, okay? So I hope I'm very clear about that part. Next, what do I actually need? I would write here ELF, okay? ELF. Now, next, let's say I want to open Google. So here goes Open Google in, and here goes the query. Now, that's Q-U-E-R-Y, right? Now, actually here, I've written webbrowser.open, so now I don't need this os.start, because now we're doing all these things online. We're doing all these things in our browser, right? That's why we're using the web browser library here. Open Google in query, right? Let's get down here. Here goes webbrowser.open. Okay, webbrowser.open. And I would simply write here google.com. Google.com, okay? So it will open Google for me. Great, that's done. Now, let's say I want to ask for the current time. Like, what time is it right now? Let me know. So I would write that, ELF, tell me the time in query. Query is a variable where I'm storing whatever I need to know or whatever I need to open, so that's why I'm mentioning query everywhere, okay? Now, here goes my variable, str_time. Let's say that's equal to, here goes datetime.datetime.now. Datetime.datetime.now. It will help me get the current time. Here goes my str_time. It means it allows me to set my format, and I want the time in the format of %h:, %m:, so hour, minutes, and seconds. Okay, but it will also let you know in the form of, let's say it's 1 p.m., so it will tell you 13. If it's 2 p.m., it'll tell you 14. It'll only let you know in that specific case. Okay, because it doesn't automatically categorize between PM and AM. Okay, that's the reason it can't automatically categorize PM and AM. That's the reason it displays the times as 13, 14, 15, and so on, okay? And then, here's what I wanted to say. I wanted to say, my dear, okay, that's my dear friend, the time is, okay, and what's the variable where we're storing it? That's str_time, my dear friend, okay? So I just write it out, right? F-R-I, okay, just a second. F-R-I-E entry, okay, my dear friend, the time is, and this is the respective time, right? So it will say, my dear friend, the time is, and whatever the current time is, it will say that time here at this particular place, okay? So that's how you access the current time. Next, you have one more thing to access. Let's say I want to open the Great Learning YouTube channel. So I write open, and open Great Learning. L-E-A, okay, that's learning. Open Great Learning YouTube channel. This is the command I would say, okay, in the query. In QUE, in query, fine. Put a colon, go down to the next line. And here, I'm going to write out webbrowser.open. Now, what's the Great Learning Channel website that you want to open up? And secondly, put this out first of all. Now, what I would do is let me quickly go to Google right here, just scroll down. It should be mentioned somewhere down here. I don't really need to go to any other web browser or anything like that in this case. So let's get down very quickly right here. And yeah, here it is, this YouTube, right? So let's quickly click on this YouTube. Fine. So let's see what it's going to open up here for the Great Learning Academy. And yes, here we have this Great Learning Academy. Oh, 1 second, it closed. Fine. So this is how, and you could simply copy that from here, okay? Or I would suggest that you could just use the search here. And let me write here, Great Learning, right? I could simply write that. That would actually be a good idea. Fine. Now I would go to this respective place, pause this, and from here you could copy this website, Control-C, okay? Don't do that directly from the website, otherwise it will take you to some other, it has a slightly different link, okay? So I would recommend that you go from the YouTube search, type Great Learning, and just just copy it from here and paste it at the respective place. Fine. So the channel is set up here. Now, next, what do we have? Now, let's say you want to access any of the social media platforms, okay? That's a very important thing. It's playing an important role in your life right now. So, see, let's say I would write here, I would write a command that is open LinkedIn. Open LinkedIn, okay? Open LinkedIn, and then here goes my query. Fine. Open LinkedIn in the inquiry, so put a colon like this. Get down, here goes my web browser.open, and the link for LinkedIn is .linkedin. Okay, that's linkedin.com. Or you could do one thing. You could search LinkedIn on Google, and from there as well, you could copy the link if you don't know the link to any of the websites or anything. So what you do is go to Google and simply type out the link, and it will take you to the redirected place or redirected page, whatever is needed, okay? So great, that's done, and now I'm left with the very last part of this program, this project, and that is automating my emails. So email to, now here, what we'll be doing is I'll be writing the name of the person I want to send the email to, okay? I will be writing the email or the name of that respective person to whom the email is to be sent, so you have to write only that, okay? Let's say I write email to, okay, let's write email to other friend, okay? Email to other friend, and here goes in the query, and type this and get down. Now here again goes my try statement. Try. First of all, it will ask me, what do you want to send? So it will write out, what should I send? What should I send? It will ask me that. And I will get down, and here I type that content variable that's equal to take command function. What it will do is it will take the command from me. It will simply run, what should I send? And I will speak, send this, or that, okay? We'll do something like that. Fine. So take command in that respective case is going to help us out like that. Getting down now, to is equal to which person. What's the email ID to which you want to send this email? So write the email ID of that specific person you want to send this email to, right? So I'm just writing that out. I just wrote the email ID of the person I want to send this particular email to, right? I wrote that down. Here goes my send email function, which we wrote above. And in the brackets, it goes to, comma. I've declared both what the to is and what the content is, right? And finally, what should it say? It will clearly indicate that your electronic mail message has been transmitted and delivered successfully. This confirmation means your email has been dispatched without any issues and has reached its intended recipient's inbox. Okay, your important email communication has been sent successfully, confirming its proper delivery. All right, everything is in order. After this try statement, we need to add one of the except statements. Except, hold on a second. Let me add one more line space. Here comes the exception. Put the colon, go to the next line, and what should we print? Print my respective exception, whatever I have. And what should it say? It should say, my dear friend, I am unable to send the email. Okay, my dear friend, I'm unable to send the email. Please, I implore you, address the critical error. Okay, please, I urge you, address the significant error, and I will certainly make a detailed note of it. All right, my dear friend, I'm unable to send the email. Please address the error. So that's if any error comes up. So please address that specific error. I'm not able to send the email for you, right? So great. I hope I've made everything about this whole program clear. Everything I've written here about what things are, how we set them up, how we categorize them, and how all of this actually works, right? So now it's time to quickly run these programs and see which functions are working, which ones aren't, and clarify everything. All right, let me do one simple thing very quickly here. Let's right-click and, okay, 1 second. Before that, let me turn up the volume so you can also hear what I'm saying. So here goes, increasing the volume. Great, fine, wonderful. Now let's quickly run this program. So let's click on run. Okay, let's see what it's gonna say. It's gonna take a lot of time. Okay, good.
Evan,
Yes,
let me know. How can I help you? What are you looking for?
open paint. Let's see what it does. It opened paint for me. And now, look at how amazing this project is. Whatever I said here, like let's say I set up that first one, it showed me it was listening first, and then it greeted me with good evening. So, my dear friend, let me know how I can help you. After that, it showed me it was listening to you, Shambhavi. Then I spoke, and it said, recognizing your voice. And my dear friend, you said, open paint. And it just opened that for me, right? Okay, now what I'm going to do is terminate this program because I've already done a lot of speech, and here it will capture all of that. So I'll terminate this from here. Okay, I'll run it again, and now we'll try running 2 or 3 things at the same time. All right, so watch this carefully. Let me go here and close the YouTube channel. And let me close this as well. Let me close this list too. Secure app access as well. Okay, let me close everything. Let's come back and run it really quickly. Listen to it.
My dear friend, let me know how I can help you. What are you looking for?
Open Great Learning Academy. Just give it a moment to open up. Okay, give it some time, because depending on whatever internet connection you have, it will work accordingly. See here, it's continuously loading things, content is showing up, and all those respective things. Let me do one thing. Let me double up the double slash here. Yeah, 1 slash was missing. Let me close this out and click on terminate. Let's run that very quickly.
Good evening, my dear friend. Let me know how I can help you. What are you looking for?
Open Great Learning YouTube channel. So see what it gets? It simply opened up the Great Learning YouTube channel for me, and yeah, here we are on the channel. Well, let me pause this here.
Yeah.
Let me pause this video. Right, so this is it. Yeah, this is the channel for Great Learning. Right, so wonderful. I would now close this out once again here. Let's go on to PyCharm. Let me close it out again because I had set up a lot of things and it'll capture everything. Okay, so let me terminate it here. Now, what I'm going to do is check the current time. Tell me the time. Okay, let's do that. Let's check that as well. Good.
Evening, my dear friend. Let me know. How can I help you? What are you looking for?
Tell me the time.
My dearest friend, the current time is precisely 20:10:48.
LinkedIn, it'll take some time to open these things out. So what I'll do is just close this from here. Okay, I'll make that run or go to something similar like LinkedIn. Yeah, that's right. Okay, fine. All right, so since I think it's taking too long, I'll run that later. First, let me show you the things that are running really quickly according to the bandwidth. All right, now let's do the email. Okay, let's do the email. Good.
Even, my dear friend, let me know. How can I help you? What are you looking for?
Email to another friend.
What should I send?
Say hello. Yeah.
Your email has been sent successfully.
See, it says your email has been sent successfully. Let's go over here. Let's open that up. See, I already have that email account logged in, so I can send emails to whoever I want from it, okay? Since I already have that particular one set up. I'll open it up. I'll go to the sent folder from there. And now what I'm going to do is right here. So I clicked on the email. See, it's showing 8:12 p.m. Actually, it was 0 minutes ago. It means that's the current time when I'm making this video. And here we go. Say hello. The text I wrote in that particular PyCharm project was say hello. And this say hello has been sent to the person whose name or email ID I entered here in this field, right? So we already did Paint. We already did Great Learning Academy too. See, YouTube is just as simple as that too. It'll open up YouTube. It'll open up Google. There's really nothing much to it. Let's open up Google. So let's run it for you. Guide.
Evening, my dear friend. Let me know how I can help you. What are you looking for?
Open Google. So what it will do next is it will just check. It's just opening up Google for me, right? So it's simply opening up that kind of thing, right? Download.http google.com, I would close that out, right? Because I hope you clearly understood what is opening in that particular place, right? So I would close this and terminate it from here as well. Now, what we're going to do is I'll just let you know 1 or 2 more things here that you should know very clearly. Okay, so let's look at this very clearly right here. Okay, so let's do one thing very quickly. Let's run LinkedIn one last time, and after that, I'll just wrap this up. So here for LinkedIn, okay, one thing needs to be done. Make this I lowercase, just like that, and open the LinkedIn tab. Now I'll just run this very quickly. Okay, let's do that. Good.
Evening, my dear friend. Let me know. How can I help you? What are you looking for?
Open LinkedIn. So see what it did? It just opened LinkedIn for me, right? So it opened LinkedIn for me. All right, now I'm going to close this right here at the appropriate spot, and I'm going to end this. Okay, so we ran it, we gave it a quick try in all the cases, and yes, it's working really well, working wonderfully. It's running properly and we just enjoyed it, right? So I hope I've made it very clear with this project how you can create a Python automation project, how you can automate things using the Python programming language. I hope that's all clear now. So I hope you enjoyed this project and that you got something useful out of it by using all these libraries and automating with Python. All right, that's all for this video. Until then, thank you and take care. So let me introduce you to the very first topic, which is the MoviePy library. First, we'll be discussing this library in detail. So what is this library all about? Well, this library was actually developed for video editing purposes. Whenever you want to do some video editing, that's where the MoviePy library, specifically the MoviePython library, comes in. Now, what kinds of video editing can you do with it? You can concatenate videos, you can simply cut a part of a particular video, you can add titles to the video, you can do video processing, and you can create custom effects. So these are all the different things you can do with it, which you can do with the help of this MoviePy library. Okay, so now, what are the Python versions that this library actually supports? So your Python should be 2.7 or above, but the one I would recommend is above 3.4. Okay, so make sure that your Python version is above that, 3.4, and if it isn't, then upgrade it to a newer version, the current version that's available. Or if you don't know how to upgrade it, you can simply uninstall Python and then install the newest version of Python on your device. Okay, so I hope I'm pretty clear about this. Now, whenever you want to do some kind of editing, like if you want to add custom effects, do some video processing, or if you want to concatenate two videos, concatenate means merging the videos, okay? Let's say you have two different videos and you want to merge them together. That's what we call concatenation. So when you want to concatenate, or you want to insert a title, or whatever simple tasks there are related to video editing, if you want to do any of those, so this MoviePy library is one of the most preferred options in all of these cases. Next, there's one more feature of the MoviePy library, and that feature is actually the main reason why we'll be using the MoviePy library in the practical implementation of this Python project. The fundamental reason, the primary justification, is that this incredibly versatile MoviePy library also conveniently lets you effortlessly read and seamlessly write the most widely recognized and commonly used audio and video formats, including, of course, animated GIFs. You possess the remarkable ability to read, to write, and to meticulously perform all these diverse and intricate operations with the invaluable assistance and powerful capabilities of the MoviePy library for virtually all video formats available. And the popular GIF format is certainly included as well. So that is indeed the main and overarching reason why we are specifically choosing to utilize this exceptionally useful MoviePy library in our current project today. What's the main task? What's the goal of the project that we want to convert? Any video format, MP4, MP3, whatever, to the GIF format, right? So for that particular case, what will be my very first step? My very first step is going to be that I have to, first of all, read my file. The complete file that I want to convert, right? Let's say I have an MP4 file with me. Now, I have to read that specific file, and I have to first read it. So whenever you want to convert a file into any other file format, this isn't just for GIFs. It's a general thing. Whenever you want to simply convert any file from one format to another, the very first step is that you have to read that file, okay? And the MoviePy library allows you to read any type of file format. That's the reason we're using this MoviePy library in our practical implementation of our project for converting video to GIF, okay? So I hope I'm pretty clear about this, the reason for using this MoviePy library. Now, I already mentioned that you need to make sure you have a Python version greater than 3.4, okay? Next, what's the installation process? For the installation, you simply have a command which is pip install MoviePy. I'll be showing you the practical implementation for installing the library as well, but here, just for your knowledge, I'm letting you know that the command for installing this MoviePy library is pip install MoviePy, okay? So I hope I'm pretty clear to you regarding this MoviePy library, what it is, what it's especially used for, what its features are, why we're using it in our project today, and the installation process. I hope I'm pretty clear about all of these things. Now, let me take you to the next topic of our discussion, and that's the video file clip function. Okay, let me tell you one thing about this function. This function is only a part of the MoviePy library, right? A few seconds ago, we learned about the MoviePy library, right? So this MoviePy library, this video file clip function is a part of the MoviePy library, okay? So first of all, if you want to use this video file clip function, the very first thing you need to do is import the MoviePy library. After that, you can use this function however it suits you best, okay? Now, I'll talk about this. The video file clip function lets you convert a video into any other format. For example, if you want to convert an MP4 video to a GIF, so the video file clip function lets you do that, okay? Now, next, I'll talk about the parameters. What parameters you have here for this particular function, okay? Let's talk about the parameters. So first, you need the file name. So whatever file name you have that you want to convert to a GIF, you can use that. Okay. Now, if you're just entering the file name, in that case, make sure you also include the extension. Extension means, what is your file format? Is it MP3? Is it MP4? What is it? Okay. Make sure to include that as well with the file name. Second, if you want to specify the path for that particular file, yes, you can do that as well. You can specify the path of any particular file as needed. So either way works. You can provide the file path or just the file name. Any of these options will work for this particular parameter, okay? Next, you have hasmask. Now, this is actually we set that to true only if you have a mask included in your video file, okay? Next, you have the audio. So we set this audio to false if your video file doesn't have any audio, okay? Or simply if you don't want to read the audio. So in that particular case, you set this audio to false, okay? I'll repeat again. You set this audio parameter to false if your video clip doesn't have any audio, or if you don't want to read the audio, okay? In that case, you set this audio to false. Next, you have the target resolution. So you can set the frame, you can set the resolution, you can set the desired height and the desired width. It's up to you, whatever you want the length and width of that video clip to be, okay? You can set that accordingly. Next, you have the resize algorithm. So whatever algorithm is there, if you want to resize it, so you can resize, but by default, the algorithm used is bicubic, okay? So bicubic is the default algorithm that's used. And next, you have FPS source. So whenever you want to get it from the metadata, in that case, you use this _source parameter. Now, among these parameters, there are 2 or 3 parameters that are especially used. The first one is your file name. The second is your audio. These 2 are the ones that are most commonly used when you're working with the video file clip function. I hope I've made this pretty clear to you. Now, this is a function. This is a method, so it doesn't require any installation. As soon as you install the MoviePy library, all these functions automatically become available, and you can use whichever ones you need, okay? So it doesn't require any installation. I've already mentioned the parameters to you, including which ones are most commonly used. So now I'll take you over to my PyCharm IDE, where we'll see a hands-on implementation of a project that converts video to GIF. So let's head over to my PyCharm IDE, and first we'll learn about the installation process. After that, I'll show you the practical implementation of our project. All right, so here we are in the PyCharm ID, and from here, I'll be writing my code and showing you how to import and install everything. Everything will be done right here in my PyCharm ID. Okay, now there's one thing I wanted to point out to you. Like, you can use any integrated development environment that you personally prefer to utilize. If you want to use popular choices such as VS Code, Jupyter Notebook, or Spider, you can use absolutely anything you find comfortable and efficient. But my strong recommendation, however, is that you absolutely avoid using any of the online-based integrated development environments, because specifically for the successful completion of this particular project, you should have a video file readily available with you in virtually any video format that you wish to convert into an animated GIF file. It is crucial that this specific video file resides within the identical folder as your primary Python script file, which is precisely where you will be actively writing and developing your project's code, okay? So now, in that particular case, it's really important for you to pay attention to these things, especially because this can't actually be done on online IDEs. That's the reason I am suggesting you to use up any of the offline IDE according to your sake of convenience. Okay, now what I'll be doing is that I am using PyCharm. So onto this PyCharm only, I have the terminal, and that I can use of that terminal for the installation of my respective libraries. Okay, so I'll be going back or going onto this particular terminal here, and from this terminal what I could do is that you could simply install up the libraries. So command for the installing of my MoviePy library is pip install MoviePy. Okay, this is the command that you have to use out. After writing that command, hit out the enter. Now what it will do, it will install up this particular library for you. It would take up some time depending upon your internet bandwidth, and it will do that out. But for me, the requirement is already satisfied because I have already installed that onto my device. So it is showing me requirement already satisfied. But if you haven't done that particular thing till now, so it will take up some time for you, and after some time, at last it will show you that successfully installed. Okay, so what I would do is that I would zoom in a little and I would write up the command here as well, so that you, if you want, you could refer that out. Pip install MoviePy. Okay, P is not going to be capital, everything is in small only. Okay, pretty fine. Hope I'm pretty much clear with this particular thing to you. Now further getting down, I'll be importing up my library that we installed right away. That's MoviePart. Okay, so I'll be writing up you that from moviepart.editor as moviepart.editor, I'm going to import up the asterisk. What's the first line which I have written? What's the meaning of that? So MoviePart is my library that we all are pretty much aware of, right? I just mentioned of the thing a few minutes before as well, that we just installed out this MoviePy library. Now what we are actually willing to do, we are actually willing to convert up a MP4 format video clip onto a GIF format video clip, right? We are doing up this particular thing. So now onto that simple case, I simply used up this moviepart.editor as well. Okay, I used up this moviepart.editor. So this moviepart.editor will actually help me to do up this particular things. Okay, and now when I wrote import asterisk, so it means that I'm going to import up all of the functions which we have up into this moviepy.editor file. Okay, so when I wrote up here moviepy.editor import asterisk, so import asterisk is simply means that from my moviepy.editor library, I'll be importing up all of the required functions which I have present up into this particular library, because I need those functions, because it's simply a tedious task for you to again and again write import this function or import that function. So at one simple go, you imported up all of your relevant functions which you are having up here. Now further, you can use out any respective function of your choice here. Let me get down. So now here I'll be making up a variable which is convert underscore video underscore name. So what will this variable actually store? This variable will store the name of the video clip which you want to convert into GIA. Okay, I'll be using up here the MP4 format. Okay, you can prefer any of your choice. So simply, I'll be writing up here video file. Okay, that will be a file clip. Okay, video file clip. This will be my respective function name. And that function, I have imported it from moviepy.editor library only. So this video file clip, I did mention about this function a little bit time before to you about this, that what is it actually, how is it used, and what are the things that you're having up here. Okay, so video file clip, right? That's done. Now, into the bracket, you'll be writing up that particular file name, which you want to convert. So I'm having up some MP4 file formats. I want to convert up that MP4 file format, but that particular thing I'll be writing up after the completion of my program. Okay, now let's get down. Now again, I'm going to use up here convert underscore video underscore name. Okay, here we'll be having write underscore GF. Okay, write underscore GF. What is this about? So convert video name, this is respective is your variable, right? And what's this write underscore GF? So this write underscore GF is respectively a function which will help you to write up your MP4 file format into the GIF file format. Okay, this is the use of this particular write underscore GF function. So with this, I simply used up this convert video name variable. Here, the reason is that because this convert video name variable, this is the one which is storing my file, which I want to convert into GIF format, right? Because it is a variable that is storing that which respective what format of file and which respective file actually I want to convert it into the particular GIF format. So now onto that particular keys, you can simply use this out, right? So this video clip file function will store the name for your file format, which you want to convert. And this write underscore GF will actually store the file for you, and you have to give up the name according to your choice as well, that in what's the name for that particular file in which you want to convert that MP4 to GIF format. Okay, so hope I am pretty much clear with this particular thing first of all to you, that what are these functions about, and how do you write up these particular things? Now further, what I'm going to do is that I'm going to write up my video file name, which I'm having up. Now, one thing to make sure is that that particular video shall be present into the same folder where your Python file is actually stored. Okay, for sure it should be there. It should be in that particular folder. I'll repeat again, it should be in that specific folder where your Python file is saved. You should have the Python file where you're writing the code, and your video clips that you want to convert into GIFs should also be in the same folder, okay? So I hope I'm pretty clear about this part for you regarding the writing the program. Now we'll move ahead and write the names of our files, and then we'll convert them and check the final output of this project. Okay, so I hope that up till this particular place, I am pretty much clear to you regarding a complete code, whatever we had written after all right. Now, what's my last task for this hands-on, for this video to GIF project, is that I have to put up my video file name and give up a name that in which name I want my GIF file to be created. And then we'll be running out a program and waiting for some time because it depends that what's the duration of that particular video which you are creating, okay? It might take out some time if you're using a very big video for converting a video to GIF, okay? It might take out. So now what I will be doing up here is that I will be going onto the desktop of my laptop, okay? Now here onto the desktop, I am having up some few files like I hope you are able to see this file and this respective one as well, okay? Let's check out that what's the properties of these files, okay? So if I go into the properties, see, I am having this MP4 file format right now. Right now, what I will do very first of all is that first of all, I'll be copying of these particular files and I'll be putting those onto the location where exactly these are to be. Now, what I just meant out from this particular thing, let me tell you. So, there is a location into which your Python file is saved, in which you're writing the project, right? I hope that you must have that location with you into which you are writing into the file, into which you're writing up your Python code, and that particular file is saved up at some location, some path into your laptop, right? So I have to save up those MP4 files onto the same path where my Python file is being saved, into which I am writing up this code for video to GIF conversion, okay? As in the very starting only, I suggested you and I told you to have an MP4 file format, right? Right now, let I be on telling you that how to put this file onto the location and from where to find out the location. So let's say this lang.py, this is my file into which I'm writing up my code. Okay, I would click on that and I would do the right click. Okay, now right click, I would go and go here onto the copy from here. From here, you can just click on copy path and it will let you know exactly that where your file is actually saved. Okay, so you could find it out from here. Now for me, I'm already aware that where this particular file of me, that is lang.py, in which respective window, in which respective place is a save. Okay, so what I would do, let me open up that desktop once again. Let's say, first of all, I'm going to convert this video. It is a very short video of 26 seconds, and that's from Great Learning itself. Okay, and the video is AI ML Trends in 2022. So let's copy this out from here. I'm going to copy this out with you. And now what I'm going to do is go to the respective destination. So it's Windows C for me, then it's users, it's user, and then I'm in PyCharm projects. And inside that, here is my respective destination. Okay, and great. So I could just do that and minimize other things later, but yeah, it's pretty fine. And I'm going to do Control+V. So have a look at this here. AI ML Trends in 2022. This file has actually come here to this particular location for me. I'm going to once again check out the properties. Let me show you about this. The name is AIML 2022. The type of file format is MP4, okay? And further, it is 26 seconds long. So I'll show you. Gone to details, and from here, you'll be able to know that, okay? The length is 26 seconds. Right away, I'll be showing you 3 demonstrations for the particular output. Now, let me first show you what this is actually about and how this particular file actually looks. So just give me a quick second. Yes, so this is basically what the file looks like. I didn't show you the complete video, but yeah, this is how this particular file looks. Okay, it's a very short video from Great Learning itself. So now that this one is done, I'll do the same thing for my next 2 videos as well. So this one is done, and what I'll be doing next is for most in-demand data science careers in 2022 with Valerie. Okay, so let's copy this video very quickly, and I'm going to go to my respective destination. That's Windows C, and then users. Here I have the users and my Python projects, and here is my folder. I'm going to paste this here. 1 second. So see, here it is. Most in-demand data science careers in 2022 with Celery. Let's check the properties for this now. So here it goes. Okay, let me bring it out here. Great. So yeah, it's again an MP4 file, as I already told you. Most in-demand data science careers in 2022 with Valerie. And as for the details, it's 28 seconds long. Okay, I'm going to click OK, and I could just run this as well and show you what this is and how this video actually looks. Great. Yeah, I hope you're pretty much familiar with this particular video itself, how it looks. Now, where's my third one? I have one more. That's most in-demand digital marketing careers in 2022 with Salary. Okay, let's copy that one out very quickly again. And I'm going to take you down to users, and here's my Python projects, and here's my respective folder, and I'm going to paste the file here. So yes, here we have it. Let me open up the properties for this, and let's have a look. So right away, yeah, it's again an MP4 file. The name is Most in-Demand Digital Marketing Careers in 2022 with Salary. And here are the details. It's 16 seconds long. Okay, great. So yes, these are all my 3 videos that I wanted. I'm going to go to the PyCharm, and now when you check here, you'll see all these 3 videos in this PyCharm folder where my file is being saved. Okay, so let's check for them. Right here, you have most in-demand data science careers, most in-demand digital marketing careers, and there should be some AI/ML. Here it is, AI/ML 20 and 22. Great, see, all of these files are done. What I'm going to do is, first of all, I'm going to work on the very short one. That's most in-demand digital marketing careers in 2022 with Salary. Okay, let's do that. So here, in this particular section, I'm going to enter that specific file name. Okay, I'm going to put in the file name. Yes, see, as soon as I started typing mo, it's giving me the options. I'm going to select the digital marketing one. Okay, because that's the shortest video we have. So yeah, right away I entered the name Most In-Demand Digital Marketing Careers in 2022 with salary.mp4. Okay, make sure you include the file name with the extension as well. Extension means like it's .mp4. So yeah, you have to do the same. Add .mp4. Okay, that's done. Here, inside this write_GIF function, I told you that in this, you're going to write the name that your GIF will have, the one into which the above-mentioned video will be converted. Okay, so I'm going to use GL_GIF1 as my file name. So in this way, you can give your file name as GL_GIF1. Great, so hope I'm pretty much clear with that? Yes. And what will the file format? File format will be .gif. So I have to mention that here, _GIF, 1.gif. Okay, this is how you have to do. And yeah, that's all over. It's the time for running out our project. So let's click on run here. And after that, I would explain your things once again till the time it will take up some time for the conversion. Then I would explain. Okay, so yes, here it's actually getting up converted. Okay, it's getting up converted. As now it is being converted, actually it would show you that process executed with this much number of seconds. Okay, now up till that particular time, I could once again give you an overview that what has been done up here up till this particular place, right? So as told by the slide deck to you, that movie file library is actually helping us to do up all of these particular things. It helps you to convert up any respective file into any other respective file. Command, let's say here we were converting the MP4. So yes, in that particular place, MP4 is getting converted onto the GIF format. Great, that's what is done up here by the file. Now, just have a look that here what it is. It started building a file gl_gia1.gif, okay, with image.io, right? And now see, it is showing you the percent as well, that how much time it's going to take for converting up your file and how much percent is done and all those particular things. It is going to take up the time, right? Till the time I could explain you that what the things we did do, and further we can move with the rest of the things. So here, yes, I was talking about that what I was being done up here. So this respective file, which we are having most in demand digital marketing carriers, that was our MP5. So this movie file library, moviefile.editor, which we are having up here into the Python programming language, that's actually helping me to convert up this particular file into the GIF format, right? So into this, we are having some functions, and with the help of those particular functions only, it is helping me to convert up any of my file formats into my GIF file. Okay, so what could be done up here is that I am having up here like my MP4 file versus most in-demand digital marketing carriers. Great. Now, that particular file which we were having up here, that was an MP4 file. I just first of all wanted that file, that video file names to be put it up here so that we get an idea that which is the file which you want to convert, right? So what I did inside my video file clip function, I wrote up the name with my file format, guys. Make sure that here you are as well writing up your file format, guys, because that's the most necessary thing that you have to do. If you're not doing that out, it might lead you to some wrong output. Okay, so make sure that you are actually putting up the file name with the extension. So I did so, and I saved that particular thing onto our respective variable. Now, after getting saved onto that respective variable name, what is being done up here is that we are converting with the write_GIF function. We are simply converting this respective one into the GI. Okay, that's pretty much done. Now, what I'm going to do is see here. Now, process finished with exit code 0. It means that my file has been converted. How do I check that now? So go to the same location. This is my location. What was my file name? My file name was gl_gif1. Let me zoom in. Where did it go? Right here, right here. Okay, let me copy that out. Let me copy it and paste it onto my desktop here once. Great. And now this is my file that has been converted. I'm going to do it like this, and I'm going to go to the properties to check it out. What's that? That's another type. My file is a GIF. Let me open this up, and 1 second here. Let me take it out. Right. What's my file name? My file name is gif.gif, right? So the name of my file is .gif, and the dimensions are already mentioned up here. Now, why isn't it showing me any duration? Why isn't it showing up? Because it's a GIF file. GIF files don't have a duration because they keep looping again and again. They keep repeating, right? So that's the reason that right here, my GIF file, it's not opening up like this. I'm sorry, I'm not getting any duration for my GIF file. So item type is a GIF file, right? The dimensions are the same dimensions as my original file. The dimensions won't change. Nothing will change, actually. Okay, nothing will change. It will remain as it is. Okay, so I think I've made it pretty clear to you how this is actually converted here. Right, I hope I'm clear about that part. Now, what I'm going to do is go to that specific destination where that file is, and I'm going to double click on this file right away. So let me do one thing. Let me close this from here. Great. And now I could actually, now when you have to open this GIF file, you're going to right click, and after that, you're going to open it with your respective video file format. Whatever is available for you at that particular place, okay? Great. So yeah, I hope I'm pretty clear about that part for you, about converting this into a GIF, right? So whatever respective apps or tools you have that support GIF files and can run GIF files, you can pretty much just convert it and run it as a GIF file, right? So this part should be clear to you. Next, what I'm going to do is change the name of my file, okay? I'll change the name and show you one more example. Let's do it for AI/ML, okay? And here, I'm going to keep the name as 2, okay? And now, this time, I'm going to run this particular project. So again, it's going to take some time to convert the respective MP4 file to the GIF format. Again, it's going to take some time for the conversion, okay? So now, let's start that very quickly here. The conversion will start in a short while because it depends on the video length. Now, this AI/ML twins file was about 28 or 26 seconds, right? So now, see, it is starting building my GIF file here, right? It started. So now it will take some time and it will convert this particular file to the GIF format here, okay? It will take some time and it will simply convert it. So until that point, I hope I'm pretty clear with all these things for you, how these things are done, how they actually take place, what are the ways we can use this, and how you can simply convert any respective file to a GIF file, okay? I just moved that down because it's actually doing its thing. Great. So not only MP4 files, but yeah, you can also use some more video formats, and according to your convenience, you can convert any respective video format to the GIF format. So this is how you can make a project, you can do hands-on for video to GIF. Now, it's not that difficult, right? You just have 3 to 4 lines of code to write here, nothing more than that. Right, so in that case, it works in the same way, but make sure that you're opening your files with an app or software that supports running GIF files, okay? Because as we all know, with GIFs, your file will play and then it will start again and keep running and keep running. It won't stop at a particular point. Like, it doesn't have any ending time, right? GIF files don't have any ending time. They just keep running and running over and over, no matter how much time you have. So make sure you're opening the files in the right software, the kind that actually supports the GIF file format, right? So as soon as the file format has been converted, once the .74 file has been converted to a GIF, we can check it out in our respective folder. But yeah, there's only one important thing about that setup. You have to make sure that the video file you have is actually saved in the same folder where your file is being saved, the file where you're writing the program. The main thing is, wherever your file is being saved, your video file should also be present in that same location. Otherwise, you won't get the output. It'll show you location errors, okay? And yes, I think my file has been converted now. Yes, it has. I'll go to this particular one. Let me close this one. Okay, that's done. And yeah, here's my location. Yeah, it's glyph 2, and I'm going to open this up. I'm going to click on Properties, and yes, now it's my GIF file, .gif, okay? And here you can change it to the respective location where you want to open it, and you can do that accordingly. It doesn't matter, right? You can open it with anything. I'm going to close this out from here, okay? And I'm going to go and click on the details. So yeah, for the details as well, it's exactly the same. The item type is GIF file, and that's the respective folder where the file is, and everything is written there. The dimensions are also the same as what we set, right? Great. So yeah, we're pretty much clear on this part about converting a GIF file. So you can say converting an MP4 file to a GIF file. That's how you can do the text, right? Now let's move on to the summary for this video to GIF file conversion Python project.
Okay, let's take a look at what a QR code is. So QR code stands for quick response code, right? The full form of QR code is quick response code, and it's a machine-readable image that can be instantly read using a smartphone camera. If you have a smartphone camera, yes, you can start reading it. You can start reading any QR code. So what is a QR code? It contains, certain information. Every QR code has a number of black squares. You can see these are the black squares we have, and they're going to contain certain pieces of information, right? And this is how we use a QR code. It's going to take all the information and create a QR code like this. We use QR codes in Paytm, we use QR codes in Google, Google Pay, Paytm, PhonePay, basically everywhere. We know these QR codes work, but how? So basically, these QR code blocks contain certain pieces of information, right? Now, when this code is scanned by a camera, it translates that information into something that can be easily understood by humans, right? Yes. So what's happening here? So basically, a QR code creates a specific block of codes where all the information is stored. And it can be read by a camera. And from that camera, it becomes something that can be easily understood by humans, right? And this is what a QR code stands for. So let's take a look at how we're going to do that. So in order to do that, we're going to install two libraries. One is PyQRCode, right? We have this library in Python. So what is this PyQRCode module? It's a PyQRCode library. It's a QR code generator library in Python. This module automates most of the process for creating QR codes. This module tries to follow the QR code standard as closely as possible. And the terminology and encoding used in PyQRCode come directly from the standard. So these are the basic explanations of this particular library, straight from the documentation. And basically, we use this library to create our QR codes. So what we're going to do is, I've written pip install PyQRCode. This is how you can install it, right? Now, we've installed PyPNG. Why piping? This is for images, to save your image, and to create your image as well. So that's why we've used it, right? So we've installed PyPNG. So what we're going to do is import QR code from PyQRCode. So we've written import PyQRCode, right? I just make it as big as I possibly can. Then what did we do? We imported PNG. Okay. From there, we have PyQR import QR code. Right. Now, what are we going to do? A string, which represents the QR code. Suppose I've given the link for a Great Learning Academy. Let me show you how I get the link. Right. If I just double click over here, right? Can you see what I get? I get www.greatlearning.in/academy, right? So if I just go back, let me show you how it's going to work. Can you see what site I get? I get www.greatlearning.in/academy, right? What I've done here is I've written HTTP, then greatlearning.in/academy. Here, we're going to have a variable called site. Okay, then what you can do is, suppose a particular company has their website, right? They've uploaded their menu over there, right? Since they've uploaded their menu there, what they want now is to use that particular menu using a QR code. Now, how are they going to do that? To make the QR code, what do you have to provide? You have to provide the link for that. Okay, so what are we going to do now? We're going to write a variable called site. Variable equals http://greatlearning.in, because I want to create a QR code for this particular site. All right, now how do you generate a QR code? You just need to write Let me just delete this part. Let me just put it over here, okay? So whatever we've done, we're gonna generate a QR code. How do you do that? Okay. So how do you do that? I've written our specific variable again called URL underscore QR equals PYQR create. So now try to understand. We've used .create. Okay, so we've written pyqrd.create, and then we've written with site. I want to redirect you. So the .create function is used to create the QR code. So what are we going to do? We've written pyqrcode.create, and then we've created the site. Okay, what is that site? What does that site contain? That's where you want to redirect your customers or redirect all your traffic. After you've done pyqrcode.create, and inside it, it will create the QR code. Now, I want to save the SVG file, naming it like here, I've changed the name, right? Okay. Now I'll talk about what is an SVG file. What is K-level? Vector graphics. Okay, this is a term used especially in image processing, you could say, and it's an extensible markup language-based vector image. So this is something you don't need to understand right now, but you can get the idea. We use SVG to get a vector image for graphics, right? Okay, now what am I going to do? I'm going to save it with the PNG file name, right? So here you can see I also get an SVG file, and here I get the created PNG as well. If you don't want, the SVG file, then what can you do? Just comment it out. So if you want to create only the PNG file, what do you need to write in the URL? _QR, where you created your QR code, .png right now. Great, .png. I've given the PNG file a name and set the scale to 5. Actually, I set the scale to 5 or 6 just now. If I want to show you what I got, let me show you. Okay. And if you're using Google Colab and you want to check which files you've saved, whether they're already there or not, there's a box icon over here, right? Can you see this folder? Just click on the box, guys, and can you see that I got both my SVG file and PNG file, right? Let me show you why it's not showing up. Okay, it showed up here, okay.